Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. As we introduce the Fabric service, we'll explore its experiences and how it works with data. We'll also cover how this affects how our data teams work together to solve analytics mysteries. Finally, we'll look at what's required to get started with Fabric. Ready to start cracking some analytic cases? Let's get started. The first mystery we need to solve has two parts to it, so we'll call this case the service and data conundrum. Let's look at the clues related to the services first. Look at this image. First thing you may notice is that there's a lot on here. I need my magnifying glass to see it all. This is a visual representation of all the different services related to big data, machine learning, and AI. While there is some overlap, it's a lot to parse through. But Jason, we're here for analytics, not all this. Well, here are the options that cover data analytics. Still quite a few services that are available. Now imagine we're tasked to engineer an analytics solution. You have choices of open source, proprietary, and even internally developed services. And then I have other considerations like, will these services natively integrate? What about monitoring costs for all these services? Or how secure is my data when sending and receiving from all these services? And do I go with cloud, virtual, or on-prem? It's a lot. Now, Microsoft Azure offers solutions that allow us to build analytics solutions utilizing platform as a service options. But we still need to do some integration of these different platforms, especially when we're dealing with a Lambda architecture, an architecture that requires both batch and streaming workflows. This is where Azure Fabric comes in. With Microsoft Fabric, you don't have to spend all of your time combining various services from different vendors. Instead, you can use a single product that's easy to understand, set up, create, and manage. Fabric offers persona-optimized experiences and tools in an integrated user interface. These tools, or analytics experiences, are designed to accomplish specific tasks and work together seamlessly. Fabric's experiences include Data Factory for data integration, combining Power Query with the scale of Azure Data Factory to move and transform data. Synapse Data Engineering with a Spark platform for data transformation at scale. Synapse Data Warehouse with industry-leading SQL performance and scale to support data use. Synapse Data Science with Azure Machine Learning and Spark for model training and execution tracking in a single scalable environment. Synapse Real-Time Analytics to query and analyze large volumes of data in real time. Power BI for translating data into decisions. And Data Activator, which at this time is in public preview, and it automatically takes actions when patterns or conditions are detected in changing data. So the mystery of disparate services is solved. But what about disparate data? OneLake can help us solve this mystery. OneLake is a unified, logical data lake designed to streamline collaboration and data management across an organization. Much like OneDrive for files, OneLake serves as the central hub for all analytics data. Here are the key clues about OneLake to help solve this mystery. The most significant aspect is the single data lake. Before OneLake, organizations often created multiple data lakes for different business groups, and that led to resource management challenges. OneLake simplifies this by providing a single data lake for the entire organization. Every Microsoft Fabric tenant automatically gets OneLake, ensuring consistency. OneCopy is a key component of OneLake that allows you to read data from a single copy without moving or duplicating data. Next, collaboration and governance. OneLake encourages collaboration while maintaining governance. Within a tenant, you can create workspaces, each tied to a specific region. Workspaces distribute ownership and access policies. Data items within workspaces allow tailored experiences for different roles, like Spark developers. Governance remains intact, but other parts of the organization can contribute to the OneLake. Next, it's open and compatible. OneLake is built on Azure Data Lake Storage Gen 2. It supports any file type, structured or unstructured, and stores data in a Delta Parquet format. Whether data is located via Spark or T-SQL, it contributes to the same data lake. OneLake also supports existing ADLS or Azure Data Lake Service Gen 2 APIs and SDKs. OneLake also allows creating shortcuts, embedded references to other files or storage locations. These shortcuts enable quick sourcing of existing cloud data without duplication. Because of the vast amount of proprietary, open source, and internally developed services, and the complex integrations between these services, often we find that data teams can't collaborate effectively. This creates data silos, and they can be frustrating. Let's look at the case we'll call siloed sleuthing. So here's our siloed data team. Our decision makers need additional items added to a dashboard. So they reach out to the data analyst to create the item. The data analyst is going to need data that isn't available to them, so they contact the data engineer to request the data they need. Turns out the data they're requesting requires a predictive model to generate the data the analyst needs, so the engineer emails the analyst to let them know. The analyst doesn't know how to create a predictive model, so they email the data scientist on staff to develop a model. Now the data scientist needs to get back to the data engineer and request the data they need, which probably isn't clean by the way, which will eventually get back to the data scientist. The data scientist builds the model and emails the analyst to let them know they have a production model ready. But we're just getting started. Now the data analyst has no idea how to implement this model in a real-time scenario. So now the data analyst needs to email the data engineer again to assist in building a real-time analytics workflow for the solution. The data engineer creates the workflow, but finds that the service they selected requires a custom connector in order for the dashboard to receive the data. So now the data analyst needs to find someone who can duct tape all these systems together in order to build this one item in a dashboard. And by the time all this is done, this decision makers needs another minor change and the process begins again. Not to mention that all of this data is being shared in ways that aren't completely secure or requires additional security implementation to provide access to those who may not have had it before. This is how Fabric can weave our data systems together and crack the case wide open. We can break the silo mentality altogether and have all of our data team working in the same platform with the same data and with services that are inherently integrated with each other. Not to mention the ability to modify data accessibility more easily while still maintaining enterprise-level security and government standards. That's an easy case to solve. Our final case to solve we'll call the enablement enigma. If you're interested in using Fabric, you need to know how to enable it. Duh, Jason. Fabric must be enabled in your tenant, either by a Fabric admin, formerly known as a Power BI admin, a Power Platform admin, or a Microsoft 365 admin. Once Fabric is enabled, you need to assign workspaces to either premium per capacity or Fabric license mode. Workspaces are the containers where you store and manage your Fabric items, and OneLake is accessed via Fabric workspaces, so it's pretty important. To access Fabric, you can use the Fabric portal, which is a web-based interface that allows you to navigate between different Fabric experiences. Now it's time to put knowledge to practice. I'd like to introduce the DetectoLab 5000, aka my Surface laptop. Remember that Fabric is a web-based platform, so you don't need a 32 gigabit RAM, GPU accelerated, 1 terabyte SSD, 8-core processor system. to accomplish many tasks in Fabric. I can also work from just about anywhere, although they won't let me leave until I finish. So trust me there. Onward. Welcome in. Let's get started. So the goal of this experience that we're going to share right now is to try to get you familiar with the different, at a high level at least, the licensing options or capacity options that you're going to be dealing with when we're talking about deploying or enabling Fabric into your own environment. So I think the first thing to kind of point out, and this can be a complex decision for you to figure out, depending on whether or not you already have an existing Power BI instance or you need to create a brand new one. And we'll show you, I'll show you what to expect when you're dealing with all this in your own environments. But I think the first thing to kind of cover is the difference between capacities and licenses. So a capacity is an infrastructure for Fabric. This comes with compute power, right? So our compute power is essentially the capacity. The one lake is the storage, but we need to process our semantic models. We need to do, you know, our Spark or SQL engine type of compute querying, and there's engines underneath of this. In order to utilize that capacity, we would enable a Fabric capacity. And you can see that the stock keeping units or SKUs for this, for Fabric, are F capacities. If you've ever dealt with Power BI capacities, they're similar to what this looks like. There's P1 and up. And you can see here that an F64 capacity matches a premium capacity. So what does this mean? This means that if you want premium features in your Fabric capacity, which are nice to have, especially at enterprise level scenarios, then you'll want a F64 capacity or higher. If you don't get those premium features in there. You can still create Fabric items, but if we're dealing with large amounts of data and some other collaborative or premium feature services, you won't have access to those. Now, licensing is a little bit different. So licenses, if you've ever dealt in the Power BI world, you got your free license, which just comes when you sign up for, when you have a Microsoft 365 account, a pro license, which allows sharing between individuals. And then you have your premium per user, which again comes with these premium features. Now, this is different than Fabric, right? These are Power BI licenses. And I believe what you can do is if you already have a premium per user or one of these individual type licenses, you can actually try Fabric on a trial basis, but eventually you're going to have to get Fabric capacity in order to work with the Fabric environment. But at least you know, or at least this tells you some of the things that you can and can't do in Fabric with a certain level of Power BI licensing. So feel free to pause, take notes if you want to, if this is what you're dealing with. Same thing with the capacities. Go back, pause, look at those, and then come back. So how does this affect my stuff, or what am I going to experience when I'm dealing with these? So I'm going to go into my personal account. This is my, I have my browser associated with a personal account. It does have a, and I'm going to navigate to Power BI. It does have a work email associated with this from a Microsoft 365 license that I created. So I do have a work account, which means I have a tenant. The problem is that I don't have a Power BI license with this. So it's already prompting me to go ahead and do a Fabric free license. This will allow me to utilize Power BI from a free aspect, but I won't be able to create Fabric items, right? This will just allow me to do this. So if you experience this screen, this means that you essentially don't have a Power BI license, and it's telling you to deploy a Fabric workspace so you can use Power BI, right? For the free version, the free license version of it. Then you can upgrade it to the pro or premium per user or whatever, and still will have to utilize Fabric. And that's the next aspect that I wanted to show you. We'll go back into my environment. We'll go into Power BI. Now, a couple things I want to point out here is that I have a My Workspace. Let's go to all my workspaces. So I have different workspaces here. I have a My Workspace, which is my personal workspace. And then I have this embedded test one, which is Power BI premium content. And you can see here that I actually have this PBI training as Fabric content. So this is already enabled with Fabric. I can go into my workspace settings and change this, by the way, and I'll just do it to show you how this changes the effect of the licensing. So I have a, hold on. Oh, this is my workspace. That's why I'm not seeing that. So let's go into here and we'll do the workspace settings on this. And you can see that under the premium content, I have a Fabric trial. Let's switch this to my pro license, right? And we'll apply this from right now. And what you'll notice is that once that's done, when I go back into my workspaces, there's no designation here, not even for premium content. If I go back in here and I change my workspace settings to my premium per user, and close out of this, I have a diamond here that represents premium content, but you can see it's a Power BI premium per user content. So what does this mean? I got premium access, right? I can start creating stuff. Well, not necessarily. This gives me Power BI premium content, but if I go into a Fabric experience, say Data Factory, and I try to create a data pipeline, it's going to prompt me to go to start a Fabric trial. So it's not enabled for Fabric yet. So I need to make sure that it's enabled in this trial format. So what I need to do is I need to go back into my workspace. I can go in my workspace settings, and then I can try the trial. You can see that the trial is good for 60 days. After that point, they're giving you a taste of it, that the taste of working with Fabric. And then you can go select a capacity in order for you to do this. And that's the third part of this, is to create a capacity. And that's what we're going to do. You can see here is what right now, and we deploy capacities through Microsoft Azure. And I already have the ability to do this through here, but just so you know, you can do a search for Fabric, Microsoft Fabric here. And then what I'm going to do is I'm going to create a new Fabric capacity. So I have my subscription. I have a resource group here, which I'm using called Fabric Demo. We'll call this Data Detective. I got a brand uphold, right? And since my tenant is deployed in the West US 3 region, it's going to default me or automatically assume that this is the region I'm going to put this in. Now, what's the benefit of this? Well, one thing is that if you have regulatory requirements that require you to keep your data in certain regions, remember your OneLake is deployed in the region that your Fabric capacity is deployed in. So if we're tied into regulatory requirements of keeping data in place, then I can deploy several capacities in different regions, and then we're adhering to those regulatory requirements, which is awesome. Right? So I don't have to configure a whole bunch of different things in order to set this up. I just create a new capacity in a new region. That data stays in that region. I can look at that data. I can read the data in from it if that's what I need to do, but the data's staying in there. It's residing in that region, and we're not moving it out of there, hopefully. We can also change the capacity size. So I mentioned that premium capacity requires an F64, and that's what we're going to use here. Now, you may also notice the cost of this, and your mind is getting blown away, especially if you're a single user wanting to do this. Now, remember, this is for using premium capacity features. If you wanted to go with a smaller SKU, you can. The other thing about deploying a capacity is that these capacities are on demand, meaning I can pause it. I'll show you what that means when I get the capacity created. I like the settings of this. You can also see that we're selecting a Fabric capacity administrator. It could be me. It could be somebody else that's in the tenant itself. So they will know in the tenant who we can apply to that if I wanted to change this. So I could select a different admin if I wanted to. We'll review it. We'll create this. We'll let the magic of editing fast forward this through, although it doesn't take too long. But we'll let this create and we'll come back. Okay, so it looks like, our resource is created. So I'm going to go to the resource and just show you that, yes, look at this. So now I have the ability to pause this. It's on right now, so I'm being charged for it. This is for our compute. Remember, I can pause this. I don't lose any of the data, right? We're just pausing the compute experience for this particular instance. But there's some things that I can do from here, like provide some access control options. I can scale this up and down so that I don't have to delete and create a new instance in order for me to upsize or downsize my capacity. Maybe I overestimated how much capacity I need. We deployed it. We're finding that we're not using, we're using like 20% of the capabilities of the capacity itself. So I might want to scale that back a little bit. If we're using like 80% of the capacity, or we're always tipping out, or we may be experiencing throttling, something of that nature, then we might need to scale that up. But I don't need to run through this whole process over or risk deleting things in order for me to get a new capacity. I just scale it up or down, which is awesome. So this is where we're going to leave this for now. We'll initiate this into Power BI later, but I do want to take a quick tour through the web-based experience, just so that you have an idea of where things are going to navigate to. One of the first things I'm going to do here is I'm going to take off that filter so that you can see up at the top, because I'm going to start here and move along to the side. So first thing you notice here are navigations, right? So, or notifications. So anytime alert is triggered, if we delete items, if we create items, certain things that happen, those create notifications, those show up here. We also have our settings. We'll get to these in another video, but this is where I can control a lot of the settings within the entire Fabric browser software as a service. There's also apps and other things that we can download directly from here that are free, like Power BI Desktop, data gateways, whether those be standard or organizational ones, paginator reports, Power BI for mobile, and then updates to analyze in Excel, or you can download Power BI for PowerPoint, or even a OneLake file explorer, which lets you navigate your OneLake files without actually being in the browser itself. So this is an app that gets downloaded on your machine. We connect into it, and then we can browse through those things. So if you're looking to, get access to your data without having to open up a browser experience, you can do that using the OneLake file explorer. Finally, there's some help and support topics if our users need it. You can always provide feedback to help improve Fabric. And then you can see here that we're going through that there's different hubs, and this changes for different experiences. So down here are our experiences, right? And we'll go through these in another lesson, but these are all of our experiences within Fabric. And you can see here that when I'm in the Power BI experience, there's a few more things that are located in here. And when I change to a Fabric Data Factory experience, there's some other things that are located within here, but the ability for me to create these objects, right? Now that I do have Fabric enabled on this, I should be able to create this object, right? It's letting me create a new pipeline. If I went into a workspace that didn't have a capacity and I try to create something that's like a warehouse, it's going to tell me to upgrade to Fabric trial license, right? So different experiences on the side. When we're in these experiences, we just go to the home page and it takes me to the navigation for that particular experience. Several common things that we would do in each one of those, with Data Factory, with data engineering, with data science, with data warehousing, so on and so forth. So all of these are going to have common links that you can utilize, object creation in general. So these are all general ones, and I think Power BI is the only one that has some more specific stuff for like deploying apps for reports and things like that. But that's how we navigate through the browser experience itself. So that kind of puts a wrap on what I wanted to show you here.
Let's head back into the studio.
Congratulations, detectives. You have successfully solved our analytics mysteries. You learned what Fabric is and why you need it, how data teams use Fabric to collaborate on data projects, and how to enable and use Fabric in your own organization. You also learned how Fabric leverages OneLake, a lake-centric architecture that allows you to read data from a single copy without moving or duplicating data. And you also learned about different Fabric experience like data factory, data engineering, to perform different data tasks and scenarios. Fabric is a powerful and flexible product that can help you solve any analytics mystery with a unified product experience, security and governance, compute and storage, and business model. Thanks for joining. Imagine that you're a detective and you have a case to solve. You need to find out what's going on with your data, how it's being used, and who's behind it. You also need to administrate your skilled team of fellow analytics investigators. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Let's discover the suite of features and high-level architectural concepts of Fabric, as well as how to manage and secure your Fabric environment as an admin. You ready to solve some mysteries? Let's get started. Before we dive into how to administer Fabric, let's take a step back and understand what Fabric is and how it works. In our first case, we'll introduce you to the missing architecture, where we'll learn about key concepts and terms that you need to know to work with Fabric. Let's get started. Microsoft Fabric is an all-in-one analytics solution for enterprises that covers everything from data movement to data science, real-time analytics, and business intelligence. It offers a comprehensive suite of services, including data warehousing, data engineering, data integration, data science, real-time analytics, and business intelligence. The foundation of the platform is based on software as a service, SaaS, which provides a simple and integrated approach. All of the Fabric experiences use OneLake as their native store without needing any additional configuration. OneLake is hierarchical in nature to simplify management across your organization. There's only one OneLake per tenant, and it provides a single pane of glass file system namespace that spans across users, regions, and even clouds. The data in OneLake is divided into manageable containers, easy for handling. The OneLake that rules them all. Okay, jokes aside, that closes that case. But on to our next mystery. How does Fabric conceptualize this architecture? Let's look at the clues. A Fabric tenant is a dedicated space for organizations to create, store, and manage Fabric items. There's often a single instance of Fabric for an organization, and it's aligned with Microsoft Entra ID. The Fabric tenant maps to the root of OneLake and is at the top level of the hierarchy. Capacity is a dedicated set of resources that's available at a given time to be used. A tenant can have one or more capacities associated with it. Capacity defines the ability of a resource to perform an activity or to produce output. Different items consume different capacity at a certain time. Fabric offers capacity through the Fabric SKUs and trial offerings. A domain is a logical grouping of workspaces. Domains are used to organize items in a way that makes sense for your organization. You can group things together in a way that makes it easier for the right people to have access to the right workspaces. For example, you might have a domain for sales, another for marketing, and another for finance. A workspace is a collection of items that brings together different functionality in a single tenant. It acts as a container that leverages capacity for the work that's executed and provides controls for those who can access the items in it. For example, in a sales workspace, users associated with the sales organization can create a data warehouse, run notebooks, create semantic models, create reports, etc., etc. Fabric items are the building blocks of the Fabric platform. They're the objects that you create and manage in Fabric. There are different types of items, such as data warehouses, data pipelines, semantic models, reports, and dashboards. Understanding Fabric concepts is important for you as an admin because it helps you understand how to manage the Fabric environment. Let's explore the case of the Fabric admin, the unsung hero who keeps the Fabric platform running smoothly and securely for your organization. Whether you need to manage security and access control, data governance, customization and configuration, or monitoring and optimization, Fabric has a tool for you. Let's get ready to crack the case of the Fabric admin. There are several roles that work together to administer Microsoft Fabric for your organization. If you're a Microsoft 365 admin, a Power Platform admin, or a Fabric Capacity admin, you're involved in administering Fabric. The Power BI admin role will transition to become the Fabric admin at some point, so be aware of that. As a Fabric admin, you work primarily in the Fabric admin portal. You may also need to familiarize yourself with the Microsoft 365 Admin Center, the Microsoft 365 Security, and Microsoft Purview compliance portals, Microsoft Entra ID and the Azure portal, PowerShell commandlets, and administrative APIs and SDKs, or software development kits. As an admin, you may be responsible for a wide range of tasks to keep the Fabric platform running smoothly. One of the most important aspects of Fabric administration is managing security and access control to ensure that only authorized users can access sensitive data. You can use role-based access controls, or RBACs, to define who can view and edit content, set up data gateways to securely connect to on-premises data sources, and use Microsoft Entra ID to manage user access. Effective Fabric administration requires a solid understanding of data governance principles. You should know how to secure inbound and outbound connectivity into your tenant, and how to monitor usage and performance metrics. You should also know how to apply data governance policies to ensure data within your tenant is only accessible to authorized users. Fabric administration also involves customizing and configuring the platform to meet the needs of your organization. This could include configuring private links to secure your tenant, defining data classification policies, and adjusting the look and feel of reports and dashboards. As a Fabric admin, you need to know how to monitor the performance and usage of the platform, optimize resources, and troubleshoot issues. This includes configuring monitoring and alerting settings, optimizing query performance, managing capacity and scaling, as well as troubleshooting data refreshes and connectivity issues. Specific tasks may vary depending on the needs of your organization and the complexity of your Fabric implementation. You need to familiarize yourself with a few tools to effectively implement the tasks outlined above. Fabric admins can perform most admin tasks using one or more of the following tools: the Fabric admin portal, PowerShell commandlets, admin APIs and SDKs, and the admin monitoring workspace. Fabric's admin portal is a web-based portal where you can manage all aspects of the platform. In the admin portal, you can centrally manage, review, and apply settings for the entire tenant, or by capacity. You can also manage users, admins, groups, access audit logs, and monitor usage and performance. The admin portal enables you to turn settings on and off. There are many settings located in the admin portal, but there's one setting that we'd like to call out, which may change how you and your users experience Fabric. The Fabric on-off switch, located in tenant settings, lets organizations that use Power BI opt into Fabric. Here you can enable Fabric for your tenant or allow capacity admins to enable Fabric. Fabric provides a set of PowerShell commandlets that you can use to automate common administrative tasks. A PowerShell commandlet is a simple command that can be executed in PowerShell. For example, you can use commandlets in Fabric to systematically create, manage groups, configure data sources and gateways, and monitor usage and performance. You can also use the commandlets to manage the Fabric admin APIs and SDKs. What are those things? Well, an admin API and SDK are tools that allow developers to interact with the software system programmatically. An API, or Application Programming Interface, is a set of protocols and tools that enable communication between different software applications. An SDK, or Software Development Kit, is a set of tools and libraries that helps developers create software applications that can interact with a specific system or platform. You can use APIs and SDKs to automate common administrative tasks and integrate Fabric with other systems. For example, you can use the APIs and SDKs to create and manage groups, configure data sources and gateways, and monitor usage and performance. You can also use the APIs and SDKs to manage the Fabric admin APIs and SDKs themselves. Fabric tenant admins will have access to the admin monitoring workspace. You can choose to share access to the workspace or specific items within it with other users in your organization. The admin monitoring workspace includes the feature usage and adoption semantic model and report, which together provides insights on the usage and performance of your Fabric environment. You can use that information to identify trends and patterns and troubleshoot issues. The Microsoft Fabric Capacity Metrics app is designed to provide monitoring capabilities for Microsoft Fabric capacities. You use the app to monitor your capacity consumption and make informed decisions on how to use your capacity resources. For example, the app can help identify when to scale up your capacity or when to turn to auto scale. And this app is obtained through AppSource. Now, let's investigate how to secure our data and analytics environment with Fabric. If you want to protect your data from bad actors and ensure compliance with regulations, this is the case for you. Let's get started by looking at the first layer of security, licenses. Microsoft Fabric security is based on Power BI security. Your role as an admin is to manage security for the Fabric environment, including managing users and groups and managing how users interact with Fabric items in terms of sharing and distribution of content. When considering security, you can look at it at several layers of protection that a bad actor will need to penetrate before getting to your precious data. Some of these layers are your responsibility to implement, like at the network, workspace, item, and within each item. Fabric, as a software as a service, does provide some built-in security sleuthing, such as encryption for data in transit and at rest, and using Microsoft Information Protection to apply sensitivity labels to your data. You can also enhance your data governance with an epic team-up with Fabric and Microsoft Purview. Licenses control the level of access and functionality that users have within the Fabric environment. Administrators can ensure that licensed users have the necessary access to data and analytics to perform their roles effectively, while also limiting access to sensitive data and ensuring compliance with data protection laws and regulations. Managing licenses allows administrators to monitor and control costs by ensuring that licenses are allocated efficiently and only to users who need them. This can help to prevent unnecessary expenses and ensure that the organization is utilizing its resources effectively. Having the appropriate procedures in place to assign and manage licenses helps to control access to data and analytics, ensuring compliance with regulations and optimize costs. License management for Fabric is handled in the Microsoft 365 Admin Center. As an admin, you can manage how users interact with Fabric in terms of sharing and distribution of content. This includes managing how users share content with others and how they distribute it content to others. You can also manage how users interact with items, like data warehouses, data pipelines, semantic models, reports, and dashboards. Items in workspaces are best distributed through a workspace app or the workspace directly. Granting the least permissive rights is the first step in securing the data. Share the read-only app for access to the reports or grant access to the workspaces for collaboration and development. Another aspect of managing and distributing items is enforcing such best practices. You can manage sharing and distribution both internally and outside of your organization in compliance with your organization's policies and procedures. Okay, so we have a license and shared access. How do we know what data is approved for use? It's time to unlock the clues in the case of the endorsed assets. Content endorsement is an essential governance feature that helps you establish trust in your data assets by promoting and certifying specific Fabric items as trusted and approved for use across the organization. All Fabric items can be endorsed except for dashboards. Endorsed assets are identified with a badge that indicates they've been reviewed and approved. Endorsements help your users know which assets they can trust and rely on for accurate information. And it also helps you, as an admin, manage the overall growth of your items across your environment. There are two types of endorsements. Promoted Fabric content appears with a promoted badge in the Fabric portal. Workspace members with the contributor or admin role in the workspace can promote content within it. The Fabric admin can promote content across the organization. Consider this like a thumbs up for your fellow detectives. Content certification is a more formal process that involves a review of the content by a designated reviewer. Certified Fabric content appears with a certified badge in the Fabric portal. The certification process is managed by an admin and can be customized to meet the needs of your organization. If you aren't an admin, you need to request item certification from an admin. Data lineage is the ability to track the flow of data through Fabric. Like a series of clues, data lineage allows you to see where data comes from, how it's transformed, and where it goes. This helps you understand the data that's available in Fabric and how it's being used. Metadata is the data that describes other assets, including data, kind of like the key to a codex. Metadata scanning facilitates governance of data by enabling cataloging and reporting on all the metadata of your organization's Fabric items. The Scanner API is a set of admin REST APIs that allow you to scan Fabric items for sensitive data. You can use the Scanner API to scan data warehouses, data pipelines, semantic models, reports, and dashboards for sensitive data. And the Scanner API can be used to scan both structured and unstructured data. Great work, detectives. We've unlocked the mysteries of Fabric architecture, concepts, and administration. Now it's time to roll up our sleeves. Well, I don't have sleeves, but that's all right. Open up the Detecto Lab 5000 and weave, get the Fabric reference there, these concepts into our Fabric environment.
All right, back in. So up to this point, we've enabled Fabric, we've created a Fabric capacity, and we already know that we have a tenant, right? I can't create a capacity without a tenant. So the tenant and capacities are already defined, right? These are the things that we've discussed in the content. So the tenant we've defined. We defined a capacity. We created that capacity earlier, and then we called it the data detective capacity. So the next level down is a domain, right? So a domain there could be several domains that are contained within a capacity. So how do we create a domain? Well, you got to be a Fabric admin in order to do that. Fortunately, I am. And then we're going to go into our settings pane here, and we're going to go into the admin portal. Now, there's other settings that we'll go through here first, but I want to talk about domains, right? So if I go into domains, I can create a new domain. And I'm just going to call this domain 1, right? And then I'm going to add a admin. And that's going to be me. So I'll administer this domain. So now this domain is created. I could create another domain. So I'll call this domain 2. And if I have other users that are in here, then they could be the admin itself. I do have other users that I created for this purpose, but I'll stick with myself because I only trust myself in these domains right now. So now I have a couple domains. If I go into an actual domain, I can create subdomains because I can associate now workspaces with domains or subdomains and then change the settings on these so I can manage these domains once I'm in there. So this is all handled through the admin portal, right? I can go back into domains and I can manage my domains as I do that. So I can have several domains with a single capacity, right? Or associate this with workspaces that have a capacity assigned to them. Domains, you don't necessarily have to have a capacity in order to have domains, but you're going to have a Fabric capacity that is associated with this. So ergo, you'll need a capacity. So next level down are workspaces, right? So workspaces, we've kind of gone over, we had our PBI one, but I'm going to create a new one because although I created that capacity, I don't have any workspaces that are associated with this. So I can't create items until I have a workspace with it. So I'm going to create a new workspace and we'll call this Data Detective workspace. And then I can also assign this to a domain, which I will assign to domain 1. And you can also see under the Advanced tab is where I can select my license mode. So I got a Pro, I'm in trial right now, which is great, but I do have a Fabric capacity, right? So I'm going to select that. You could see that it even resolves, because I could have several capacities, but I only got one right now. So I can resolve this to whatever capacity I need to, and then associate it with different domains. You can see how this goes, right? And subdomains of different domains. And then I can always go back and change these workspace settings if I want to, but I'm going to go ahead and apply this now. So now I have a Fabric capacity. You can see that this has a domain. It's part of a domain. It's part of Fabric content. So I should be able to create Fabric licenses within this. So what are the items that I can create with here? Well, if I go into create, this gives me a lot of what I can do. This is just Power BI. And if I go into create, you can see every time I go into a different experience, then I can create different items. So these are the different items associated with the different experiences. Remember, we talked about Fabric experiences. So Power BI is a Fabric experience, Data Factory, Data Activator, Data Engineering, Data Science, Data Warehouse, Real-Time Analytics. Some of these are in preview. Some of these are generally available. Refer to documentation on that. But every time I switch to a different experience, it's going to allow me to create different items. And that's everything that I can create within here. Data warehouses just happen to be their own license or own items. So I could create data warehouses in here. I can also change administrative settings within my portal as well. Oh, it's still creating another domain. That's what this notification is giving me. So instead of showing you all of the admin settings, I'll go through some of them. If you are a Fabric admin or a tenant admin, then you should be able to go into the tenant settings and be able to navigate through and set some of these for you. But you can see that there's Fabric ones, and these are anything that's in a preview feature right now may be generally available at some point, just at the time of this recording there in preview. So keep that in mind, that preview items, if it's in public preview, then they're testing it out, which means that it may not work with every integration that's possible in Azure or Microsoft at this point. So they're slowly putting it out to production level reach, and then they'll make it generally available. Help and support settings. So if you remember up here in the help and support, I can actually change what my users see in there from a tenant level. So I could post different things in there or change some of those settings. I can change the way that domain admins function within this. and workspace settings. There's information protection settings that are within here, exporting, sharing settings. I think we did go over the promoted and certified type of documents. Certified is more of the organizational, or there's usually a designated administrator that certifies certain documents, and that's an explicit person that does that. Endorsement of a promotion is just a thumbs up from a colleague saying that this is a good data set that you can work with. So export and sharing settings, a lot of those enabled in here. Discovery settings, application settings, integration settings. So if we want to use XMLA endpoints, things of that nature, then we can do that as well. There's also some other Power BI visual settings and some other auditing, monitoring, other settings that we can do. You can also see that in my capacity settings that I can view my different licenses or capacities that are available to me within my tenant. So if I have Power BI premium ones, I can view that. I do have an embedded capacity. It's paused right now. So I can pause those as well as Fabric capacities. Any trials that I may have, and then any Fabric capacities that I have. And I can manage those from here. So I can see what my utilization is from them and work with them from there. Finally, I got workspace management if I need to, but for the most part, this is about the tenant settings and the ability for users to create Fabric items. And you can enable and disable these. Sometimes when you enable them, you can enable them for specific security groups that you define, or they can be available to the entire organization. All right, for things like that. So the last thing I want to show you in this demo is the ability to use and I'm going to open this up real quick and move this out of the way, is the ability to use PowerShell commandlets to do certain things. So PowerShell is more of like a management type deal where we can create assets and work with or manage assets that we've already created within our environments, or sometimes we can create those assets or whatever. So if you know how to use PowerShell, then it's great. Now, what we are going to do here is we're going to utilize PowerShell commandlets through Cloud Shell. Why? Because it already has all the PowerShell libraries, the PowerShell or the Power BI PowerShell libraries installed on it. So I should be able to go in here and do some things. I'm going to do a real simple one right now. But what Cloud Shell does is it actually logs into, it automatically authenticates me into Azure. So I can look at all my resources that are in Azure instead of me having to do on my local machine an AZ account connection, which would require me to enter my password and all that information in there. This automatically logs me in. Plus, this environment itself has all the PowerShell libraries installed on it. So I don't have to go install these libraries into my local machine either. So it's a real benefit to utilize this. So what I'm going to do first is, since I'm already logged in, I'm just going to log into my Power BI account. So this is my login to my Power BI service account. Now what it's going to have me do is it's going to have me open up a new window and insert this code, which I'll copy right now, to log this device into here. So now I'm going to paste this code in, and this is essentially authenticating me. I'm going to give it my email. Yep, continue. And now I should be able to utilize PowerShell in here. Boom, boom, boom. All this popped up. So just to show you a simple way of doing this. So if you have the Power BI libraries installed on your local machine, you connect into Azure using the connection string values with PowerShell. Then I can do something like, getting my workspaces. I can add users to workspaces. So here it's telling me all the workspaces that I have in my Power BI environment right now under this tenant, right? So I have the PBI training workspace. I have the embedded test workspace, which I showed you, and then the fabric capacity one, which is on its own capacity. You can see that. And I even have this one on a dedicated capacity because it was because I have a trial set on it. So all of these do have a dedicated capacity to them. You also notice that a My Workspace isn't included in this, and that's because a My Workspace is kind of like your own personal playground. You can't really share assets from out of it. But hopefully you kind of get the feeling for how we can utilize PowerShell commandlets. So instead of opening up a browser, if I'm only on my local machine, I have access to secure Wi-Fi or whatever that looks like, and I need to manage some Power BI assets, then manage Power BI assets or Fabric assets. I can go in and utilize PowerShell commandlets to list things, add things, delete things, update things, do other things with the PowerShell commands instead of actually opening up the portal and going there doing it. So that does it for the administrative part of this. Hope you got a lot out of it. Let's head back to the studio.
That's it, detectives. We introduced you to some of the features and benefits of Fabric, a cloud-based data platform that allows you to access, analyze, and share data across your organization. We unlock clues about Fabric architecture and concepts, and close the case of administrative practices regarding users and data. Thanks for joining. Remember those days of visiting the summer lake house, the swimming and boating expeditions, the summer sun, and your cruel cousins? Nah, me either. Welcome, detectives. My name is Jason Richards, Microsoft technical trainer and data detective, and we won't be talking about summer lake houses, but rather Fabric lake houses. We'll unlock mysteries like what they are, how to work with them, and even more important, how to secure them. First things first, what's a lake house? Our first mystery we'll call the Lakehouse case. Pretty simple. A lake house presents as a database and is built on top of a data lake using Delta format tables. Lakehouses combine the SQL-based analytical capabilities of a relational data warehouse and the flexibility and scalability of a data lake. Lakehouses store data in all formats and can be used with various analytical tools and programming languages. As cloud-based solutions, lakehouses can scale automatically and provide high availability and disaster recovery. Let's look at some of the benefits. From the data lake perspective, lakehouses offer scalable, distributed file storage and the ability to use flexible on-read schemas as opposed to predefined schemas. From a data warehouse perspective, lakehouses support ACID transactions, which we'll talk about in a little bit, through Delta tables and a SQL endpoint for native SQL querying, as well as the flexibility of using Spark. A lakehouse is a great option if you want a scalable analytics solution that maintains data consistency. It's important to evaluate your specific requirements to determine which solution is the best fit. Now that you understand the core capabilities of a Microsoft Fabric Lakehouse, let's investigate the clues on how to work with Fabric Lakehouses. Before you can create a lakehouse, you create a workspace in the Fabric platform and configure your workspace to allow Fabric resources. You create and configure a new lakehouse in the data engineering workload. Each lakehouse produces 3 named items in a Fabric-enabled workspace. The Lakehouse item contains storage and metadata where you interact with files, folders, and table data. This interaction happens through the Lakehouse Explorer interface. The SQL Analytics endpoint is a read-only SQL endpoint through which you can connect and query data with Transact SQL or T-SQL. The semantic model is an automatically created default data model based on the tables in the Lakehouse. Power BI reports can be built from these semantic models. The Lakehouse Explorer enables you to add and interact with tables, files, and folders in the Lakehouse. When a Lakehouse is created, a tables and files folders are created. We'll cover that case in a bit. This is where you can also work with the data using Apache Spark and other data engineering tools. Another way to work with data is with the SQL Analytics endpoint. The SQL Analytics endpoint is a pseudo warehouse that is automatically generated from a Lakehouse in Microsoft Fabric. A customer can transition from the Lakehouse Explorer to the SQL Analytics endpoint with a quick selection. The SQL Analytics endpoint is read-only, which is different than the warehouse item, which is read-write endpoint. So data can be modified through the lake view of the Lakehouse using Spark. Via the SQL Analytics endpoint of the Lakehouse, the user has a subset of SQL commands that can define and query data objects, but not manipulate the data. This allows actions like performing queries, creating views, inline table functions, and procedures to encapsulate your semantics and business logic in T-SQL, as well as manage permissions on the objects. The SQL Analytics endpoint can also be leveraged through some familiar SQL tools like SQL Server Management Studio, Azure Data Studio, the Microsoft Fabric SQL Query Editor. Okay, Lakehouse Explorer and SQL Analytics endpoint allows me to work with the data in the Lakehouse. What about this semantic model you mentioned? What's that all about? Let's unlock the mystery of the semantic model mayhem. Every time a SQL Analytics endpoint is created, Fabric creates a default semantic model for analysts and business users to connect to for reporting. A semantic model has metrics that are used to create reports, and semantic models are automatically kept in sync with the data lakehouse, so you don't have to worry about maintaining them. You can also create custom semantic models to meet your specific needs. In Power BI, a semantic model is always required before any reports can be built. So the default semantic model enables quick reporting capabilities on top of the warehouse. Let's look a little bit more into this default semantic model. A default semantic model inherits business logic from the parent lakehouse, which initiates the downstream analytics experience for business intelligence and analysis. New tables in the Lakehouse are automatically added to the default semantic model. Users can also manually select tables or views from the Lakehouse that they want included in the model for more flexibility. Objects that are in the default semantic model are created as a layout in the model view. For report readability purposes, it's always a good idea in the semantic model to rename columns to more user-friendly names, as well as hide objects that users won't need to view. Semantic models, case closed. Now, let's uncover the clues of data. OneLake will obviously serve as our central data repository, but what about if I have data in cloud storage already and don't want to copy it into OneLake? Can we solve the case of not my data? Of course! Shortcuts are objects in OneLake that point to other storage locations. The location can be internal or external to OneLake. Shortcuts appear as folders in OneLake, and any experience or service that has access to OneLake can use them. Shortcuts behave like symbolic links. They're an independent object from the target. If you delete the shortcut, the target itself remains ineffective. If you move, rename, or delete a target path, the shortcut can break. You can create shortcuts in lakehouses and Kusto Query Language or KQL databases. Furthermore, the shortcuts you create within these items can point to other OneLake locations: Azure Data Lake Storage, Amazon S3 Storage, Dataverse, and even Google Cloud Storage, which is in preview at this time. When creating shortcuts in a lakehouse, you have to understand the folder structure of the item. Lakehouses are composed of two top-level folders: the Tables folder and the Files folder. The Tables folder represents the managed portion of the lakehouse, while the Files folder is the unmanaged portion of the lakehouse. In the Tables folder, you can only create shortcuts at the top level. Shortcuts aren't supported in other subdirectories of the Tables folder. If the target of the shortcut contains data in the Delta Parquet format, the Lakehouse automatically synchronizes the metadata and recognizes the folder as a table. Now in the Files folder, there are no restrictions on where you can create shortcuts. You can create them at any level of the folder hierarchy. Table discovery doesn't happen in the Files folder. A lot's been covered, detectives. Oh, actually, I want to take that part out.
Which part?
That paragraph. A lot's been covered.
Okay. And,
So
and the 3-second hold?
yeah,
Okay.
this is what I didn't know we were doing chapters in this, so I put like inherent breaks in there, but I forgot to delete that one.
All right, cool. Do you want to start at chapter 3 or?
Yeah, we can. Yeah, that's exactly where we can
All
start.
right, perfect. We'll continue in 3, 2.
Now, hopefully, you have a better understanding of lakehouses in Fabric, but more questions come up. How do we ingest data into the lakehouse? How do we explore and transform the data once it's in the lakehouse? And finally, how can we analyze and visualize the data using Power BI and the default semantic model that the lakehouse provides? Let's crack the case of worrisome workloads. First, let's look at the clues on ways to load data into a Fabric lakehouse. You can upload local files or folders to the lakehouse. You can then explore and process the file data and load the results into tables. Another option is to import and transform data from a range of sources using Power Query Online via Dataflow Generation 2 and load it directly into a table in the lakehouse. You can use notebooks in Fabric to ingest and transform data and load it into tables or files in the lakehouse. Also, you can utilize pipelines to copy data and orchestrate data processing activities, loading the results into tables or files into the lakehouse. After loading data, you can use various tools and techniques to explore and transform it. Let's uncover the clues. Each Fabric lakehouse can use Spark pools through notebooks or Spark job definitions to process data in files and tables in the lakehouse using Scala, PySpark, or Spark SQL. Scala, call it whatever you want. Notebooks are interactive coding interfaces in which you can use code to read, transform, and write data directly to the lakehouse as tables and/or files. Spark job definitions are on-demand or scheduled scripts that use the Spark engine to process data in the lakehouse. We also have our trusty SQL Analytics endpoint through which you can run transact SQL statements to query, filter, aggregate, and otherwise explore data in lakehouse tables. In addition to using a data flow to ingest data into the lakehouse, you can create a data flow to perform subsequent transformations through Power Query and optionally land transform data back into the lakehouse. Finally, data pipelines orchestrate complex data transformation logic that operates on data in the lakehouse through a sequence of activities. Now remember that semantic model? You can use a default or a custom semantic model as the source for a Power BI report that enables you to visualize and analyze the data. By combining the data visualization capabilities of Power BI with the centralized storage and tabular schema of a data lakehouse, you can implement an end-to-end analytics solution on a single platform. Mystery solved. Okay, time to change hats from investigation to security. First up, the data in OneLake. Keep in mind that your OneLake is an object storage resource, fully integrated with Fabric, and OneLake uses a layered security model built around the organizational structure of experiences within Microsoft Fabric. You essentially use Entra ID along with options within Fabric workspaces and items themselves to apply security. Let's look at this from each level in the lakehouse. Fabric lakehouse permissions are granted either at the workspace level, item level, and within the lakehouse itself. In the workspace settings, you can choose between 4 different roles. These permissions should be reserved for collaboration for all items within the workspace, not only the lakehouse. The Lakehouse is a single item within the workspace, so access can be controlled at this level as well. You can grant access directly to the Lakehouse within Fabric, or you can grant access to be only used with the SQL Analytics endpoint. This access means users can connect to the SQL Analytics endpoint with other tools like SQL Server Management Studio to query the data. You can share items via link, and as you create this link, you select the permissions for the audience, like the ones shown here. The People in Your Organization link allows people in your organization to access this item. It doesn't work for external users or guest users. The People with Existing Access link generates a URL to the item, but it doesn't grant any access to the item because they already have access. The Specific People link allows specific people or groups to access the report. If you select this option, enter the names or email addresses of the people that you want to share it with. This link type also lets you share to guest users in your organization's Microsoft Entra ID. You can't share to external users who aren't guests in your organization. Once you've created a shareable link, you can manage permissions and provide more advanced access options. Depending on the item being shared, you may find different set of permissions that you can grant to recipients when you share it. You can also grant object-level security by using the SQL Analytics endpoint and T-SQL to further control what users can access. You have the ability to use built-in roles or custom roles, and those typically involve grant and revoke permissions. And always remember to use the principle of least privilege when considering access. Leverage permissions accordingly, and keep in mind that you can apply these permissions to Entra ID groups as well as individuals. Enough talk. Let's apply knowledge to practice and revisit the trusty Detecto Lab 5000. Let's Lakehouse.
Okay, back in our environment. So what we're going to do now is we're going to create a lakehouse. We're going to do a few things in here. The goal of this is to create a lakehouse. We're going to show you the security settings that we can apply at workspace level and then individual item levels. And then we're going to take it a step deeper and we're going to create a shortcut into an external data lake account. To show you how shortcuts work and how easy it is to apply a shortcut into the Fabric environment. So the first thing that we're going to do is create a lakehouse. We're going to build all this from scratch, right? Eventually, we're going to load data in here, create semantic models, and do reporting and analytics through this lakehouse. But for now, we're just going to create the lakehouse and show you some of the security settings in here. So I am in my Fabric content enabled, domain enabled, workspace, which is named Data Detective, and we're going to go ahead and create a new lakehouse. And I'm going to get real fancy with this name here. I'm going to call it sample LH, and we'll create this. Oops. So we'll do that sample LH1 and create. This is what happens when we test this stuff out. I got to practice before I get in here, right? Can't just do that. So now I have this, and that's it. I mean, all I did was just name it, and it created this for me. You can see that it's deploying a SQL Analytics endpoint as we speak, so I don't have to configure any of this. It's already created my lakehouse. My lakehouse is attached to the OneLake. And then you can see it already adds a tables folder and a files folder. And this is where we'll apply our shortcuts later on. Now, to navigate through this, let's go ahead and navigate through this. You can see that the SQL Analytics endpoint is created. What can we do with this lakehouse once we have it? Well, I can refresh the screen. Also, by the way, you can see that all these different items show up. When we're in our workspace, different items that we brought up in a different browser window, I can bring these up and navigate back and forth through them. One of these is the endpoint, and one of these is the lakehouse itself. Right. So in the lakehouse, I can refresh the screen. I can change settings, the lakehouse settings. I can get data through uploads or different ingestion options that we'll go through in later exercises. I can create a new semantic model, should be a default one. And then because we're in the lakehouse version of this, I can open up notebooks and use Spark or Spark SQL or the different languages within notebooks in order to transform data or load data in here and work with it in that way. Then I have my SQL endpoint. So if I don't want to deal with Python or Spark or Scala or some of those other languages that I might not even be familiar with, all I know is SQL. There is a SQL Analytics endpoint, so there's a different screen for this. You could see that it gives you that nice, comfy, cozy feeling of being in a SQL environment where we have our schemas, our security options. I can create new queries. I can create visual queries, which are essentially no-code ways of viewing data utilizing a SQL endpoint. So not only can I programmatically use SQL, but I can create a visual query. And a visual query allows me to build, drag and drop tables there and do what I need to do in order to filter and join and aggregate certain items. So a no-code option as opposed to just writing SQL. All right. So Lakehouse, we have our analytics endpoint. Let's go back into the actual Lakehouse itself so I don't get that error again. And we'll talk a little bit about security. In order to do that, we're going to go back into our workspace. Now, if I go into here and I look at my manage access, you can see that I have 2 users. Now, these users are part of my Microsoft 365 account that I've added in here. So we got Vidi Vigilante and we got Gary Gumshoe. I got Gary applied to a viewer role, and I have Vidi at a contributor level role. So what we're going to do is we're going to see how these built-in roles apply to the Lakehouse items in our environment. I can add people. I can change their access. So this, as an admin, I have these types of abilities to manage access into my workspace itself. And a workspace administrator can do this as well. So even if I add other workspace admins, they could do the same thing. But what I want to see is how this affects my permissions within this item itself. So at the Lakehouse level, let's look at that. If I go into the More Options tab, I can view Manage Permissions. And then we can see from a Lakehouse perspective, what I can do. So I can read, write, execute from this level. Really, the only thing I can't do from a permissions perspective from a contributor role is reshare content, so I can't share it out. And I can't view the logs, so I can't perform audits on things that are happening within the environment. As a viewer, all I can do is read and view outputs. View outputs means just whenever I have a notebook open, there's an output that's displayed. I can read those outputs as well, or view those outputs, or read data from the files and tables. But I can't write back to it. I can't execute things. I can't do things like that. I can, however, if you notice, under the viewer role, there's going to be these 3 little more options, and I can add read all. They still won't be able to write, so that we're still at a read level with this. But this allows me a little bit more flexibility to say, if I want this individual to be able to read all the information that's associated with their certain file or table, I can add that permission in there. That gives me the flexibility to add permissions and override the built-in ones. So this is the Lakehouse itself. What about the analytics endpoint? Now, we kind of looked at those permissions in the content, right? The read data, read all, those. There's also other permissions that are located within this. But again, I can't really change the contributor one because they have the read all. But if I needed to add a read all to Gary's permissions, I can do that. So again, I got flexibility to override built-in permissions with this. And then finally, from our semantic model, remember, a default semantic model is always created whenever we create a Lakehouse, and then we can always create other ones. But let's look at the permissions in here. So just the workspace viewer, it goes by, because we're in a Power BI kind of context when we're talking about semantic models, it just goes by the workspace permissions because that's initially what these were designed to handle, were Power BI permissions. So those are our permissions. Also, because we have contributor permissions, we can add certain, we can add additional access again, to semantic models for this. So I guess bottom line is, since we have these granular permissions, always follow the least privilege rule, meaning you want to only give permissions to what this individual or group of individuals should be having access to. And then you can granularly add access, or you can change a built-in role permission. By the way, this doesn't just apply to users. If you have a group in your intra ID tenant, meaning that I may have a bunch of users that are associated with a group email, those groups can also be applied to certain workspace roles, ergo these other permissions as well. How does this apply to my SQL analytics? Well, let's go back in here, because you can also see that I have another layer of security that I can apply within the actual SQL endpoint, which is essentially a Lakehouse type warehouse. But there are security roles that I can apply to this. So there's some built-in roles here. So if I want to take this permission granularity to, if you've been in the SQL world and work with databases, this is how we apply roles into databases. So from a database perspective, I can apply certain granular roles to certain databases once I create them in this warehouse. So if I have dozens of databases that I've created within this warehouse, then I can apply certain permissions to certain databases. So that gives me that extra layer of granular protection that I can apply to the users based on their intra ID email accounts. So this is more flexibility and granularity within the permissions that I have. So that pretty much covers the permissions part. Now, shortcuts. So we'll load persisted data into our OneLake here at some point down the road. But for right now, I wanted to show you, since we're here and we talked about it in the content, to actually get some data in here externally, or linked externally. So what I'm going to do is I'm going to go in the files. Why? Because I don't have any tables created necessarily in this storage account that I'm going to be referencing in this shortcut. So we're going to go under files here, and we're going to create a new shortcut. So all I did was right click on this, and we'll create new shortcuts. And you can see all the options here. So it's not just data lakes in Azure. I have S3 buckets or Google Cloud Storage, the Dataverse. So if we have Power Platform lists and objects within there, I can also reference those. And what I've noticed is that in the world of data, that cloud providers tend to play nice with each other when it comes to integrating with their services from a data perspective, because everybody kind of understands that a lot of large organizations are dealing with multiple clouds, and they're going to need access to this. And I don't want to have to create some custom connector in order to access data in a object level storage solution. So I am going to connect to a data lake storage here. I have one that's already, I could create a new connection if I wanted to. In order to create a new connection, I could create a URL, and that's the endpoint into a certain data lake. So here, if I looked at this DDALDS data lake here, I have a data lake storage endpoint, and that's what it's really looking for, is that, right? And then we can create a new connection, give it a name, and then what kind of authentication I want to apply to it, whether that's a shared access signature. If it's already in my organization, I can use that. Let's say I have, if I'm working with clients and they have their own storage accounts, they can provide me temporary access through a shared access signature that allows me certain permissions into that storage account, so I could read data in from there. And then if we could also apply service principals to cloud-based objects and get authentication in that way. But since I've already created this connection in here, I'm just going to use it. But it was that DDALDS, right? And you can see here that it found my data lake, and now I'm going to navigate through here. And what I'm going to do is I'll navigate into the sales file, and I'll just check mark this. Now this has CSV data in it, JSON data, and Parquet file information in here, but we'll go ahead and click next, and then we'll create this. And that's it. That's all it took for me to create the shortcut. Now when I go in here, You can see that I have my CSV data, my JSON data, my Parquet data. So these were years of data. This is properties. I can go in here and I can explore this stuff now. So this is just an item in a JSON object. In my CSV, I can open up the CSV and look at that information as well. And I haven't loaded this into my OneLake. I'm literally accessing this from this external account. So it's connecting to this account and loading the data in. You can see that it can't preview Parquet data, but all this other information I can view and see. And then from here, I could create tables out of these, load them up into my tables, and then start creating my own semantic models or whatever. So we don't necessarily have to import a bunch of data into our OneLake. Yes, it's a great place for our central repository of data that we want everybody to work with, but I can create shortcuts into certain items like lake houses and then be able to access external storage without me having to copy it and move it into my OneLake. So that does it for this exercise. Let's head back into the studio.
Congratulations, detectives. You have successfully solved the mysteries of fabric lakehouses. You learned what they are, how to create and configure them, how to work with data and them using various tools and techniques, and how to secure them using different levels of permissions. By the way, if you happen to have a summer lake house without the cruel cousins, hit me up. Thanks for joining. Great analytics detectives solve analytics-related mysteries using the power of Microsoft Fabric and Apache Spark because you have a secret weapon, your trusty notebook. No, not the one with paper pages, but the one where you can write and run code in multiple languages, combine text, images, and charts, and collaborate with other detectives. With this notebook, you can harness the distributed processing capabilities of Spark and the rich set of libraries available for data engineering and analytics. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Let's uncover the clues on how to use Spark and Fabric to load, transform, and query data using data frames in SQL, as well as how to create stunning visuals to reveal insights from your data. Ready? Let's begin. Before you can start your investigation, you need to set up your Spark cluster in Microsoft Fabric, where you can manage the configuration and environment of your cluster. This is the mystery of the cold case cluster. Apache Spark is a distributed processing framework that enables large-scale data analytics by coordinating across multiple processing nodes in a cluster. Put more simply, Spark uses a divide and conquer approach to processing large volumes of data quickly by distributing the work across multiple computers. The process of distributing tasks and collating results is handled for you by Spark. You submit a data processing job in the form of some code that initiates a driver program, which uses a cluster management object called the Spark context to manage the distribution of processing in the cluster. In most cases, these details are abstracted. You just need to write the code required to perform the data operations you need. Spark can run code written in a wide range of languages, including Java, Scala, a Java-based scripting language, Spark R, Spark SQL, and PySpark, a Spark-specific variant of Python. Most data engineering and analytics workloads are accomplished using a combination of PySpark and Spark SQL. In Microsoft Fabric, each workspace is assigned a Spark cluster. An administrator can manage settings for the Spark cluster in the Data Engineering Science section of the workspace settings. Specific configuration settings include the node family, which are the type of virtual machines used for the Spark cluster nodes. Currently, memory-optimized nodes are the only option. The runtime version of Spark and dependent subcomponents to be run on the cluster. Spark properties are specific settings that you want to enable or override in your cluster. The Spark open source ecosystem includes a wide selection of code libraries for common and sometimes very specialized tasks. Since a great deal of Spark processing is performed using PySpark, the huge range of Python libraries ensures that whatever the task you need to perform, there's probably a library to help. By default, Spark clusters in Microsoft Fabric include many of the most commonly used libraries. To set additional default libraries or persist library specifications for code items, you need workspace admin permissions to create an environment and set the default environment for the workspace. The environment item in Fabric is currently in preview. There you have it. Having ready-made cluster options at your disposal is essential for solving mysteries that require special clue cracking settings. Whether you need to crack a case that involves interactive exploration and analysis, or automate a process that ingests and transforms data, Fabric has the tools you need. You can use notebooks or Spark jobs to run your code on Fabric clusters and leverage the power of Spark to handle large-scale data processing. Let's dive into the details of these options and see how they can help you solve the case of what we'll call the enigma of execution. To edit and run Spark code in Microsoft Fabric, you can use notebooks, or you can define a Spark job. When you want to use Spark to explore and analyze data interactively, use a notebook. Notebooks enable you to combine text, images, and code written in multiple languages to create an interactive item that you can share with others and collaborate. Notebooks consist of one or more cells, each of which can contain markdown formatted content or executable code. You can run the code interactively in the notebook and see the results immediately. If you want to use Spark to ingest and transform data as part of an automated process, you can define a Spark job to run a script on demand or based on a schedule. To configure a Spark job, create a Spark job definition in your workspace and specify the script it should run on. You can specify a reference file, for example, a Python code file containing definitions of functions that are used in your script, and a reference to a specific lakehouse containing data that the script processes. All right, so the enigma of execution is a closed case. Flexibility in executing Spark code just adds to our capabilities to solve analytics mysteries. Now let's investigate how to work with data in a Spark data frame, a data structure that enables you to process large volumes of structured or semi-structured data efficiently. This is the case of the distributed data frames, and we're on it. Ready to get cracking? Let's go. Natively, Spark uses a data structure called a resilient distributed data set, or RDD, but while you can write code that works directly with RDDs, the most used option for working with structured data in Spark is the data frame, which is provided as a part of the Spark SQL library. Data frames in Spark are similar to those in the ubiquitous Pandas Python library, but optimized to work in Spark's distributed processing environment. In a Spark notebook, you could use the following PySpark code to load the file data into a data frame and display the first 3 rows. The first row of the CSV file contained the column names, and Spark was able to infer the data type from each column from the data it contains. You can also specify an explicit schema for the data, which is useful when the column names aren't included in the data file, like this CSV example. Specifying an explicit schema also improves performance. Now, the examples we show here are for CSV, but the Spark engine can natively load in several file formats, including JSON and Parquet. Now that we have our data on our notebook, time to use our deductive capabilities to interrogate, manipulate our data to reveal their secrets. For example, the following code example uses the select method to retrieve the product ID and line item total columns from the data frame named DF containing product data. In common with most data manipulation methods, we want to make sure that when changing a data frame, we want to apply a new variable name so as not to overwrite the existing data frame. Here, we set a name of price list _DF on the left side of the equal sign to make that happen. You can also chain methods together to perform a series of manipulations. For example, this code chains the select and where methods to create a new data frame containing the product ID and line item total columns for products that had an order quantity of 1 and 2. To group and aggregate data, you can use the group by method together with aggregate functions. For example, the following PySpark code counts the number of products for each order quantity. Any changes made to the data frame are saved in memory, so it's always a good idea to occasionally externally save your transform data to ensure if something should happen, and everything fails at some point, then you have the peace of mind knowing it's externally saved. The following code example saves the data frame into a Parquet file in the data lake, replacing any existing file of the same name. The Parquet format is typically the preferred file format that you'll use for further analysis or ingestion into an analytical store. Parquet is a very efficient format that's supported by most large-scale data analytics systems. In fact, sometimes your data transformations requirement may simply be to convert data from another format, like a CSV file, to Parquet. Partitioning is an optimization technique that enables Spark to maximize performance across the worker nodes. More performance gains can be achieved when filtering data and queries by eliminating unnecessary disk input-output. To save a data frame as a partitioned set of files, use the partition by method when writing the data. The following example saves the data frame DF and partitions the data by year. The folder names generated when partitioning a data frame include the partitioning column name and a value in a column equals value format. So the code example creates a folder named data that contains the following subfolders: year of 2020 and a year of 2021. Each subfolder contains one or more files with the product data for the appropriate year. Here, our data frame only contained 2 years of data for 2020 and 2021. If there were more years of data represented in the data frame, then the partition by function would create additional folders for those years. Now here's where this gets exciting. When reading partition data into a data frame, you can load data from any folder within the hierarchy by specifying explicit values or wildcards for the partition fields, saving computational time and costs. Way to go, detectives. We cracked the case of the distributed data frames. Spark is a very flexible programming language, but what about our fellow detectives that only work with SQL? Never fear, Spark SQL to the rescue. Spark SQL is a powerful library that lets you work with data using SQL expressions. Spark SQL enables you to create and query relational data objects in the Spark catalog, such as views and tables, and Spark SQL gives you the flexibility and performance you need to crack any case. Let's dive in. The data frame API we worked with earlier is part of a Spark library named Spark SQL, which enables data analysts to use SQL expressions to query and manipulate data. The Spark catalog is a metastore for relational data objects like views and tables. The Spark runtime can use the catalog to seamlessly integrate code written in any Spark-supported language with SQL expressions that may be more natural to some data analysts or developers. It's important to note that Spark SQL can only be used when the data is in a format that allows for SQL querying, meaning tables and views. One of the simplest ways to make data in a data frame available for querying in the Spark catalog is to create a temporary view as shown in the first code cell here. This view is temporary, meaning that it's automatically deleted at the end of the current session. You can also create tables that are persisted in the catalog to define a database that can be queried using Spark SQL. Tables are metadata structures that store their underlying data in the storage location associated with the catalog. In Microsoft Fabric, data for managed tables is stored in the table storage location shown in your data lake, and any tables created using Spark are listed there. You can create an empty table, or you can save a data frame as a table by using its save as table method, like shown in the first code snippet. Deleting a managed table also deletes its underlying data. Additionally, you can create external tables. External tables define metadata in the catalog, but get their underlying data from an external storage location, typically a folder in the file storage area of the Lakehouse. Deleting an external table doesn't delete the underlying data. As a note, you can apply the same partitioning technique to Delta Lake tables like we did with the Parquet files earlier. Partitioning tables can result in better performance when you're querying them. There are different ways we can use Spark SQL to query data once in the proper format. In this first code block, we see that we're using PySpark and its SQL function to include a SQL string value in the argument that contains the query we run or run. This requires us to display the results, so if our detectives are more familiar with Pythonic language, this is just right. For detectives who prefer to use native SQL to query data, there's another option. The percentage SQL line at the beginning is called a magic operator and tells Spark that the language used in this cell is going to be SQL. You can select the language you want to use as a default in the toolbar of the notebook interface, and then use a code magic operator to override that choice for a specific cell. Pretty nifty, huh? Rest assured, SQL sleuths, that Fabric isn't leaving you out of the fun when it comes to analytics detecting. Sometimes the best way to solve a mystery is to look at the clues in a different way. That's where data visualization comes in handy. Data visualization is the art and science of presenting data in a graphical form that reveals patterns, trends, and insights that might be hidden in plain text or numbers. This is the case of the vexing visualizations. Are you ready? Let's go. One of the most intuitive ways to analyze the results of data queries is to visualize them as charts. Notebooks in Microsoft Fabric provide some basic charting capabilities in the user interface. When you use a display method on a data frame or run a Spark SQL query in a notebook, the results are displayed under the code cell. By default, results are rendered as a table, but you can also change the results to view a chart and use the chart properties to customize how the chart visualizes the data. The built-in charting functionality in notebooks is useful when you want to quickly summarize the data visually. When you want to have more control over how the data is formatted, you should consider using a graphics package to create your own visualizations. There are many graphics packages that you can use to create data visualizations in code. Python supports a large selection of packages, most of them built on the base matplotlib library. The output from a graphics library can be rendered in a notebook, making it easy to combine code and visuals in the same place. The matplotlib library requires data to be in a pandas data frame rather than a Spark data frame, so the toPandas method is used to convert it. The code then creates a figure with a specified size and plots a bar chart with some custom property configuration before showing the resulting plot. You can use the matplotlib library to create many kinds of charts, or if preferred, you can use other libraries like Seaborn to create highly customized charts. All right, we're visualizing the finish line, detectives. Spark is just one way of working with data in Fabric, and we'll cover other methods as well. Now that we've collected all our clues in solving Spark-related mysteries, we can hop right back into the Detectolab 5000, aka my Surface laptop, and put knowledge to practice. The game is afoot.
All right, everybody, welcome back to the environment. We're working with Spark here, so a lot of concepts to cover. Let's cover it real quickly. So I'm in my workspace, and when we work with our Spark pools are assigned by workspace. So when I go into workspace settings, this under the data science and engineering is where I can manipulate these. Now keep in mind that at the time of this recording, this is how the user interface is set up. Just know that sometimes these options get moved around and things like that based on feedback and other items. So don't think that just because it's here doesn't mean necessarily it's going to be there if you're working on it later on down the road. Just pointing that out. All right, so what are we working with when we're working with Spark? We're working with pools of virtual machines, essentially. So several virtual machines that are executing the work on our behalf. So we'll always get a starter pool or default pool for everybody, and they name it starter pool. I can create workspace pools if I wanted to. So I can go in here, I can give it a name. I can memory optimize means that it's CPU enabled. And then I can vertically select the size for each of the virtual machines for each node. Now, small, as you get larger, there's more RAM and memory included in these. And for, larger data workflows or more complex data operations like experimentation and model building, we may want to use larger sized nodes for that. That's the vertical way we can scale up or down these, by the way. After we create one, we can go in, management, drop it, scale these on demand. Horizontal scaling is another way we scale, and that's adding another virtual machine essentially to perform the work. So we're doubling the work. So each one of these nodes represents its own virtual machine. Here we're telling it to auto scale. So when the job is submitted to the Spark engine says, well, I probably need this many nodes in order to perform this work the most efficiently. It's got an optimizer in that. So it may deploy only 2 nodes. If I have auto scale, it may deploy up to 10 depending on that. So this is another way that we're kind of releasing some control in order for Spark to self-optimize that. Once I have a pool created, then I can do things like add an environment. It comes with a default environment. I can set libraries in that environment if I need to. And there's some other settings, like if several users or services are going to be utilizing this compute option or this pool, I can enable high concurrency, just meaning more users can use it at the same time. And then automatic logging, which is MLflow enabled logging for machine learning experiments and models. All right, good stuff. Now, in order to open up a notebook, well, you can either go into the data science or the data engineering experience. I'll just go into data engineering since that's kind of the focus of this course anyway. And I can import notebooks or load existing notebooks in here. Now that I've already imported one, but you can get it from your local system once you have it in there. So when I go back into the workspace, you can see that I can open up the notebook from here. Now I won't get into notebooks necessarily in this particular demo because we're going to cover notebooks in another one. But I will kind of say that, the Spark engine or the different languages that we can use, so Python, Scala, SQL, and R in here, you can see that the default for this one is set to Python. That's the code that's being used in here. And you can see some of the other options that we have set in here. So we'll go ahead and stop this session just because I want to show you what happens when we execute a cell. So I have canceled this session on here. Obviously, I come in here and practice this and see what errors might happen when these get executed. But when I execute my first cell, it'll attach to a session. How long would this take in another type of platform service? It can take 3 or 4 minutes, but you can see here that my session started in about 3 to 5 seconds. This is the benefit of having that one node on all the time. So what I'm doing here, and I'll kind of go through what the Python is telling, or I'll tell the story of the Python as we're doing this if you're not a Python expert. Totally understandable. This isn't the only way to have to work with data in here. There's several other ways. So if you're more of a SQL person or just understand logic, we got solutions for you. This is just one way of doing things. But what we are doing is importing libraries. So just because we have them installed on the runtime doesn't mean that it's attached to the session yet. So we need to make sure that we install these. So matplotlib is a visualization library, so a C-born. And then we're also importing pandas, which is a Pythonic data frame manipulation. So it creates data frames. They're just pandas data frames. Good to point out that pandas data frames do not equal Spark data frames. This is a Spark engine. If we created a Spark data frame, some tools like matplotlib can't work with Spark data frames natively. So we'll have to convert those into a pandas one. And if there's other Python libraries that are dependent on pandas data frames, they won't work with Spark data frames and vice versa. So you got to keep that in mind when we're working with this kind of information. So I've imported these libraries. Now what I'm going to do is I'm going to get this data set, right? Oh my goodness, I found an error. I thought I handled all these. Well, errors happen. And this is fine. All that happened here is that it can't find this module. And I can do a quick fix on this, right? So I'm going to add a code cell above here, and I'm going to do a pip install real quick of that. So pip install Azure ML open data sets. So this is a quick fix. Oops. Pip install Azure ML dot. Oh, probably because I didn't spell data sets right. See how syntax matters? But hey, you know what? This is what happens when we run live demos too. Live recorded demos, whatever. Anyway, so what this is doing now is it's installing this Azure ML.open datasets package onto the runtime so that I can execute it later. Now this is happening in the session. So it's attaching it to the in-memory session. The library isn't necessarily installed on the runtime itself all the time. So I would have to literally run this, execute this every time I want to do this. So this would be one of those things that I would maybe want to go ahead and add that library into my environment later on. I hope that installed it. Yep. So now what's happening? Now I'm not getting the error, so obviously it did install. And you can see that what we're doing here is from that library I just imported, Azure offers a bunch of publicly available libraries. You can see this is the New York City yellow cab data set. And then I'm importing some datetime parsers or ways to, this declares datetime objects, and this allows me to create arguments from those types of, a datetime object, right? So what I'm doing is I'm setting this parser, and what I'm doing is I'm setting an end date and a start date. So you see I'm using the end date in arguments in the actual New York yellow taxi cab data. When I run this method, you can see that I'm inserting the start date and end dates. These are called variables. When I place something next to an equal sign and run a function on the other side of the equal sign, I'm essentially assigning this to this variable. So that means I just don't have to write this whole thing out when I want to declare something like this. So this saves me coding space, right? So I'm setting two variables here, which is a start date and an end date. And then I'm executing a method called New York City yellow TLC, whatever the TLC is. So when I execute this function, it's going to import this data set for me. But I don't want to import the entire thing. So I'm saying just import where I've defined the start date and the end date, right? So it's only going to load a month's worth of data, it looks like. Also, I'm converting this to a Spark data frame, right? And then what I'm doing here is I'm using a display method to output this. Now, when I use a display method, it generates a nice rich output for me. And because of that, I can view it as a table, and I could view this as a chart. So this is one of the visualization options we can actually use, right? I can manipulate this. I can create custom charts if I want to, meaning I can change the type of chart that I want to create. So instead of a bar chart, I could say a column chart, and I could switch the keys and values and any aggregations I want to apply to it, as long as it has the data to run that in there. So this is one way that we can create visuals in here, is by displaying this rich HTML output and then convert these. And then I can take these images and download them, export them out, and use them in reports if I wanted to. But I also have a visual in here. This is always good to perform on-the-fly analytics of what visually is happening to the data. Sometimes it helps us understand that a little bit better. All right, so now what am I going to do with this Spark data frame now that I have it? I'm validated, so this is my sanity check. I know that it converted this into a Spark data frame. I'm seeing it. Now what am I going to do with it? What I'm going to do now is I'm going to use SQL context. Now, yes, the Spark engine essentially way down at the bottom and the foundation of it in that engine is a SQL engine, right? So it's built at a lot of these other data frame packages and everything else are built on top of this. So there is SQL at the base of this. So what we can do is we can use Pythonic code to apply SQL methods. So that's what this SQL functions library allows us to do from PySpark. And then I'm importing everything. And then what I'm doing is just applying methods that are associated with this library, which are very familiar to some SQL statements, right? Select. So select is a SQL statement. And I'm selecting certain columns out of this table or out of this data frame. Sorry, let me correct myself in there. I'm also parsing out information of some columns and then renaming them other names. So that's what alias does. So this would be as, like an as statement in SQL. The filter is like a where clause, right? So dot filter is like a where clause. And what I'm doing is I'm applying several different where clauses to this. So the passenger count has to be greater than 0. The tip amount has to be greater than 0. The fare amount has to be in between $1 and $250. And then the trip distance has to be greater than 0 and less than or equal to 200 miles, I'm assuming, because we're in New York City, right? And then what I'm doing here is creating a temporary view. So this right here, since I'm using a filtering clause and I'm applying all these SQL methods to it using Python, I'm saving that as a data frame called filter df. So again, I'm setting this variable, but I don't want to call it df because then I'd be overriding the original data frame, and we don't want to do that. So this is why we rename data frames every time we change it. The other thing I'm doing in here is I'm changing it to a view. Now keep in mind that this isn't a SQL table yet, right? Or something that I can natively query with SQL because it's not in a view or a table format. I can't use native SQL until it's in something like that. So what I'm doing is I'm running this method here called create or replace temp view. This could also be temp table. This could also be table or view. And creating this temporary table called taxi data set. Now, because I have it in a view format, right? And I didn't set this as a variable. I'm just naming it a table called taxi data set. Now I can run native SQL statements on here. So I'm going to run this and explain what's going on as I'm doing this. What essentially I'm doing is you see this %% SQL sign. This is called a magic operator. And because there's 2 percentage signs, it applies to the entire cell. What I'm doing with this is I'm essentially overriding the default language of Python and telling it to that what I'm going to write in this cell is going to be native SQL. Now, if I hadn't converted this to taxi data set, which is what I'm referring to here, it wouldn't be able to do this for me. It wouldn't be able to run this query for me. But because I've converted this into a view, now it's going into the cache, looking at the view that I've created called taxi data set, and now it's running the query on this. Because this is in a SQL, we're calling on native SQL language, it's going to automatically output that rich HTML output. So I can still go change, to chart views or table views and modify how I want to look at the data doing it this way. As long as it's in that view or in a table, I can do this, right? So let's move on and get to going. So what we're doing here is we're going to create another data frame. And what I'm doing is I'm taking a sample of that filtered data frame that we created earlier. Running this takes that data set that we originally had, and I just want to sample a certain percentage of it, right? And randomize it by a seed value. So I'm just essentially taking a sample of the data set that we had filtered earlier, right? And one of the reasons that we're doing is that we're going to convert it into a pandas data frame. Now, converting a Spark data frame to a pandas data frame takes quite a bit. And that's why we're sampling this down. So we're down sampling it in order to convert it to a pandas data frame so we can run these pandas data frame friendly visualization packages on it. Just as a sanity check, I'm running a pandas method called head, which allows me to see the first 5 results of the data frame that was created. So now I know it's in a pandas data frame. Now, because it's in a pandas data frame, I can go through and create visualizations. So right here, what I'm doing is I'm using matplotlib to create a histogram, right? So distribution of tip amount distribution going down. So there's tip amounts. Okay. See a lot of between 0 and 250 happening here. Now what I'm doing here is I'm using Seaborn. So the PLT, since I have matplotlib now I already installed this, but I just wanted to put this here so you could see that the PLT is what I'm calling out here. So I'm using matplotlib.pyplot to plot these visualizations out. And in this one, I'm using Seaborn, which was SNS. If I went back up and showed you that I'm replacing Seaborn with SNS, this is what it's doing. Seaborn is actually kind of a layer built on top of matplotlib, although it isn't the same library. But it creates more, I would say, fancier, more detailed visuals than matplotlib, but just another visualization option. Here we're doing a box plot, again showing distribution, but this one adds whiskers to it so I can kind of see, what the minimum and maximum values were. So the minimum's always going to be 0. Can't go less than 0 on a trip. Can't go negative on a trip. Can't go negative on a fare. That'd be messed up if that happened. But we can see what, the max values are. And then it gives me, median and 25%, 75% quartiles on this. All right. We're getting way too much into that. Love talking about it. Here, we're just doing another box plot that more visually represents any outliers that might be contained within this. And again, we're doing a matplotlib scatter plot. So several different visualization options that I can apply with pandas-based visualization packages. If I want to use Spark, then I can convert it to a Spark data frame and then do a display method. And then I could take this table and create my own charts and visualizations with it. So this is how we utilize Spark to run notebooks. So this is the underlying engine, just showing you how you can use visualization techniques, how we load data in, and why it has to be in a certain type of data format, whether that be a Spark data frame, a Pandas data frame, or a table or view, so that we can utilize these different tools to query it. Great. Let's head back into the studio.
Great job, detectives. You have learned a lot about how to use Spark and Fabric to load, transform, and query data using data frames and SQL. You've also seen how to create and run notebooks in Spark jobs, as well as how to create stunning data visualizations with various Python libraries. Now you're one step closer to applying your skills to solve any analytics mystery that comes your way. Thanks for joining. If you're a fan of mystery novels, you know that the clues are often hidden in plain sight. Sometimes the most obvious things can be the most revealing. That's why, as data detectives, we need to pay attention to the details and look for patterns that can help us solve our analytics cases. We'll explore how Microsoft Fabric Lakehouse can help us uncover insights from data using delta tables, a powerful feature that brings relational database capabilities to data lake processing. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Let's investigate what delta tables are, how they work, and why they're so useful for data analytics. Delta Lake is an open source storage layer that adds relational database semantics to Spark-based data lake processing. Tables in Microsoft Fabric Lakehouses are delta tables, which is signified by the triangular delta icon on tables in the Lakehouse user interface. Delta tables are schema abstractions over data files that are stored in Delta format. For each table, the Lakehouse stores a folder containing Parquet data files and a Delta log folder in which transaction details are logged in JSON format. What are some of the benefits of Delta tables? Glad you asked. With Apache Spark, you can store data in Delta tables that support CRUD, or create, read, update, and delete operations. In other words, you can select, insert, update, and delete, for you SQLites out there, rows of data in the same way you would in a relational database system. Relational databases are designed to support transactional data modifications that provide atomicity, which means transactions complete as a single unit of work, consistency, which means transactions leave the database in a consistent state, isolation, which is in-process transactions, they can't interfere with one another, and durability. When a transaction completes, the changes it made are persisted. This spells out ACID. So when I refer to ACID, that's what I mean. Delta Lake brings the same transactional support to Spark by implementing a transaction log and enforcing serializable isolation for concurrent operations. Because all transactions are logged in the transaction log, you can track multiple versions of each table row and even use the time travel feature to retrieve a previous version of a row in a query. Most relational databases include tables that store static data. Spark includes native support for streaming data through the Spark Structured Streaming API. Delta Lake tables can be used as both sinks or destinations and sources for streaming data. The underlying data for Delta tables is stored in Parquet format, which is commonly used in data lake ingestion pipelines. Additionally, you can use the SQL Analytics endpoint for the Microsoft Fabric Lakehouse to query Delta tables in SQL. Delta tables are a powerful way to store both static and streaming data in a structured format that supports transactional updates, time travel, and schema evolution. Delta tables can be created and queried using Spark SQL or data frames, and they can be stored in either managed or external tables. Let's investigate how to create these Lakehouse-friendly tables and explore the differences between managed and external tables. Ready to dive into the case of Delta Detective? Let's go. When you create a table in Microsoft Fabric Lakehouse, a Delta table is defined in the metastore for the Lakehouse, and the data for the table is stored in the underlying Parquet files for the table. One of the easiest ways to create a Delta table in Spark is to save a data frame in the Delta format. For example, the following PySpark code loads a data frame with data from an existing file and then saves that data frame as a Delta table. The code specifies that the table should be saved in Delta format with a specified table name. The data for the table is saved in Parquet files, regardless of the formatted source file that you loaded in the data frame, in the table storage area in the Lakehouse, along with a Delta log folder containing the transaction logs for the table. The table will be listed under the Tables folder for the Lakehouse in the Lakehouse Explorer. You can also create Delta tables by using the Spark SQL Create Table statement, as shown here. This action saves the table similarly as the previous example to the table storage. You can also create a table by specifying an explicit file path. Here, we're creating a parameter called Delta path and referring to it in the save function. Because we're writing the table to a file location, this will be saved as an external table. The table name will still appear under the table storage location, and the Parquet data files and the JSON log files for the table are stored in the files storage location, and it will be shown in the files node in the Lakehouse Explorer pane. So what's the big deal between a managed and an external table? Let's solve this mystery. When a table is created, two parts are saved. A table definition, which is the metadata or pointer to a table, as well as the actual data and the associated logs. When creating a managed table, the table definition and the underlying data files are both saved and managed by the Spark runtime for the Fabric Lakehouse. Deleting the table will also delete the table definition and data from the Lakehouse. When creating external tables, the table definition, while still in the metastore, directs or maps to the data which is stored in an alternative file storage location. This means that deleting an external table will remove the table from the metastore, but does not delete the associated data files. This approach can be useful when you want to create a table definition that references data that's already been saved in a Delta format, or based on a folder where you expect to ingest data in Delta format. Certain scenarios may require you to save data in Delta file format as opposed to a Delta table, which essentially prevents a table definition from being created. This approach can be useful when you want to persist the results of data transformations performed in Spark in a file format over which you can later overlay a table definition. It's also good to note that you can still get the benefit of a transaction log that is saved with the file. Then there may be other scenarios where you want to save just a table definition that could be used to populate tables later. You can use Spark code to accomplish this as well. Now that we have Delta tables created, how in the heck do we work with these things? Another case to crack wide open, detectives, so grab your magnifying glasses and let's look for clues. Probably not much of a shocker, but you can work with Delta tables or Delta file formats to retrieve and modify data in multiple ways. The most common way to work with data in Delta tables in Spark is to use Spark SQL. You can embed SQL statements in other languages, like PySpark or Scala, by using the Spark SQL library. For example, the following code inserts a row into the products table. You can also use native SQL statements. You can either use Spark SQL as the default language in a notebook, or use a magic operator that will override the default language in a notebook. Here, we're updating the products table by changing the price of a certain product. When you want to work with Delta files rather than catalog tables, it may be simpler to use the Delta Lake API. You can create an instance of a Delta table from a folder location containing files in Delta format, and then use the API to modify the data in the table. Here, we're defining a Delta table object in memory and updating the prices of all accessories. This will update the file without persisting a table in the Lakehouse. Yes, detectives, time travel is possible, but not in the sense you might be thinking. Modifications like updates made to Delta tables are logged in the transaction log for the table as JSON files. Not this JSON, by the way. Each JSON file serves as a version of the table. Because of this, we can use the log transactions to view the history of changes made to the tables and to retrieve older versions of the data, known as time travel. To see the history of a table, you can use the describe SQL command, as shown here, and the results of this statement show the transactions that have been applied to the table. To see the history of an external table, you can specify the folder location instead of the table name. You can retrieve data from a specific version of the data by reading the Delta file location into a data frame, specifying the version required as a version as of option. Another case solved, but more mysteries abound. All the data we've explored up to this point has been static data in files. However, many data analytics scenarios involve streaming data that must be processed in near real time. For example, you might need to capture readings emitted by Internet of Things or IoT devices and store them in a table as they occur. But where do we store the streaming data? How do we query it? More mysteries. Are you ready, detectives? Let's dive into the clues and see how Fabric can help us handle streaming data with Delta tables. A typical stream processing solution involves constantly reading a stream of data from a source, optionally processing it to select specific fields, aggregate and group values, or otherwise manipulate the data and write the results to a sink. Spark includes native support for streaming data through Spark Structured Streaming, an API that is based on a boundless data frame in which streaming data is captured for processing. A Spark Structured Streaming data frame can read data from many kinds of streaming sources, including network ports, real-time message brokering services like Azure Event Hubs or Kafka, or file systems locations. You can use a Delta table as a source or a sink for Spark Structured Streaming. For example, you could capture a stream of real-time data from an IoT device and write the stream directly to a Delta table as a sink, enabling you to query the table to see the latest stream data. Or you could read a Delta table as a streaming source, enabling you to constantly report new data as it's added to the table. In the following PySpark example, a Delta table is used to store details of internet sales orders. A stream is created using the read stream method that reads data from the table folder as new data is appended. After reading the data from the Delta table into the streaming data frame, you can use the Spark Structured Streaming API to process it. Here, the data frame is simply displayed, but you could use Spark Structured Streaming to aggregate the data over temporal windows, for example, to count the number of orders placed every minute, and send those results to a downstream process for near real-time visualization. Okay, so we're capturing boundless data and performing ETL on it in real time. But what about when we're ready to write the data to a source? No problem, detectives. In the following PySpark example, a stream of data is read from a JSON file in a folder. The JSON data in each file contains the status for an IoT device, so the fields that we're collecting from the JSON file would be device and status. New data is added to the stream whenever a file is added to the folder. The input stream is a boundless data frame, which is then written in Delta format using the write stream method to a folder location for a Delta table. You may also notice the checkpoint path indicated in the code. The checkpoint location option is used to write a checkpoint file that tracks the state of the stream processing. This file enables you to recover from failure at the point where the last streaming process left off. After the streaming process is started, you can query the Delta Lake table to which the streaming output is being written to see the latest data. Another note, streaming data is boundless, so when a structured streaming job is submitted, it won't stop unless you programmatically stop it. Keep that in consideration when executing notebooks or scripts that contain streaming functions. Now that we've gathered clues on how to work with Delta tables in Fabric, let's connect the dots and put knowledge to practice. We're jumping back into the DetectoLab 5000, aka my Surface laptop, for a go. The game is afoot.
All right, welcome back into the environment. And we're going to cover Delta tables. So up to this point, we're kind of working a little backwards just because this is the way that the content fell in the whole scheme of things, but we want to cover it. So we're going to talk about the Delta tables, and I'll give you a little background for what we've done up to this point, which moved a little bit ahead, and then we're moving back. But what we've done up to this point is we've created a sample Lakehouse. We've shortcutted into that. And then what we did was we loaded data into our files path into our Lakehouse. So if I go into my Lakehouse here, you see I have this WWI raw data. And this was actually data that we imported in using a pipeline from an external blob storage account into our Lakehouse itself. So when you get into pipelines, this will make a lot more sense. But ultimately, what we have here is a bunch of raw data in Parquet format, right? So I got different Parquet files in here. And usually that's the optimal way of reading data into anything, into the Spark engine. Parquet is very good, is a very ideal file type to work with the Spark engine. And that's why all these are in Parquet. So it's always a good thing to do in an ETL process, especially if we're going to work in Fabric, is to convert your files. If we're going to copy them into a Lakehouse or into our OneLake, we want to go ahead and convert those through a downstream process to turn them into Parquet files so that if we're going to use a Spark engine, we know it's going to be optimized to work with that file type. They're already there like that. So what we're going to do is we're going to go back into our workspace and open up this notebook. Now, if I would have opened up the notebook, by the way, I'm going to stop this session. And I'm going to make sure that I have my Lakehouse enabled on this, right? So you can see that my Explorer, I could upload data and files to certain resources, but also if I want it to load it up to a Lakehouse, I need to make sure that I have that in there, right? So my Lakehouses, I already have one, so we can add those to it. But I want to make sure that this item's added, because I'm going to be referencing file paths in there, and I want to make sure that the Lakehouse is the file path that it's looking for in the session. So we're going to run this cell, and the first thing I want to talk about while we're running this cell, and we'll go through this again, is these configuration settings. Now, we are working with Spark Engine in this case, and if we're going to be utilizing our SQL Analytics endpoint or using downstream analytics tools like Power BI, this optimization open source project called vOrder allows the data that we're going to load into these tables to be compressed and optimized for reads from those downstream resources that I just mentioned. Also, this optimize write is a good optimization technique to include whenever we're writing tables to a Delta format. So they do have to be Parquet format in order for you to utilize things like vOrder, but we also want to optimize the writes in these Delta table formats so that we're maximizing read times when it comes to querying these particular tables. So that's what I'm doing in here. I'm enabling vOrder or making sure it's enabled. This way I got all my bases covered. Same thing with optimize writes. I'm making it enabled. And then I'm also setting a bin size, which means that it's going to try to write these to a certain size file, and then whatever's left over, it'll make its own folder for that amount. So this is a bit size or a size for that. So the first thing that we're going to do is we're going to create a fact table out of those files that we loaded into our Lakehouse. So what do I need to do? Just to go over the Python here, I'm importing some SQL functions, because what I'm going to do is I'm going to be parsing out certain values contained within columns and making our own columns out of those values, so to speak. So what I'm doing here is I'm setting a variable name called fact sale, and we're going to apply this to the table name. That's a string value. And why? Because we're going to insert it here later on. This seems like a little overkill because I could have just entered fact sale there, but if we had multiple tables that we were creating, I could see why you'd want to do this. Now, going back to Python, in order to create a Spark data frame, we talked about Pandas data frame, but in order to create a Spark data frame, just utilizing the Spark commands, I can go to the Spark and then do a read. So this is what loads data into a data frame. I'm making a data frame API call out and setting it to the designation or variable df. I'm telling it that the files are going to be in Parquet format and where to look for those files. So there should be a files path for my raw data, a full, and then a fact sales year 1. Just as a sanity check, I can look full, fact sale, 1 year full. So I know it's in here, right? Very good. Know it's there. And what we're doing here, after we read the data in, it should create that data frame. And now I'm going to overwrite this data frame since it's the same variable, but I'm including these column values. So now I'm creating a column called year where I'm pulling out the year from a date time column, and I should be able to parse out certain aspects of information from that. Also, I'm going to pull out the quarter of that and create its own column, and same thing with the month. And then I'm going to write this. So when I use a Spark write command, I'm externalizing this data. It's all held in memory until I externalize it. So this Spark write method allows me to essentially write this to an external place. Now we're going to be writing it to our Lakehouse, right? In the tables, that's what I'm identifying here. we're also going to be converting it to Delta Parquet format, and we're going to partition them by year and quarter. So there'll be folders made for both all the years in the data set and then all the quarters in the data set as well, following those optimization techniques. So this might take a little bit of time because it's going to read all this data in. If it's a full year's worth of data, it may be several megabytes worth of data. And then it's got to apply these transformations to it. And then it's going to write it to the Delta Parquet format file. And this is what's going to essentially create our Delta tables in our Lakehouse. This is really all I'm doing. This right here is what's converting this or creating Delta tables. I'm just saving it under the table's name and then writing them to this. So I'm going to let the magic of editing, of video editing, come back when this is done. All right, so it looks like the cell executed. Welcome back, by the way. Fast forward in time. We are time traveling ourselves. So now we've actually created a table. So let's do a sanity check, right? I want to see if this happened. So we'll go back in our Lakehouse, and there it is. There's our fact sale table. Now I'm in my file explorer right here, so I can see my data that's open, that's created from this. And then I could always go into the fact and the Parquet files in here. But I can also view the files. So this is what I wanted to point out for this, because this is what essentially has created this Delta log here, right? Or this Delta table and what it includes. So you see here that I have a Delta log, right? And then I have this year folder. Let's go back because I want to show, first I want to show let's go back to the files. So the Delta log is my transaction log, right? If I go in here, there should only be one version of this because I just created this table. So you can see there's a bunch of spaces in there. If I were to update this table with some different information, even if I was to change a column name, filter some data out, do something of that nature, it's essentially going to update this table just like it would in like SQL if we were doing this there. Difference is that it's a JSON file and we associate it directly with the other files that are in this path. So what it'll do is it'll call on the metadata associated with a specific version. I don't know if I can open these or not. So yeah, I can. So you can see that there's info associated with this, right? And it just has everything that I've done up to this point. So this is all metadata associated with all the files. Go back in here. So this is the metadata associated with all the files that were in the path that I created. So this is our transaction log. I update it. This is what allows me to do time travel and go to different versions of the log. Now, about the partitioning. Remember, we used a partition by strategy. So we can partition our data out using that strategy. I'll go back and show you, but remember we did it by year and by quarter. So it created a year because there was only 1 year in the entire data set. If it had more than year 2000 in there, it would have created another folder for year 2001. But it only has 1 year in here, right? That's what we pulled it from, was this fact sale 1 full year. So it should only have 1. And in that year, it has 4 quarters. So it also can split this data by quarter. And then you can see that it created a partition file for each one. Or I keep doing that. I want to navigate through that way. So you can see that each one of these is about, 58, 59 megs. So this is kind of what that optimization does too. And then it created a final file that was around 39 megabytes. So this is essentially what the optimization does, what happens when we write this and when we partition it by using a Parquet file in these deltas. So the delta applies the transaction log, the Parquet partitions the files for super fast read times on this. So now I can essentially go back in here and, directly query this data. And we'll come back and do that here in a second. But let's go back into this because I don't just want my fact tables. I want dimension tables, right? I want to start building a model from this data. So this is what this particular cell does. And I'll go through this too because we're doing this a little bit differently. And usually you'll see this when we talk about Spark execution jobs or you hear about Python scripts. This is a notebook, but you can create Python scripts. And usually the difference between what would happen in a script and this is that we're not really including all this markdown language in there. We're going to refactor the code to define functions as opposed to calling functions out in line by line. We're going to define a function and then execute the function in some type of order, execute the collection of functions. So in this case, this is a good first step. I would say this is 80% of what a Python script would look like, except that we would include, some executables for the we would define a main run and then execute the main run. Here, we're just running a for loop to execute the actual function itself. So what are we doing here? Let's get to the point, Jason. All right, so we're defining a function called low full data from source. So I'm creating this. And the argument that it is going to require is a table name, right? So what is this function going to do for me? So when this gets called out, it's going to read data in from my files and then pull in a table name that I'm defining, right? So, and I'll infer that later on down here. So this is why I'm creating these table name, this table name variable right here. So this is what it's calling out, which I would name here. Then I'm selecting columns. If C is not equal to photo, so I'm going to include every column except for this photo column, which I'm assuming contains an image that we just don't want to include in this. And then we're going to write these to a delta table. So this is just another way of doing this. I can create, essentially define functions, write this as script, Python script, save it as Python script, refactor it like I am here, and then run it as a Spark execution job on a schedule. So then I could constantly check for data in my Lakehouse, pull it in from there, and update the tables that are contained within my within the Lakehouse itself as well. Now, what I'm doing here is I'm defining a list of tables that I want to pull out, right? So this is what it's doing is now it's going, when I execute this, and this is a for loop, so it's going to keep going until it's iterated through this list of items here. So it's going to look for dimension city, dimension date, dimension employee, and dimension stock item. And then it's going to run this function on them, right? For each table that's listed in this list. So hopefully my Spark session didn't end and we'll be able to pull this in. We're still associated in our File Explorer with our Lakehouse, so that's where it's looking for these file location names at. And I got to tell you, that was super quick in its way of, now these are just dimension tables, so they're probably super small tables. But let's go back into our Lakehouse and take a look. So you can see it's already refreshing. And again, now I have my dimension table. So I have my dimension city, my dimension customer. I can click on this. It'll load a preview of the table for me, right? So, and this is, 402 rows in this one. This only shows a max of 1,000, so there's probably more than that in there. My dimension date probably has way more than 1,000 rows in it. Dimension employee, maybe not so much, 213 rows. Right. And then dimension stock items, we have 672 stock items in here. So customers and dates, probably more than 1,000. Some of these are cities, I'm sorry. So our cities, there's more than 1,000 cities and there's more than 1,000 dates. But this is essentially what created all of our delta tables. And each one of these, view the files, it's going to have a delta log and it's going to have its own file associated with that. It didn't partition or it didn't create folders. Why? I didn't use a partition by statement in the actual loading of the table, right? I don't have a partition by here in the right as I did up here. Boom. This had a partition by. And dimension tables are usually small enough where you shouldn't have to partition them by anything. Fact tables, you'll usually want to use like a partition or a date that's going to split the data as evenly as possible. They probably did this twice to further split that data to be more optimized on the read part of it. And sometimes you'll have to do that. But that pretty much introduces the concept of delta tables. Let's go back into the studio.
Yes, fellow detectives, this is how we delta in Fabric. Delta tables are a key component of the Lakehouse architecture, providing transactional support, schema evolution, and time travel capabilities. They also integrate seamlessly with the Fabric Lakehouse user interface and the SQL Analytics endpoint, making them easy to explore and query. Whether you're investigating static or streaming data mysteries, Delta can help crack the case. Thanks for joining. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Data Flows Generation 2 is a Fabric item that allows you to perform ETL, extract, transform, and load tasks using Power Query Online, which is a visual interface that makes data transformation easy and intuitive. What the heck are data flows? How do we use Power Query Online to create data flows? And how can I incorporate data flows into other Fabric items like pipelines? All great mysteries to solve. Gear up, detectives, we have a case to solve. Now, imagine you're a data engineer working for a large company that has data stored in different formats and locations. You need to prepare the data for downstream analytics, but you don't want to write complex code or deal with multiple tools. You want a simple, reusable, and scalable solution that can handle any data source and any data destination. You want to use Data Flows Generation 2 to solve this mystery. Data flows are a type of cloud-based extract, transform, and load tool for building and executing scalable data transformation processes. Data Flows Generation 2 allows you to extract data from various sources, transform it using a wide range of transformation options, and load it into a destination. Using Power Query Online also allows for a visual interface to perform these tasks. Fundamentally, a data flow includes all the transformations to reduce data prep time, and then can be loaded into a new table, included in a data pipeline, or used as a data source by data analysts. Data Flow Gen 2, or Generation 2, is the new generation of data flows. The new generation of data flows resides alongside the Power BI data flow, Gen 1, and brings new features and improved experiences. The table shown here provides a comparison between the Generation 1 and Generation 2 data flows. Some major features to think about are the ability to select data destinations, as well as the integration of data pipelines. There's more than one way to ETL or ELT data in Microsoft Fabric, so be sure to consider the benefits and limitations for using Data Flows Generation 2 before selecting them as an option. Traditionally, data engineers spend significant time extracting, transforming, and loading data into a consumable format for downstream analytics. The goal of Data Flows Generation 2 is to provide an easy, reusable way to perform ETL tasks using Power Query Online. In order to create a data flow, you need to have a Microsoft Fabric-enabled workspace. Data flows are created through the Data Factory experience. From there, you should be able to create a new data flow item. For ETL processes, you can create a Data Flow Generation 2 first to extract and transform the data. Once your data is ready, you have options for using the data flow. Like, you could load the data into a Lakehouse, so the business can easily consume the curated semantic model. You could add a data destination to your data flow, which is optional, and the data flow preserves all transformation steps. To perform other tasks or load data to different destination after the transformations, create a data pipeline and add the data flow generation 2 activity to your orchestration. Another option might be to use data pipeline and data flow generation 2 for extract, load, and transform, or ELT process. For this order, you'd use a pipeline to extract and load the data into your preferred destination, such as the Lakehouse. Then you'd create a data flow generation 2 to connect to Lakehouse data to cleanse and transform the data. In this case, you'd offer the data flow as a curated semantic model for data analysts to develop reports. Data flows can be horizontally partitioned as well. Once you create a global data flow, data analysts can use data flows to create specialized semantic models for specific needs. Data flows allow you to promote reusable ETL logic that prevents the need to create more connections to your data source. Data flows offer a wide variety of transformations and can be run manually, on a refresh schedule, or as part of a data pipeline orchestration. To create a data flow generation 2 in Fabric, we use Power Query Online, a no/low code interface, which allows not only hard-nosed coding proficient detectives, but also our detectives who understand the logical flow, but may not be able to be as coding proficient to perform transformations on data. So what elements can we expect to use in Power Query Online? Let's crack the case of interface interrogation. The first element of Power Query Online to discuss is the ribbon. If you're familiar with Microsoft software, the ribbon serves as a go-to for quick access to extracting and transformation options. A common use of the ribbon is to get data from sources that can include cloud and on-premises relational databases, Excel or flat files, SharePoint, Salesforce, Spark, and of course Fabric Lakehouses, just to highlight a few examples. Then there are numerous data transformation options possible, like filtering, sorting, pivoting, unpivoting, removing duplicates, merging queries, and the list goes on and on and on and on. There's a lot that you can do. Let's just put it that way. The Queries pane shows you the different data sources, now called queries. Some options for query formatting are renaming, duplicating, referencing, and enabling staging. The diagram view allows you to visually see how the data sources are connected and the different applied transformations. The data preview pane only shows a subset of the data to allow you to see which transformations you should make and how they affect the data. You can also interact with the preview pane by dragging and dropping columns to change order or right-clicking on columns to filter, to make changes, etc. The query settings pane primarily includes applied steps. Each transformation you do is tied to a step, some of which are automatically applied when you connect the data source. Depending on the complexity of the transformations, you may have several steps applied for each query. In the Query Settings pane, you can see a data destination field where you can set the Lakehouse or other Fabric items as your destination. While this visual interface is helpful, you can also use the M code through the Advanced Editor. As detectives, we realize that we can rely on past cases to help us solve current cases. Same thing applies to data flows. Gone are the days where we would need to continuously perform the same ETL operations on raw data because of disparate systems that don't integrate. With Fabric, data that was enriched with data flows can be integrated with other Fabric experiences seamlessly. Let's look at an example in the case of the data flow pipeline partnership. The combination of data flows and pipelines is useful when you need to perform additional operations on your transformed data. Data pipelines are easily created in the data factory and data engineering workloads. Pipelines are a common concept in data engineering and offer a wide variety of activities to orchestrate. Some common activities include copying data, adding a notebook, executing a script or a stored procedure, and so much more. Pipelines provide a visual way to complete activities in a specific order. You can incorporate a data flow into a pipeline to orchestrate extra activities like execute scripts or store procedures after the data flow is completed. In the example shown here, we're using a data flow to pull data into a pipeline, running a notebook to perform additional transformations or machine learning possibly, then copying the data to a defined destination. And fear not, detectives, we'll explore pipelines further on another case. Time once again to log into the DetectoLab 5000 and put knowledge to practice. Let's do some real investigation to unlock the mysteries of data flows.
All right, back in the environment, and we are going to work with data flows in this one. So let's ingest data into our Lakehouse utilizing a data flow. So what I'm going to do is, first of all, just show you I'm in my Data Detective workspace with the Fabric content, and I'm going to navigate into my Lakehouse itself, and then I'm going to get data from here. I could do it from here, but I'm going to say new data flow Gen 2 on this one. And this should open up Power Query for me. Now, where am I going to get this data from? I'm going to do this from a CSV file that I have, and I'm going to upload it. Now, I have the ability to create connections to different resources if I need to, but I'm just going to upload a file, and I'm going to load this from my local machine. And what this is going to do is it's going to upload this for me and create its own connection for me. Okay. And then I'm going to go ahead and click next, and it's going to parse through this data now and give me a preview of it. So I can tell that it's applying or inferring data type values to this, and also found the column names, which should have been the first row of the data set. So it did those for me. I can see that the preview looks pretty good. I'm going to go ahead and create this connection into my data flow. So a couple things that happen when we load data in. So it's going to connect to a source, and I've already mentioned that it's promoting the column, the first row as the column values, right? And then it also changed some column types. Maybe the original CSV had a different, or maybe it's because it's inferring the data types onto it, it changed column type values for that. So those are things that it did on its own just to load the data in and apply its own data types to it. So those show up on our applied steps. Now, going back to this is our Power Query Editor online. And if you're familiar with using Power Query Editor in Power BI, then this experience should look pretty familiar to you. Should seem pretty familiar. So we got our ribbon up at the top. We have our queries pane. So if I have different queries that I've provided, meaning different tables that I want to create out of this, then there's going to be applied steps that are applied to each one of these. So different sources, different table names that I want to bring in, I can always get that data and then bring it in here, change those steps to it as well. Because of that, then I can come in here and start merging or appending items or data from one to the other. I could perform join operations like full or inner joins to several different source connections. Just to give you an idea, these are some of the examples of the sources that I can create and pull data in from. Then we have our preview down here, our visual preview of the data, and I have the visual steps up here. So if I parse through this, I'll just give you an example. I'm not going to do too much to this data set, but I can always come up here and remove columns. If I highlight a column, it may give me some options to do this, but I can also right click on it. And let's just say I remove this column just to show you what happens. It's going to remove this column from the preview, and then it's going to add that remove column steps to my visual and the applied steps here. If I didn't want to do that, or if I'm looking at the data after I perform an operation, I'm like, yeah, I don't like that too much, I can always go back and remove the step, and it will fix what I didn't mean to do. One thing I do want to point out, though, is that sometimes a step might have happened earlier up here that may affect a step that happened later on, or is associated with a step that happens later on. So be careful. You don't want to just go removing steps all the way up here when you may have a dozen steps. 2 or 3 of them might be dependent on that previous step, and you won't be able to perform it. So just make sure you're performing sanity checks quite often when you're doing this. One thing I do want to just to apply a transformation step to this is I want to get rid of this row. But I'm not going to delete the data from here. What I'm going to do is I'm going to filter it out. So if I click on the actual drop arrow here, it shows me all the values that are listed in this particular column. And this 0 value is just applying an unknown. So what I'm going to do is I'm just going to filter that out. So it does a few things here. It adds it as a step, so it filtered the rows out. I can visually see that it filtered that out. And then it removed it from the preview. Now, anytime that the data ends up changing and it reloads the data in from this data flow, that's what the connection does. Then if somebody entered another 0 value into this customer key, which would be an unknown in this case, then it's going to automatically filter that data out. I don't want those zeros or NA values in there because it may skew some of the aggregations or totals that I want to apply to the column. Last thing I'm going to do is just change the name of the query to dimension customer. Just so you know, table names shouldn't have spaces or spaces in them. So you want to make sure that there's no spaces in your table names. So that's really all I'm going to do. The last thing I want to point out here is the data destination. Now, because I opened up this data flow from the Lakehouse experience, it set that as my destination automatically. But if I wanted to update the destination or create a new data destination for this, I can edit the current settings in here or select a destination, replace a method if I wanted to. I could set that in there or update the settings in create a new Lakehouse connection to another Lakehouse if I wanted to. All right. I'm going to go ahead and publish this. And as this is publishing, a couple things are going to happen. It's going to obviously run the data flow. So now it's pulling in the data from there. It's performing whatever transformations I have. And it's going to add it as a table into my Lakehouse. So at some point, when I refresh this, that table will end up showing up here in the actual Lakehouse itself. But I'll give it some time in order for it, and it doesn't take too long for the actual data flow to publish, and then it takes it a little bit more time for it to load the data into an actual table itself. All right, nothing in there yet, but we'll see it here eventually. You can see that it's already performing a refresh because I can't hit the refresh button. And that's what it's doing. It's loading the data now into a table in my Lakehouse. There it is. So now I can see the actual data here. And I can also see the column values that are with it. Now, what happens in the Lakehouse experience? So this is another thing. Lakehouse experience versus the SQL Analytics experience. So the Lakehouse experience, I can see the actual CSV file. I can also, I can see the structured data that's associated with it. And from here, I could like open this up in a notebook, load this data in, and do something else with it. Now, that's fine if I know, Pythonic language and stuff like that. But if I'm more of a SQL person, I might not want to use Python. I might want to use SQL. So I can switch to the SQL Analytics endpoint. The table's still here, but now I can actually perform a new SQL query. And run T-SQL statements that will allow me to actually get information out of this. So now I'm performing analytics from this query itself, or from building that table in the Lakehouse. So it created a SQL endpoint or SQL Analytics endpoint that I can use SQL language to query this. By the way, these queries do get saved in here. So even if I close it out, it'll get saved as that query, and I can always come back to it and run it. Rename it from here, do what I need to with it. Now, the semantic model is created with this too. So because I have this table in there now, I could essentially start using that. It should sync that up with my, sync that table up with my default semantic model. And that updates that automatically. So from here, I could just start looking at that data visually through Power BI tools if I wanted to kind of parse through the information in that single table. Don't have a full model yet, but I do have a single table that I can visualize in here. So that essentially covers data flow. So now we have a data flow that's loading a CSV file, ingesting it directly into our Lakehouse. Hope you got some out of it. Back to the studio.
That's it, detectives. You learned how to use Data Flows Generation 2 to create and execute scalable ETL processes using Power Query Online. You also seen how to integrate data flows with other Fabric items like pipelines and lakehouses. Data flows are a powerful tool for data engineering that can simplify and automate your data transformation tasks. And remember, if you ever need help with data flows, just call me. I'm always on the query. Thanks for joining. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. And let's face it, sometimes we just like to be lazy. Efficient. When solving data mysteries, we want to crack the case as quickly as possible, with as little deep investigation as possible. Same applies to analytics. Sometimes we just know the logic behind how we get the data and how we want it to look when we're done. And we don't want all the complexities of systems integrations and complex coding to do it. Pipelines to the rescue. Pipelines in Microsoft Fabric encapsulate a sequence of activities that perform data movement and processing tasks. You can use a pipeline to define data transfer and transformation activities and orchestrate these activities through control flow activities that manage things like branching, looping, and other typical processing logic. The graphical pipeline canvas in the Fabric user interface enables you to build complex pipelines with minimal or no coding required. Before building pipelines in Microsoft Fabric, you should understand a few core concepts. Activities are the executable tasks in a pipeline. You can define a flow of activities by connecting them in a sequence. The outcome of a particular activity, meaning success, failure, or completion, can be used to direct the flow to the next activity in the sequence. There are two broad categories of activities in a pipeline. Data transformation activities encapsulate data transfer operations, including simple copy data activities that extract data from a source and load it to a destination, and more complex data flow activities that encapsulate data flows that apply transformations to the data as it's transferred. Other data transformation activities include notebook activities to run Spark notebooks, stored procedure activities to run SQL code, and delete data activities to delete existing data, and others. Control flow activities allow you to implement loops, conditional branching, or manage variable and parameter values. The wide range of control flow activities enables you to implement complex pipeline logic to orchestrate data ingestion and transformation flows. Pipelines can be parameterized, enabling you to provide specific values to be used each time a pipeline's run. For example, you might want to use a pipeline to save ingested data in a folder, but have the flexibility to specify a folder name each time the pipeline is run. Using parameters increases the reusability of your pipelines, enabling you to create flexible data ingestion and transformation processes. Each time a pipeline is executed, a data pipeline run is initiated. Runs can be initiated on demand in the Fabric user interface or scheduled to start a specific frequency. Use the unique run ID to review run details to confirm they completed successfully and investigate the specific settings used for each execution. All right, So we cracked the case of what pipelines are and understand that we can create complex transformations using this Fabric item. We can also use them to do simple things like copying data. Time to investigate the copying conundrum. The copy data activity is one of the most commonly used data pipeline activities. Many pipelines consist of a single copy data activity that's used to ingest data from an external source into a Lakehouse file or table. You can also combine the copy data activity with other activities to create a repeatable data ingestion process. For example, by using a delete data activity to remove existing data, a copy data activity to replace the deleted data with a file containing data from an external source, and a notebook activity to run Spark code that transforms the data in the file and then loads it into a table. When you add a copy data activity to a pipeline, a graphical tool takes you through the steps required to configure the data source and the data destination for the copy operation. A wide range of source connections is supported, making it possible to ingest data from the most common sources. After you've added a copy data activity to a pipeline, you can select it in the pipeline canvas and edit its settings in the pane underneath. Use the copy data activity when you need to copy data directly between supported source and destination without applying any transformations, or when you want to import the raw data and apply transformations in later pipeline activities. The simple things. But what about more complex transformations that don't fit into a single activity? That's where we can dial up our investigative specialist, data flows. If you need to apply specific transformations to the data as it's ingested that can't be done with a single activity, or you want to merge data from multiple sources, consider using a data flow activity to run a data flow. You can use the Power Query user interface to define a data flow that includes multiple transformation steps and included in the pipeline. You can define pipelines from any combination of activities you choose, enabling you to create custom data ingestion and transformation processes to meet your specific needs. However, there are many common pipeline scenarios for which Microsoft Fabric includes predefined pipeline templates that you can use and customize as required. To create a pipeline based on a template, select the Choose a Task to start a new pipeline as shown here. Selecting this option displays a selection of pipeline templates. You can then choose the most appropriate template for your needs, and then edit the pipeline in the pipeline canvas to customize it to your needs. Now we're ramping up to become pipeline pros. Imagine now we have a plethora of pipelines powering your processes. Say that 5 times fast. How do we make sure things will properly execute? And after we publish the pipelines, how do we monitor them? Great questions. Let's look at the clues. When you have a completed pipeline, you can use the Validate option to check that its configuration is valid, and then either run it interactively or specify a schedule. You can view the run history for a pipeline to see details of each run, either from the pipeline canvas or from the pipeline item listed on the page for the workspace. When you view a pipeline run history from the workspace page, you can select the run start value to see the details of an individual run. That includes the option to view the individual execution time for each activity as a Gantt chart. The DetectoLab 5000 is powered up and ready to put this knowledge into practice. Let's dive in and start pipelining.
All right, back in the environment, and now we're going to talk about pipelines. So we are going to create a pipeline, very generic one, just a copy one, and load files into our Lakehouse. So again, an ingestion method, just a different way of bringing data in. But obviously we want to see different options. So we're going to use a data pipeline. You can see that I'm in my workspace right now, and we're going to go ahead and create a new data pipeline. What are we going to call this pipeline? What do they want me to call it? So I'm going to copy and paste this. This is the actual name that we're going to call this, ingest data from source to Lakehouse. And this should open up my pipeline experience. right? So now you can see that I have new activities. I can create pipeline activities. I can use the copy data assistant. And that will take me through a step-by-step like wizard in order to do this. But I think I want to create just a copy data activity. We won't go through the step-by-step. That's more of a wizard. And feel free to go through and experiment on your own. If you want to create a wizard or something like that, that's perfectly fine. But we're going to go through the copy data activity itself and build this out ourselves. Because when we add a activity, now remember a pipeline could contain several activities in here, and we can chain activities together. Now, this particular pipeline will be a single step, but let's go ahead and back up and introduce the features and what you can do with this service or with this item within the Fabric experience. So you can see here that I have my main ribbon, which has my different activities that I can include in here, what I can do when I'm ready to run this, and I can view the JSON code. So if I want to programmatically save this and integrate it with like Git or something like that, that's great. I can do things like that, or zoom out the visual interface itself. And all this is just visual interface that allows me to zoom in, zoom out, do all that good stuff. If I wanted to add another activity, because I have an existing data flow, I can click data flow, I can add this activity, and then I can say on a success or on some certain state of this, I could do something and chain these together. You can also see that anytime I select something, I might have, there might be particular settings within each activity that are going to differ depending on what I'm connecting it to, right? So I have a data flow that I created in a separate one, so I could chain this together and connect it to a lake or this particular data flow. When I change those settings, I can even change the settings on the actual state itself, right? So when this is complete, so this is a state, kind of a state machine here that looks at what the output of or what the state was of the previous step. And this is one way I can do control flow, right? So if the pipeline happens to skip that step, I could take it through a whole different self-healing aspect of things. If it fails, then I might want to do something like send an email to somebody, which could be another activity I can create, or if it completes or whatever. I could also just add control flows. So like if conditions, I think there's for each conditions that I can also apply to these. And if I don't need the steps, I can just delete the steps, right? So I can delete them, deactivate them, do what I need to. Also, when I don't have anything selected, I can place variables or parameters or settings that apply to the entire pipeline, not necessarily an individual step, but I can also change the settings on individual steps. So here we have general settings, right? So I can say what the activity state is. I can deactivate these if I wanted to and give it a timeout. So I can give it, say this activity is running longer than a certain period of time, it'll time out, and then I can give it retry options as well. And then there's some more advanced things that I can do. Keep in mind these steps are going to be different for each type of activity. Now, where's the source? Well, I want to get this source from an online. Actually, I also want to change this name of this copy activity to data copy to Lakehouse. And we're going to copy some information to that. We're going to look at the source and we're going to connect to an external source. And I'm going to create a new one. So I haven't created this connection yet. There's actually some public storage accounts that are available from Azure that will allow me to connect to them and bring data in from them. So they're publicly available. I don't need special permissions in order to connect to this. So we're going to connect to a blob storage account, and I have the address here. So essentially I'm using an endpoint because that's how we connect to cloud-based objects is through an endpoint. So you can see I'm just connecting to a blob storage account that just happens to have public data associated with it, right? So I'm going to make this a new connection. I can change the connection name. I don't want this to be the whole name of this, right? I just want to simplify this. So I'll call the connection name WWI sample data. And what this is it's a worldwide importers bunch of tables from a worldwide importers data set, right? Don't need a data gateway to connect to it because it's a public account, cloud-based. And then we're also accessing through anonymous access. This you can only do, again, with a publicly available storage account. There may be different options that you need to consider when you're connecting to a storage account or some other object that's going to require authentication credentials in order for you to connect to those. But we're going to go ahead and connect to this. Right. So now you can see that what happened is that after we've created that connection, it added that connection. So now I have this connection permanently associated with my workspace, and I can go back and use this over and over again if I wanted to change it. It looked like it added that admin. It looked like it didn't delete a term that was supposed to not be in there, but it looks like it is. So what I am going to do is I'm going to go into the sample data path, and then, I could go with wide world importers. In fact, it's wide world importers DW/Parquet. So I'm going to be loading in Parquet files. And then I'm going to load in all the files within that, right? I could also find this in the browse section. So it should go ahead and look at all what I'm doing in here. So it's going to have the incremental, and all the tables that are associated with this. But I could have went back into the root folder and applied this by using the browse option as well. All right, recursive checked, file format binary, and then what we want to do is change the destination. Where's this going? This is going to go into our Lakehouse, right? So I want to make sure that it's a workspace associated item into a Lakehouse. I have my sample Lakehouse here, and then my root folder, I'm actually going to put this in my files, right? I'm associating this with files. And I'm going to rename this directory WWI raw data, right? And make it binary data. Boom, boom, boom. We're all good there. And then if I wanted some other settings, I could change those as well. All right. So I'm going to save this. Okay. Select run to execute the pipeline and get its activity running. So what I'm going to do is I'm going to go ahead and run this pipeline. So this should copy the data automatically. Now I could have validated this, and you can also see that right now it's queued this up and it's going to actually execute this pipeline for me. Let's talk about some of these other options that are up here while this is actually running, because it's going to load a lot of tables in here. So what we have here is, let's see, under our run, I could validate. And what validating does is it actually checks for any errors that might happen in a pipeline that we've created. So if I have several steps in here, I can validate all the steps to make sure that they're running. This actually succeeded, so that ran fairly quickly. I can also run these pipelines on a schedule. So I can create a schedule if I wanted to run this a daily and apply certain times. I can add times to this, so several times during a day, several times during the week, by the hour, by the minute. So this automates this process for me. I don't have to refresh the data on my own. I'm not going to do that. I'm not going to save this and run it on a schedule. But just wanted to show you that, yes, it did run this. I can monitor, once I run the activity, I can monitor the activity here. Once it's gone in here, I can see how long it took, some other advanced options. You know, and it could say it, and these are all outputs. So this is all log information that's collectible and things that I can analyze later on. So you can see that the copy, it took it from the source, sent it to the destination, look at about, you know, almost a gig's worth of data that read in there with 106 different files in there. I think it did a pretty good job of loading that data in as fast as it did. But here I can see, you know, what happened with this actual process. If there are any errors, it would generate an error message for me. I can go in and see what happened with it. I can also see input settings and output settings in JSON format and be able to work with those as well. So now when I go back in my Lakehouse, let's go back in here. And I go back into my Lakehouse. Under the files, I should have all these files in here. So here it is, my WWI raw data. So now I have my, you know, full incremental or my full backup, my incremental, and then, so this has all the folders worth of data that are in here, my fact sales. And from here, I could create tables out of these files. I can go into one of these and show you, just to show you that these got saved in Parquet files, right? So it partitioned the file itself. I don't think I can preview Parquet file information, but you can see that it partitioned the data out for me. Same thing with some of my dimension tables, right? So it partitioned out all this data for me, and that's typically what happens when we're dealing with Parquet file types. So there you have it. That's how we can use pipelines. And I know that was a very simple way of getting data from one way to another one, but you can build complex pipelines. Again, you can add several different sources, merge those sources together in single activities, and utilize pipelines to ingest data. Schedule these pipelines to run, load them into your Lakehouse. Back to the studio.
Wow, we've learned a lot about pipelines in Microsoft Fabric. You now know the basic elements of pipelines and how to use the copy data tool and the data flow activity to ingest and transform data from various sources, how to leverage pipeline templates, and how to run and monitor your pipelines using the Fabric user interface. You're well on your way to becoming a data detective yourself, solving analytics mysteries with ease and efficiency. Just don't forget to clean up the crime scene after you're done. Thanks for joining. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Fabric notebooks are interactive documents that allow you to write and execute code, add comments, and visualize data. They're powerful tools for data analysis and experimentation, as well as automation and orchestration. Together, we'll investigate how to use Fabric notebooks to connect to external data sources, ingest and transform data in a lakehouse, write data in different formats, and optimize performance and scalability. We'll also consider how different users and roles can benefit from Fabric notebooks and how to transform data for different purposes. Grab your magnifying glasses, not with that big ol' eye, but with yours, and let's solve the case of notorious notebooks. Fabric notebooks are documents that combine code, markdown, and output in a web-based interface. You can use Fabric notebooks to write and run code in various languages like PySpark, Scala, R, and Spark SQL. You can also add markdown cells to provide comments, explanations, or instructions. The output cells show the results of your code execution, such as tables, charts, or graphs, and errors if you screw up. You can run or freeze individual or multiple cells depending on your needs. Fabric notebooks are great for exploring data, testing hypotheses, prototyping solutions, and automating workflows. One of the main use cases for Fabric notebooks is to ingest and transform data from various sources and load them into a lakehouse. A lakehouse is a hybrid data platform that combines the best features of a data lake and a data warehouse. It allows you to store and process structured, semi-structured, and unstructured data in a scalable and performant way. Fabric notebooks provide a comprehensive, automated solution for data ingestion and transformation, as opposed to manual uploads or data flows, which have some limitations. Fabric notebooks also leverage the Spark engine, which enables a distributed and parallel processing of large data sets. In other words, if you like control, flexibility, and performance when performing ETL operations, and are familiar with one of the programming languages mentioned, then notebooks may be your most important tool in your detective kit. So how do we get started working with notebooks? Glad you asked. Fabric notebooks can connect to and ingest data from a variety of external sources like Azure Blob Storage, Azure SQL Database, Synapse Analytics, and others. You can use Fabric shortcuts to easily access some of these sources, or you can programmatically connect to them using code. For example, to connect to Azure Blob Storage, you can use Shared Access Signatures, or SAS tokens, and construct a path for the connection. To connect to Azure SQL Database, you can use a service principal, which in essence is like your detective badge. It's an identity with permissions attached to it. Then you can build a Java database connection, or JDBC URL, which is a generic Java database connector. You can also use different authentication types depending on the source and security requirements. Once you connect to a source, you can read the data into a Spark data frame and manipulate it as you need. Great, flexibility in connecting to different data sources. Now that we have our data, what can we do with it? Another mystery, detectives. Lakehouses support structured, semi-structured, and unstructured files. Load as Parquet file or Delta tables to take advantage of the Spark engine. OneLake supports a wide variety of file formats, including many formats that are commonly used in Spark code, like delimited text, JSON, not this one, Parquet, Avro, ORC, and others. In most cases, Parquet is the preferred format because of its optimized columnar storage structure and efficient compression capabilities. Parquet is also the base format on which Delta tables in a lakehouse are based. To write data to a lakehouse, you can use the write method and specify the format, mode, and path or table name. For example, to write a data frame to a Parquet file, you can use the write.parquet method shown here and provide the output path. Delta tables are one of the key features of Fabric Lakehouses. You can easily ingest and load your external data into Delta table via notebooks. Delta tables are covered in more depth in another case, so use your investigating skills to track it down. For enterprise-level data scenarios, write optimization is key. Consider these optimization functions for even more performant data ingestion when writing data to Parquet and Delta-type files. V-order enables faster and more efficient reads by various compute engines such as Power BI, SQL, and Spark. V-order applies special sorting, distribution, encoding, and compression on Parquet files at write time. The optimized write improves the performance and reliability by reducing the number of files written and increasing their size. It's useful for scenarios where Delta tables have suboptimal or non-standard file sizes, or where extra write latency is tolerable. Before you move to the next steps of your data analysis and modeling, you should consider who will be using the data and how they'll be using it differently. Different users and roles may have different preferences and requirements for data ingestion and transformation. For example, data scientists may want to access the raw ingested data and explore wide tables with minimal changes. They can use Fabric's Data Wrangler to interactively explore and data and generate transformation code for their specific needs. On the other hand, data analysts may need more transformation and modeling before they can use the data in Power BI. They may prefer more narrow tables with more changes and aggregations. While Power BI can also transform data, starting with well-prepared data allows analysts to develop reports and insights more efficiently. Once again, the trusty DetectoLab 5000 is prepped and ready to apply the knowledge we learned to practice. Ready to wrap up this case? The game is afoot.
Welcome back to our environment. And we're going to talk about notebooks. So we've talked about Spark, we've talked about Delta tables, but we haven't really gone over the notebook experience. And I got to say that, the Jupyter Notebook type, interactive development environment, or IDE, is really one of my more favorite ones, even a little bit better than the Databricks, although it does have its benefits in there. But just to make a point, or just to call it out, is that in order to load notebooks into this environment, it's got to be in an IPYMB format. So IPYMB file extension is what the file kind of looks like. It doesn't really list it as IPYMB here, but you'll know it's a notebook and it has to be an IPYMB file in order for it to do that. I might be able to, if I went into, let's see, I don't think this gets saved in the actual Lakehouse. It just gets saved in the workspace items. So yeah, I don't see it in here, but I do have them in here. So IPYMBs, you can see that I have an IPYMB file extension. As long as it has that in there, you'll be able to load these file into a notebook. If not, then you can always go into convert. There's a lot of different programs and coding that you can utilize to convert files from one format to another one and be able to load it. Just know that it might change the way that it looks when you bring it in. It always seems to do that. So, besides the point, we're here to talk about notebooks, right? So there's a couple ways, or few ways, that we can load notebooks in. We can go directly into the experience, so the data engineering experience, and import notebooks or open notebooks, find our notebooks that way. There's also data science, also utilizes notebook experiences. We can do it there. We can also do it directly from our workspace. So I can open up a notebook or create a new notebook and associate it with that. And if I'm in my Lakehouse item, so if I'm in my Lakehouse itself in the Explorer part, I can open up a notebook. And what this will do is this will actually attach the Lakehouse as a resource or as part of the Explorer. So when it's going to look up files and you're naming file paths in the notebook, it'll know that that's where I'm trying to pull the files out of. But just to show what that means without that, we'll go into this and we'll just open up this notebook, which has been already saved in here. So when I see the Explorer, see there's these resources. So I have built-in resources, which I don't have any yet. And I have Lakehouses, which I do. So what I want to do is I want to add this Lakehouse data source in here. I have that. I'm going to add it in here because I'm going to be working with this. So what I'm doing here is I'm attaching this to it so that it knows now that I have one item added. So if I'm referencing file paths in here, then it knows where to grab it. Or if I'm referencing tables, it should be able to grab that from the Explorer, right? Because I have those fact sale, dimension date, and dimension city here in my tables. Boom, I know that this is happening. So the first thing I need to do is make sure that I'm associating this with the file paths that are being identified in here with the resource that I have connected. All right, notebook experience itself. Notebooks in and of themselves have, I mean, if we went through the ribbon, we might as well just go through that. I can save, I can download, I can change settings, I can run all the cells, or I can run cells below, above or below. When the session starts, and usually when you execute the first cell is when it attaches to a session. So it's attaching to a Spark session, a Livy session, so or managed by Livy or Livy or whatever you want to say in that. And then that's what we execute off of. So there's a certain core capacity that is that is reserved for your session. So if somebody else wants to run in that session, they may go over core requirements or something like that. So always make sure that when you're done, now these will automatically stop after there's a timeout that usually occurs with these, where it'll stop the session. Anything held in memory at that point will disappear. So keep that in mind. But when you stop the session, then you're freeing up those compute options for somebody else to run it, or for another process to run it. But those are things like high concurrency and vertically scaling or horizontally scaling your nodes out can help alleviate that. All right, so default language. We have 4 languages that we can select from. If I was going to create a new notebook, I can define what the default language is going to be in that. So if we're more used to working with Python, we can do that. It's considered PySpark, which is a Pythonic version of Spark. There's Scala, which was what Spark was written in. It's actually a language that was invented specifically to create the Spark engine, which is cool. And it's actually a pretty cool language. I call it a mix of Java and Python, right? Kind of dynamic programming along with this object-oriented programming of Python. So it has the best of both worlds in it. It's a cool language. Like native SQL, we got that. And then also R for all of you machine learning engineers that prefer the R over, or data science engineers or data engineers that prefer R over Python, then you got your stuff too. But that's always an argument that will be around forever. All right, so I can change this is the default workspace environment that's associated with this. If I had created a new environment that may have different libraries on there, then I could utilize that one in this. But in this one, the workspace default should apply. And then there's also another couple options that I can do. I can actually open up this notebook in my desktop version of VS Code or the web version, but I would, you got to make sure that you have permissions in VS Code to access. So there's a whole authentication thing that needs to happen from me working in Fabric in my own local notebook to doing it here from this web browser. So there's probably going to be some configuration you'll need to set up in the back end. Not saying that I couldn't do it from here, but I'm not going to try to break anything. All right. So we have the session, or we have our Lakehouse associated with this. So I know it's going to be pulling all the files or whatever it's calling out from my Lakehouse. I know that that's going to happen. So what I'm going to do is kind of go over the notebook experience itself. All right. And there's a few things I want to cover. Number one is the ability to highlight. So when you highlight one, it highlights all of the words that match that in the same cell. So that makes it really easy for me to find out where, if I set variables like df dimension date, if it's getting called out anywhere else in that cell, right? You can see that I got it in here and it's being called out a couple times. It just doesn't go by more than one cell. So that's one thing I can do. One of the other things that's contained within this is the ability to use IntelliSense. And the IntelliSense is really nicely built into this. So I can, start typing something out and then type something else out, and it will start thinking of what I want to do next. So if I wanted to hit another configuration object, I can do that, and then I hit that, and then set usually comes afterwards. And then when I run the arguments, it's telling me what arguments are required and what arguments are not required. Right? And it may already set those for me at some point, but that's the IntelliSense that's built into this. So I can tab complete. It does a really good job of taking a guess on what I think I want to be doing in this. And it's nice to have. Another cool thing about notebooks that's different than other IDE formats is the way that we can utilize Markdown language. So this cell up here at the top is a cell. It's just like this. It's just not a code cell. It's a markdown cell. So if I double click on this, you can see that this is just text that I'm inserting here. And it even gives me the option to format the text. And it uses, I believe, HTML5 to kind of render the markdown cells after it's done. But when I click out of it, that's what how it ends up resolving. So this is a certain heading value, these signs here, and this is just regular text. Although I'm adding in things like these underlines will write it in a certain way. I think that might be italics or something like that. But again, it renders out. Now, what happens when I execute cells? Like if I were to execute all the cells, it can identify a markdown cell and it'll just skip over it. Now, another thing about notebooks is that it does execute all these cells in order. So I can't just skip one and come down here and select another one. If I set a value in here that's being called upon, like this dimension date, if I were to call on this dimension, if I didn't run this cell and I tried to run this cell, it's going to kick back an error saying it can't find DF dimension date because I hadn't executed this cell yet. So if a variable hasn't been set or something else is dependent on a previous cell, then it's going to kick back an error if it gets run out of order. So the cells get executed in order. Even when you manually run them, you'll want to run them in order. Unless you purposefully do something different, that's your business, right? All right. Now, I can also add code cells and I can also add additional markdown cells to my notebook. So if I want to add a code cell, I can do that. I can delete it. I can add a markdown cell and it gives me those options that I have here. And then I can delete it. And then I have options within the cell. So I can convert this to a markdown cell or switch it back to a code cell. See, it just thought whatever this was to text. I can also clear the output for a cell. I can add comments, and these comments get saved with the notebook. So when another data scientist or data engineer comes in here, they can read the comments associated with this, add their own, and we're all collaborating with the same stuff. I can lock a cell. I can freeze a cell. I can also toggle this into a parameter cell. So when we talk about pipelines, this is one way that I can actually incorporate parameter values that I want to generically create in my notebooks that get called out from a pipeline. So I can make my pipelines dynamic by applying a parameter, toggling this into a parameter cell, setting a generic parameter value in here, and then changing that parameter in the actual pipeline without me having to go in and change the actual notebook itself, which is awesome. Now I don't have to change. Now my pipeline is dynamic, or I've made my notebook dynamic so that my pipeline can change based on what I'm trying to execute here. That's a little out of scope, but just wanted to point that out. There's also some other things that I can do with here, like I can move it up, down, hide certain things, or split it or merge it with another cell if I wanted to. All right, enough of that. We're going to execute this stuff. Now, I went over this in the Delta, creating Delta tables, but just so I'm explaining what's going on here. First of all, we created a session, and the session started very quickly because there's always going to be a node in the back end ready to go for this environment. What I'm doing is I'm setting configuration settings. And I'm enabling vOrder and I'm enabling optimize writes so that anytime I'm writing to a Delta table, it's performing compression techniques and partitioning techniques that are designed to work best with the Delta format of the SQL endpoints and downstream processes that I'm going to be utilizing from Power BI if I'm going to use reports for that. So that's what enabling that does. This is just more of me ensuring that it's there, but I'm also setting a bin size for the write files to say, this is what I want to max this out as. If it goes over that amount, just create a new partition for it, right? New file for it, so to speak, right? So here's what we're doing in here. What I'm going to do is I am creating data frames. I'm creating 3 different data frames. So if you remember, reading data in, I thought I had this associated with this. WWI, oh, I know why it's that. I know why it's that, because I named it something else. Right? I named it sample LH1. Look at this. I can't use the, love it. Love it. Love errors because it makes me think, right? Makes me think. So we got to change this. All right, that should do it. Let's try. If I get an error 2 times in a row, that won't be good. It looks like it's running it now. So what we're doing here, see, I know how to fix stuff. I'm not just talking. All right. So what we're doing is we're running a bunch of Spark read operations. So I'm converting all these into data frames. I'm not displaying any of them. I'm just holding them in memory. So I've created a data frame called fact cell, dimension date, and dimension city. These are all data frames now. They're still tables in my Lakehouse, just in memory now. I'm pulling that data in and converting them to data frames so that I can perform Pythonic or Spark-related data changes to them. So because I have these in a data frame method, what I'm going to do is apply a bunch of different stuff to them. I want to make sure that I got the right, make sure that my, okay, so I don't see any WWI Lakehouse in here. Okay. And what we're going to do is we're going to execute this by Python because I got these in data frames. So dimension city, where's that? So I got dimension city here. I got dimension date here. And I'm joining these with fact sale by fact sale dates. So I'm essentially taking these tables and creating new data frames, a new data frame called sale by date city, and applying this. And all of these, by the way, whenever you see these dots, these are chaining. So I'm chaining all of these aggregations together or chaining all these methods together. So I'm performing a bunch of join operations here from these dimensions to the fact sale. And then I'm selecting certain columns out of those tables. I'm grouping them by other or the same dates in those, or the same columns in those in those tables. I'm applying aggregations to it. So now I'm creating total amounts, right? Totals with the sum function. And then I'm changing column name. So this sum of this, total excluding tax, I'm going to rename that to a table called sum of total excluding tax and sum of tax amount, so on and so forth. And then I'm going to order by a certain date. And then I'm going to take this data frame that I just wrote. So this should be a data frame that contains all these aggregations and joins. I'm going to externalize that to my Delta Lakehouse or my Lakehouse as a Delta table named sale by date city, right? And if it's already exists, I'm going to override it. So that's essentially what I'm doing here. I don't think this should take very long. I know we're performing a lot of join operations on different tables, and that's what it's going to go through. The fact table is a larger table, so performing the join operations on that might take a little bit of time because I'm joining it by city key in the date on this one. So there you go, 34 seconds. That is not bad for me to perform all these join operations, aggregations, column renaming, and then sending this table to my actual Lakehouse. So what should have happened here is that when I go into my Lakehouse now, I have this aggregate sale by city, and it should have all of that, whatever aggregations I created, sum of total excluding tax, sum of profit. So these were what I added. These were those sum values that I added to the data frame. And since I already have dates and key values to this, I should be able to create relationships between this and other tables. So notebooks, right? Just thinking of anything else. Oh, by the way, when these outputs do get done, you could see that how many jobs were associated with this one execution. There's 29 jobs, right? And different stages associated with each one of these. All of these go as what they call a directed acyclical graph. And you could see, so I could go through step by step, and all this information is logged, by the way. So this is just more data I can analyze and see how long it's take for a compute to run. But I can go through these jobs and see the directed acyclical graphs for these from the Spark user interface. And it'll show me, the step-by-step, the stages that it completed, what happened during that. So I can get a lot of information off of the log files when these have happened, right? Here's the log files here. So it tells me what happened. I can also view resources associated with this. This is going to happen. So you'll always get an example of what's happening within these different jobs, and always get an output of at least what happened in the Spark job. But unless I'm explicitly telling it to output something, most of the time it isn't. The other thing I wanted to go through on notebooks, and maybe this is probably repeat information, is the ability to utilize magic operators within our cells. So I mentioned this before, magic operators can change languages. They can do other things. They can write to folders. They can write to files. They can do other things at the beginning. So I can create folders for something, and it'll just write to that folder. A single percentage point only applies that line. You see how all that disappeared? Now, if I were to write SQL language here, let me copy this, just show you. Copy and paste. I thought maybe it would include that there. But usually when it's 1%, it applies to the same line that the magic operator is in. When you use 2% within it, then it applies it to the entire cell. And that's why everything kind of turns blue here, because now it's saying that I want to want to utilize SQL now in this. Now, how will I be able to do this? Oh, and by the way, it is calling on some, see this? Boom. So what I need to do is I need to change this, right? Sample LH1. This one. Boom. So I have all that changed. Now remember, I don't have any data frames created. I haven't changed anything. But if you remember, I already have tables. Now I can't perform native SQL operations unless it's in a table format. Fortunately, they're in a Delta table, right? So I should be able to run native SQL on these tables that have already been applied into my essentially my Lakehouse warehouse. So when I go back into here, what I'm going to do is I'm going to create a temporary view called sale by date employee. And then I'm going to be performing a select, and again, providing some, did I already have that? I just want to make sure I'm sale by city. So that's sale by date city. So that's not the same thing, right? We're doing this by employee. But still, I'm going to provide some values, right? And then rename them certain columns. So I'm still going to add additional information like I did with the cities. But this time we're doing this by employees. I don't have this table yet, But since I'm calling on tables that are already in a table structure, like dimension date, dimension employee, and the dimension fact, this should go ahead and be able to process it because it's in that table format. So now I'm creating a new table, again, called sale by date employee. And that only took 4 seconds to run. So now when I go back in here, I should be able to see a sale by date employee. Maybe I need to refresh it. Did it finish that? Let's see. Order by, create or replace. Oh, because it's in a view. That's why. That's why I can't see it, because it's in a view. If I would have created a regular table, I would be able to see that table. Now, because I've created the view, I should be able to see it here. Oh, actually, there's one. See, I'm forgetting a cell. So now I'm doing select all of these from a view. Sometimes you want to write a temporary view so that you can perform a sanity check on it before you put it in a production level table. That makes sense. I think that's the thinking here. And what we're doing is then we're going to select everything from that table, right? So I'm using spark.sql context. This is another way that we can use Pythonic methods in the Spark engine to perform SQL queries on data. So this is just a string value that is a SQL query that I'm using the SQL method in order to parse through. Then I'm going to write it to a Delta table called aggregate sale by date employee. This will add the table into my Lakehouse. I didn't have it because it was a temporary view. So forgive me for that. So what I'm doing is I'm essentially pulling all the data out from that view, and I'm going to create a Delta table out of it. And that job's done. So now when I go back in my Lakehouse, now I should have another table. Sale by employee. So there we go. So that's notebooks. Notebooks are really great, especially these markdowns, because you can add different, you can add so much more detail into what you're doing from a step-by-step approach. It makes it easier for somebody to come back in and see what you've done with this. So the benefits of being able to create markdown cells and code cells, along with tagging parameters, utilizing IntelliSense and changing languages in between cells, is just makes notebooks a great and dynamic way of everybody that works with different coding languages, whether that be SQL or Python or Scala or R. All of them can work with the same data in the same place in the same format in a notebook. So they're pretty awesome. That does it for this. Let's head back into the studio.
Congratulations, detectives. We unlocked the mysteries of Fabric notebooks to ingest and transform data from various sources, write data to a lakehouse in different formats, optimize performance and scalability, and consider different users and roles for data ingestion and transformation. Now, where did I put my notebook? Forget it, I have Fabric. Thanks for joining. Welcome to the Detecto Olympics. I have my medals. And yes, I do use the word Detecto a lot. It's fun to say. My name is Jason Richards, Microsoft technical trainer and data detective. Yes, Detecto Olympics isn't a real thing, but it's a great way to grasp the concept we'll cover. We're going to investigate a data design pattern called the medallion architecture, which helps you organize data in a lakehouse logically and improve its quality as it moves through different layers. This pattern can make your data more reliable, consistent, and easy to analyze for various downstream tasks. We'll look at clues covering what a medallion architecture is, how to implement it, how to secure it, and how to achieve continuous deployment of the architecture. Join me as we dive into the case of the mysterious medallion, where we'll transform raw data into gold. Ready to crack the case? Let's go. Data lakehouses in Fabric are built on the Delta Lake format, which natively supports ACID, atomicity, consistency, isolation, and durability types of transactions. Within this framework, the medallion architecture is a recommended data design pattern used to organize data in a lakehouse logically. It aims to improve data quality as it moves through different layers. The architecture typically has 3 layers: bronze, or raw, silver, which means validated, and gold, or enriched, each representing higher data quality levels. Some people call it a multi-hop architecture, meaning that data can move between layers as needed. This architecture ensures that data is reliable and consistent as it goes through various checks and changes. It also guarantees that the data is safely stored in a way that makes it easier and faster to analyze. The medallion architecture complements other data organization methods rather than replacing them. You can think of the medallion architecture as a framework for data cleaning rather than a data architecture or model. It ensures compatibility and flexibility for businesses to adopt its benefits alongside existing data models, allowing you to customize data solutions and preserve expertise while remaining adaptable in the ever-changing data landscape. So that's an overarching look at the medallion framework. But what about these layers? The bronze or raw layer of the medallion architecture is the first layer of the lakehouse. It's the landing zone for all data, whether it's structured, semi-structured, or unstructured. The data is stored in its original format, and no changes are made to it. The silver or validated layer is the second layer of the lakehouse. It's where you'll validate and refine your data. Typical activities in the silver layer include combining and merging data and enforcing data validation rules like removing nulls and deduplicating. The silver layer can be thought of as a central repository across an entire organization or a team, where data is stored in a consistent format and can be easily accessed by multiple teams. In the silver layer, you're cleaning your data enough so that everything is in one place and ready to be refined and modeled in the gold layer. The gold or enriched layer is the third layer of the lakehouse. In the gold layer, data undergoes further refinement to align with specific business and analytics needs. This could involve aggregating data to particular granularity, such as daily or hourly, or enriching it with external information. Once the data reaches the gold stage, it becomes ready for use by downstream teams, including analytics, data science, or machine learning operations. Depending on your organization's specific use case, you may have a need for more layers. For example, you might have an additional raw layer for landing data in a specific format before it's transformed into the silver layer. Or you might have a platinum layer for data that's been further refined and enriched for a specific use case. Regardless of the names and numbers of layers, the medallion framework is flexible and can be tailored to meet your organization's particular requirements. Think of it, you could have titanium, vibranium, adamantium, the nth metal, all these different layers. All right, that's overkill, but you get the point. Onwards. Moving data across medallion layers refines, organizes, and prepares it for downstream data activities. And there's more than one way to move data between layers, ensuring that you can choose the method that works for your team. Here are a few things to consider when deciding how to move and transform data across, and understanding the difference between data transformation and data orchestration helps you select the right tools for the job within Fabric. Data transformation involves altering the structure or content of data to meet specific requirements. Tools for data transformation in Fabric includes Data Flows Generation 2 and notebooks, kind of like the athletes participating in the Detect Olympics, on the front lines doing the work. Data orchestration refers to the coordination and management of multiple data-related processes, ensuring they work together to achieve a desired outcome. The primary tool for data orchestration in Fabric is pipelines. And these would be like the coaches for the athletes, orchestrating activities to accomplish goals. Now that you have a solid understanding of the medallion framework, let's investigate the clues for how to put it into action within Fabric. I mean, after all, we're still detectives. First step, create your Fabric Lakehouse, obviously. You can use the same Lakehouse for multiple medallion frameworks, or alternatively, you can use different Lakehouses and even different Lakehouses in different workspaces, depending on your use case. We'll dive more into this in a bit. Next, design your framework layout. Define your layers and determine how data will flow between them. The most straightforward implementation is to use the bronze as the raw layer, silver as the curated layer, and gold as the presentation layer. Then we need to determine how we will move the data through our layers, like how you'll ingest data into your bronze layer using either pipelines, data flows, or notebooks, and how you'll transform data into your silver layer. You can do this using data flows or notebooks. Transformations at the silver level should be focused on data quality and consistency, not necessarily on data modeling. The gold layer is where you'll model your data for reporting using a dimensional model. Here you'll establish relationships, define measures, and incorporate any other elements essential for effective reporting. You can have multiple gold layers for different audiences or domains. For example, you might have multiple gold layers by use case or by department. Here we'll go with use case. We also need to implement how you'll enable downstream consumption of your data. You can do this using workspace or item permissions, or by connecting to the SQL Analytics endpoint. Here we're going to connect this folder to an Azure Machine Learning Workspace data store to perform machine learning on it. And here we're creating enriched files that can be easily landed into a data warehouse solution. Something else to consider is availability. We may be relying on several processes that can fail at any time and should have redundancies in place for those types of situations. During ingestion and transformation operations, enable checkpoint storage locations to ensure that if a failure occurs, we can prevent substantial data loss. Now that your medallion framework is in place, data teams and the businesses can start using it to query and report on data. Fabric has several tools and technologies that enable you to query and report on data in your Lakehouse, including the SQL Analytics endpoints and direct lake mode in Power BI semantic models if it's in premium capacity. The SQL Analytics endpoint in Fabric enables you to write queries, manage the semantic model, and query data using the new visual query experience. The SQL Analytics endpoint operates in read-only mode over Lakehouse Delta tables. To modify data in your Lakehouse, you can use data flows, notebooks, or pipelines. You can also use the SQL Analytics endpoint to connect to your Lakehouse from third-party tools and applications. In addition to using the SQL Analytics endpoint for data exploration, you can also create a Power BI semantic model in direct lake mode to query your data in your Lakehouse. When a Power BI report displays a data element, it fetches it from the underlying semantic model, which in turn accesses a Lakehouse for data retrieval. To enhance efficiency, the default semantic model preloads frequently requested data into the cache and updates it as necessary. This approach is called direct lake mode and truly gives you the best of both worlds, the performance of a semantic model and the freshness of Lakehouse data. So, building the medallion framework, check. Using the data from our medallion framework, check. Next, we'll share a couple of considerations to keep in mind when managing your Lakehouse, including how to secure your Lakehouse and how to handle continuous integration and continuous delivery, otherwise known as CI/CD. You can secure your Lakehouse by ensuring that only authorized users can access data. In Fabric, you can do this by setting permissions at the workspace or the item level. Workspace permissions control access to all items within a workspace, whereas item-level permissions control access to specific items within a workspace and could be used when you're collaborating with colleagues who aren't in the same workspace, or they only need access to a single specific item. you can strategically store different layers of your lakehouse in separate workspaces for improved security and efficient capacity management. This approach not only enhances security, but also optimizes cost effectiveness. Also, access is an important security consideration. You should define who needs access at each layer, ensuring only authorized personnel can interact with sensitive data. Some examples are provided here on suggested access at each layer. Sharing of Fabric content should be discussed with your organization's security team to ensure that it aligns with your organization's security policies. Defining a continuous integration and continuous deployment process for a lakehouse architecture involves several considerations to ensure a smooth and efficient deployment process. Some considerations are listed here. While some of these are related to processes and practices, others are related to the tools and technologies used to implement CI/CD. Fabric natively provides several tools and technologies to support CI/CD processes. Git integration in Microsoft Fabric enables you to integrate development processes, tools, and best practices straight into the Fabric platform. Fabric's Git integration enables data teams to back up and version work, revert to previous stages as needed, collaborate with others, or work alone using Git branches, and leverage the capabilities of familiar source control tools to manage Fabric items. CI/CD is crucial at the gold layer of a lakehouse because it ensures that high quality, validated, and reliable data is available for consumption. Automated processes enable continuous integration of new data, data transformations, and updates, reducing manual errors and providing consistent and up-to-date insights to downstream users and applications. That enhances data accuracy, accelerates decision-making, and supports data-driven initiatives effectively. Way to earn those medals. Now it's time to roll up our sleeves and hop back into the Detectolab 5000 to put knowledge into practice.
Here we are in our environment, and we're going to be talking about the medallion architecture. So let's get this set up in our system, in our lakehouse here. First, we were going to navigate to the lakehouse. So I got my workspaces. Let's get into the workspace. We have our lakehouse down here. We'll go into our lakehouse. And the plan is that we're going to add this into our files. Now, there's a couple ways that you can approach this, and you can approach it however you want. There's no wrong way to do it. Well, there's probably several wrong ways to do it, but there's a few right ways. There's a few ways that you can do it besides doing it this way. Is that you could do it in the actual storage account associated with this. Maybe set up the folders in your OneLake Explorer. But here we're going to do it through our files so that everybody that's in the environment and has access to this lakehouse can see the different folders. Now, in order for us to create our processes, first we need to create the folder paths, right? So that's what we're going to do first. In our files, we're going to add a new subfolder, and we're going to call one bronze. And then we're going to call another one silver. And I'm not going to create a gold one. And there's a reason for this. The reason I'm not going to create a gold in the files here is because typically the gold standard is going to land, or it sometimes is going to land in the actual service that the data is going to be used for. Now, yeah, you could create another file, a folder here for gold, but we're providing a simple example in this demo. So I'm just going to add a table to the actual lakehouse itself, and that will be my gold. Now, again, there's different ways that we can do this, but from here, I would be reporting it from the actual lakehouse. So you could apply your gold to a folder level, or you could apply your gold to the individual, the tables itself. I can't create subfolders in my table, so I can't create a gold table standard here. So I'm just going to apply this into my gold standard or my gold folder level of the medallion framework into the actual into the actual tables itself. So how are we going to do this? I like automation. So if I go back into my workspace, I'll show you that I do have a pipeline that I've created that's going to set this stuff up for us. And fortunately, I already have the folder paths. Once I've created the folder paths, these are identified by these folder paths. So I'm just going to execute the pipeline and then show you what's in here. Now, this is a two-stage pipeline. We have a copy data stage and we have a notebook stage. So I'm going to execute this and then I'm going to show you what's happening and just reinforce the concepts as we're doing this. So obviously I could schedule this pipeline, right? So if I wanted to automate this process, maybe do it on a daily or a weekly type of scenario where we're constantly searching for the files in our in whatever system is producing the raw data and then moving the raw data into our bronze folder, then we can do that. Or we can just manually run it, which is what I'm going to do now. So I'm going to run this notebook and you can see that it's queued up. And then once it starts, it'll show down here that it's queued up and it'll start processing it. But let's look at the steps in here and I'll show you kind of what's going on with this. So in the actual copy tab, I have my source and destination. These are going to be the main points to consider here is I need a source and a destination. This is going to land in our bronze. So this is just the raw data. So I'm essentially connecting to some sample data in a storage account. That's what this symbol right here represents, is a storage account. And I'm calling on a specific file path. In this case, we're pulling in a New York City taxi data set. It's yellow cab and green crab information from New York City cab service with different columns representing fares and distances and things like that. Where's it going? Well, we're just ingesting the raw data. So I've identified the bronze path as the file path for this. So what's going to happen is it's going to pull all the sample data in. If there was updated sample data in there, it would upload that and then it would overwrite any existing folders or files that are in this bronze level. Sometimes you might not want to do that. Sometimes you might want to set up a process where it's writing new files, and you can do that within here, but this is just a simple demo. And that's the copy data phase. So the notebook phase, you can see that there's a notebook, and I have to get into it to actually show you what it's doing, but I'll show you the settings. I have a notebook called New York City Taxi Clean. So in order, the purpose of the silver level folder is to hold clean data. And I'll show you what we're doing with this in the notebook itself while this is executing. By the time I show all this off, then it should be done. So let's get in this actual notebook itself and show you what's going on with it. So in the notebook, you can see that I'm pulling in the data from that 2000, from the bronze level. Now, when the data is loaded in, there's several years worth of New York City taxi. I think it goes from 2018 to 2020 or 22 or something to that effect. Now I'm only pulling in 1 year of data for this. And this is just, like I said, this is just an example. You could set up processes. In fact, for your pipeline, this would be a great way to set up like conditionals. So if I went back to my pipeline and I could set up like conditionals, once this step is complete, I could do an if then right here. And if a file equals 2019, I can run it through one notebook. If it equals this, I could run it through a separate notebook, so on and so forth until it's all done. All right, but let's go back in here. So I'm loading in specifically the data from the 2019. Now you could see that that first step had already completed in here. So when I go back into the pipeline itself and I refresh this bronze file, there should be several years in here. So I got 2018 to 2023 data. So I'm just worried about, for this demo purpose, the 2019 stuff. All right, so that's what I'm pulling in the notebook here, right? Just pulling in, creating a file path, and then reading in the file path. It is in a Parquet file format, which is nice. And then I'm displaying the results just as a sanity check to see what the column names are and what things I could possibly do with this. Now you can see this airport fee, most of these values are null, and they might all be null. So there's something that I could probably handle right there is I'm going to get rid of that airport fee. I don't think it's going to apply too much for what I'm going to use it for. So we could drop columns, unnecessary columns that, and keep in mind that when we're thinking about silver level, we still want everybody to be accessing the data. So typically like dropping columns and selecting certain columns may not be part of this process. We just mostly want to clean the data, meaning we want to get rid of duplicates. We want to get rid of or figure out what to do with null values or sometimes people put negative values in data sets in order to do this, and we want to get rid of that stuff. I'm taking this a little bit further, and if you remember, we can chain methods together, chain Python methods together. So I'm actually doing that. Starting off with the drop duplicates, which will get rid of any, it'll parse through the data frame and look for any duplicate values, and it'll drop those rows. And then I'm also dropping that airport fee column. Once I drop that and it executes these in order, then I have another one where it's going to identify NA values or null values, and then it's going to drop the rows that still contain any null values from it. Now, again, we may not want to essentially drop null values. This is just an example of what we could do. A lot of times we might want to encode those values with a median value if it's numbers or something else. That's something that needs to be decided on before you put this into place. And again, I'm going to display it as a sanity check, right? So here's that data. You can see that the airport columns is gone, and there might be fewer rows or something like that in there because of the null values that were removed. There's ways like you could do a data frame describe, and it'll give you statistical information about this. I'm taking this a step further, this cleaning process. I'm actually going to, and if you saw the visualization exercise, this is kind of the same thing. I'm going to use a Spark SQL method and do a select. So I'm filtering out certain columns out of this, and I'm creating new ones, right? So I'm creating I'm taking the hours out of this and creating hours of the day, day of the week, and day of the month. These columns are going to get added to the data set. And I'm also applying a filter where they have to meet these, since there's ands in here, it has to meet all of these standards in here in order for this select operation to occur. So it's going to filter all this data out, and then I'm going to write this into my silver folder. Now, again, we may want to wait to do this until we get it into gold standard. It really depends on who it's going to write then. Silver level or silver folder, we want just the clean data that everybody can use, no matter what data team it is. When you go into gold, that's when we want to aggregate, filter, and enhance the data for specific purposes like machine learning, like warehousing, so on and so forth, so that those teams have an easier job of what they need to. All I need to do at that point is create tables and load them up, right? And that's great. So we're going to load that into our silver folder. We're also going to, at this point, so this is silver. I've taken this notebook a step further. And again, this is something that you could separate into another notebook or another type of task or whatever, or activity that you want to include. It could be a stored procedure for SQL or something like that in our pipeline. But in this case, I'm using Python notebooks. I'm going to aggregate this. So what I'm doing is I'm going to add a column called fare by mile. And what this is going to do is it's going to take the fare amount divided by the trip distance, so we can get like an average fare per trip. So you can see here that it did that. This is called feature engineering. So I can take multiple columns and create new columns out of them. Sometimes I'll see this a lot with exponential values. If it's between 0 and 1, sometimes exponential values for machine learning processes can find significant, correlations in data and new discoveries. And then we're going to call this, we're going to name a table called Fact New York City Taxi Data, because these are transactional information. And then we're going to overwrite any existing tables. You can see that I'm applying this to a Delta format. I'm going to partition it by the payment type. Why? Because there's two types of, because when you go through your data and you look at this, there's going to be 30 days of the month, there's going to be 7 days of the week, there's going to be 24 hours of the day, and then there's going to be all these different other values. When you decide on a partition key, you want to split the data as evenly as possible between the partitions. So based on all of these columns, it seemed to me that the best option, now vendor ID might be another one, depending on how many vendors there are. This would have been a good choice for a partition. But I chose payment type because it looks like there's only 1, 2, or 3 different payment types that they can choose from. So this should write 2 different partitions for the data, which should be enough for what we're doing. Let's go back to our pipeline here. So you can see that the run succeeded. So now I can go back in to my Lakehouse here. And we already determined that our bronze worked because I got my files or my folders here. Now let's look at the silver level. I'll refresh, let me refresh the whole dang thing. And then we'll take a look at this. So now when I go into silver, you can see that now I got my 2019 silver level, right? And you can see that I have my data written into that Parquet file format. And I also have my fax sale that was created from that aggregation that I put in. Not this one, the New York City taxi. So fact New York City taxi. Now I have all this in a table and I can start performing analytics on it right away. So that's the purpose of a medallion architecture or medallion framework, is to set up these levels of standard, because we don't want to get rid of our raw data. We want to hold on to it. Sometimes you even have legal holds and stuff like that where we need to hold on to this data for a certain period of time. And that's what the bronze level's for. Just put it in there. Then we can take this bronze folder, do things like set up lifecycle policies on this particular folder, where after 30 days it'll get sent to a cool tier, and then finally to a cold tier, where it's not going to be used that much. Storage costs decrease at that point when you switch to different life cycles. And then we can just archive it in a vault after, say, 180 days, because we don't think the data is not going to be valid at that point. We're probably not going to use it, but we may have to hold on to that data for a while. But now I don't have to parse through all these different folders and set up these policies within that individually. I can just go to my bronze file and do this. Now that I got my clean data in silver, we would direct everybody to come into silver and then take it for the purposes that they need it. We can even set up our gold processes and send them either directly to the service that it's going to be at, or we could set up a gold folder, separate them by the different departments that are needed, like gold, and then create a subfolder for the gold that is for like machine learning, for warehousing, so on and so forth. That's up to you to decide. And again, we can take this further, make a platinum level, or we could have even a sub-bronze level where it may be JSON data or something that we're going to have to take it an extra step through in order to get it in be able to work with it in a data frame format. So that's a medallion architecture, or the framework, and just setting up a pipeline in order for us to perform those processes.
Great work, detectives. We learned how to design and implement a medallion framework in Fabric, and how to use it for data exploration, reporting, and downstream consumption. We unlocked the clues on how to secure your Lakehouse and how to set up CI/CD processes for your medallion architecture. And yes, these medals are props. I never won a medal for athletic performance ever in my life. I wonder if they'll make medals for Fabric training. Thanks for joining. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Data warehousing workloads benefit from the rich capabilities of the SQL engine over an open data format, enabling us to focus on data preparation, analysis, and reporting over a single copy of their data stored in their Microsoft OneLake. Together, we'll solve the mysteries of Fabric warehouses, including what a Fabric warehouse is, how to design one, creating objects, ingesting data, using semantic models from one, and security and monitoring aspects. Now, that's a full list of mysteries to unpack, so let's start unpacking, detectives. Our first mystery is a fundamental question. What's the difference between a lakehouse and a warehouse? And when would I use one or the other? Wait, that's two questions. Anyway, Fabric's Lakehouse is a collection of files, folders, tables, and shortcuts that act like a database over a data lake. It's used by the Spark engine and SQL engine for big data processing and has features for ACID transactions when using the open source Delta formatted tables. Lakehouse is a great place to enrich and store data, but it's not the best place to serve data to business users. For that, you need a data warehouse. Fabric's data warehouse experience allows you to transition from the lake view of the Lakehouse, which supports the data engineering and Apache Spark, to the SQL experiences that a traditional data warehouse would provide. The Lakehouse gives you the ability to read tables and use the SQL Analytics endpoint, whereas the data warehouse enables you to manipulate the data. In the data warehouse experience, you'll model data using tables and views, run T-SQL to query data across the data warehouse and Lakehouse, use T-SQL to perform data manipulation language, or DML operations, on data inside the data warehouse that always adheres to ACID transactions, and serve reporting layers like Power BI. Mystery solved. If your end goal is analytics reporting, then a warehouse is better suited than a lakehouse. Anything else about the warehouse experience? Glad you asked. Fabric's data warehouse is a relational data warehouse that supports the full transactional T-SQL capabilities you'd expect from an enterprise data warehouse. It's a fully managed, scalable, and highly available data warehouse that can be used to store and query data in the Lakehouse. Using the data warehouse, you're fully in control of creating tables, loading, transforming, and querying data using either the Fabric portal or T-SQL commands. You can use SQL to query and analyze the data, or use Spark to process the data and create machine learning models. A huge feature of the warehouse is cross-database querying, which enables you to leverage multiple data sources quickly and seamlessly for fast insights and with zero data duplication. Data warehouses in Fabric facilitate collaboration between data engineers and data analysts, working together in the same experience. Data engineers build a relational layer on top of the data in the Lakehouse, where analysts can use T-SQL and Power BI to explore the data. In the data warehouse experience in Fabric, you can build a relational layer on top of the physical data in the Lakehouse and expose it to analysis and reporting tools. You can create your data warehouse directly in Fabric from the Create Hub or within a workspace. After creating an empty warehouse, you can add objects to it. Once your warehouse is created, you can create tables using T-SQL directly in the Fabric interface. Like all relational databases, Fabric's data warehouse contains tables to store your data for analytics later. Tables in a data warehouse are typically organized in a way that supports efficient and effective analysis of large amounts of data. This organization is often referred to as dimensional modeling, which involves structuring tables into fact tables and dimension tables. Fact tables contain the numerical data that you want to analyze. Fact tables typically have many rows and are their primary source for data for analysis. For example, a fact table could consist of sales transactions, log data, or sensor observations. Dimension tables contain descriptive information about the data in the fact tables. Dimension tables typically have a small number of rows and are used to provide context to the data in the fact tables. Tables for dates, products, customers, stores, and employees are common dimension tables. In most transactional databases that are used in business applications, the data is normalized to reduce duplication, and it makes sense when dealing with individual transactions. In a data warehouse, however, the dimension data is generally denormalized to better handle aggregations over large amounts of data and reduce the number of joins required to query the data. Often, a data warehouse is organized as a star schema, in which a fact table is directly related to the dimension tables. In most cases, the fact table will contain aggregations of data, which the dimension tables will then filter, allowing analysts to see only what's relevant for insights. If there are lots of levels or some information is shared by different entities, it might make sense to use a snowflake schema instead. A snowflake schema is considered a more normalized version of the star schema. In this case, the dim product table has been split up or further normalized to create separate dimension tables for product categories and suppliers. Also, a dim geography table has been added, containing information on where customers and stores are located. This is also called a bridging table, which can help dealing with dimension tables that require filtering against each other, where there may be a many-to-many relationship. Great work, detectives. We have our objects created and our data loaded into our tables. Time to report. Well, not exactly. We need to build a model for data analysts to generate reports, which brings us to the next mystery, the modeling menace. Let's look at the clues. A semantic model defines the relationships between the different tables in a model, the rules for how data is aggregated and summarized, and the calculations or measures that are used to derive insights from the data. These relationships and measures are included in the semantic model, which is then used to create reports in Power BI. All right, so we need a semantic model. Let's look at how we can do this in Fabric. You can easily switch between the data, query, and model view in Fabric using the menu at the bottom left corner of the screen. The data view shows the tables in the semantic model. The query view shows the SQL queries that are used to create the semantic model, and the model view shows the semantic model. Relationships allow you to connect tables in the semantic model. You create relationships between tables in your data warehouse using a click and drag interface in Fabric in the model view. Measures are the metrics that you want to analyze your data warehouse. Measures are calculated fields that are based on data in the tables in your data warehouse using the data analysis expression or DAX formula language. Building out the semantic model is a critical component to preparing your data for use in downstream reporting. To simplify things for your report builders, you can hide elements from view, either a table or a column. Hiding fields removes the table or column from the model view, but it will still be available for use in the semantic model. Every time a data warehouse is created, Fabric creates a default semantic model for analysts and/or business users to connect for reporting. A semantic model has metrics that are used to create reports, and semantic models are automatically kept in sync with the data warehouse, so you don't have to worry about maintaining them. You can also create custom semantic models to meet your specific needs. In Power BI, a semantic model is always required before any reports can be built. So the default semantic model enables quick reporting capabilities on top of the warehouse. The default semantic model inherits business logic from the parent warehouse, which initiates the downstream analytics experience for business intelligence and analysis. New tables in the warehouse are automatically added to the default semantic model. Users can also manually select tables or views from the warehouse they want included in the model for more flexibility. Objects that are in the default semantic model are created as a layout in the model view. For report readability purposes, it's always a good idea to rename columns to more user-friendly names, as well as hide objects that users won't need to view. Okay, Jason, we have a Fabric warehouse, properly formatted a schema, we ingested data into our tables and built a semantic model. Now can we report? Yes, we can, but reports are just the start. Let's look. Fabric enables you to visualize the results of a single query or your entire data warehouse without leaving the data warehouse experience. Exploring data while you work to ensure you have all the necessary data and transformations for your analysts is particularly useful. And yes, reports. Use the New Report button to create a new Power BI report from the contents of your entire data warehouse. This opens the Power BI service experience where you can build and save your report for use by the business. All right, detectives, that covers all the fun stuff regarding warehouses. I imagine at this point your biological data warehouse is reaching max capacity, but hang with me for our last case to solve on this topic, the security sleuth. Security is a critical aspect of managing your data warehouse. Fabric provides several security features to help you secure your data warehouse, like the ones listed here. Access, encryption, and auditing are critical for any solution, and implementing security features like the ones listed are just as important. Data in Fabric is organized into workspaces, which are used to control access and manage the life cycle of data and services. Appropriate workspace roles are the first line of defense in securing your data warehouse. In addition to workspace roles, you can grant item permissions and access. This enables you to share a single data warehouse for downstream consumption. You can grant permissions to users via T-SQL or in the Fabric portal. You can grant the following permissions to users who need access to your data warehouse. The read permission allows the users to connect using SQL connection strings. The read data allows users to read data from any table or view within the warehouse. The read all allows users to read data from the raw Parquet files in OneLake that can be consumed by Spark. And build allows the shared recipients to create reports on top of the default semantic model that's connected to the warehouse. A user connection to the SQL Analytics endpoint will fail without at least the read permission at minimum. Granular permissions can also be set within the warehouse itself using T-SQL. Common permission settings are object, column, and row level security, as well as dynamic data masking. And always remember to use the principle of least privilege when considering access. Leverage permissions accordingly, and keep in mind that you can apply these permissions to intra-ID groups as well as individuals. Now that we covered at a high level what a Fabric data warehouse experience is, let's put knowledge to practice and deploy a warehouse in the Detecto Lab 5000.
All right, back in the environment. Now we're going to create a warehouse, which really doesn't take too long in Fabric, but I want to also kind of outline the differences between the Lakehouse and the warehouse as well, just to give you those nuances between the two and what the visual interface at the time of this particular demo is being presented. User interfaces change all the time, so you know the way things show up in Fabric may differ based on when you actually watch this and when you're applying these techniques to it. So I'm here in my workspace. Now I can create a new warehouse in several different ways. You know, I could go into data engineering. I could even go into data warehouse here from my experiences and create a new warehouse from the data warehouse experience. I can also just go into my workspace, look at more options, and create a warehouse from here as well. And that's what I'm going to do here. Now I'm going to call this World WWI WW Importers. Or we'll just call it Worldwide Importers. Importer, Worldwide Importer. All right. And then we'll go ahead and hit create. And that's really it. I mean, this Fabric in and of itself is going to create the SQL endpoint for us to work with in this. And if you're comfortable working with, you know, tools like, you know, SQL Server Management Studio, something like that, then this gives you that a little bit of that more warm fuzzy feeling. Yeah, it's a little watered down, isn't quite feature rich as what SSMS is, but you could see that I have my worldwide importer and I have my schemas, my security, like my roles. You know, I can create roles. All this makes me feel good in SQL. And then my queries pane and then my shared queries. Up at the top, you can see I can refresh this. There's settings that I can look at and apply. Here's my SQL connection string. So if I need to connect to SSMS, which we'll do in another demo, will connect to SSMS or other third-party tools, then I have this SQL connection string, and I can use my intra ID credentials or my email credentials in order to log in with that. I can also set sensitivity labels for this. We'll just set this to all employees, right? And then endorsement, I can promote it. I can't certify it because I'm not the tenant admin, but then we can sync the default Power BI semantic model with the workspace. That's one of this is also a great part or a great feature about this data warehouse experience is that I have a default Power BI semantic model that's created with this. Now I can sync the objects. So if I create new tables, new objects, new columns, new things like that, it will sync with the default semantic model. And default semantic models are great for quick reports. It's not really great for doing a lot of customization with it. But if I wanted to do quick analytics on something, then syncing this default Power BI semantic model is going to be nice. I'm not going to do that, but I do want to show that. So those are the settings. Now I can get data through new data flows or pipelines. I can also, if I wanted to, I could send, notebook. I can work with notebooks as well and send it to the warehouse. I can create new SQL queries with this and new visual queries. We'll do that in a later demo, but this is where we can create those objects, right? And this just expands the ribbon so I can see this in full view. We could create a new warehouse if we want, right? I can look at the ones that I have. And connect to those and search for them. I can look at whatever schemas I have, security, and then whatever queries that I answer. Obviously, this is brand spanking new, so I haven't added any queries in it. But anytime you open up a new query, they automatically get saved in the queries section of this. I don't necessarily have to save this. The other thing I want to show you is the different options down here. So we have our data view, we have our query view, and we have our model view. Now, if I wanted to open up SQL Query and do a new SQL query, I could do that. Or I can go into the query blade and it'll create new SQL queries. Now, I haven't even written anything, and you can see that I already saved a SQL Query 1 in here. So I could come back, even though this is blank. I haven't saved it, so it went away. But you could see that I could do this. I also have a model tab. I can't use it right now. Why? Because I don't have any tables in here. It isn't going to create a default semantic model for me in order for me to view this, which is why some of these other reporting features aren't available to me either. Like the new report and the new measure. When I have tables in my warehouse, then these options should pop up because the default semantic model will be created at that point, and I can work with it there. Now, what's the difference between this and the Lakehouse? Well, let's move back and forth. I have it right here, and I have my sample Lakehouse here. So if I go into my sample Lakehouse, the first real difference you're going to notice is that, up here, I don't have an option to switch from a SQL endpoint to a Lakehouse, right? I have two different explorers here. I have a Lakehouse Explorer and a SQL Analytics endpoint. The SQL Analytics endpoint is going to reflect more of what the warehouse looks like, right? Because I have my schemas, I have my tables, I can look at the warehouses that I have created. I already have tables in here, so I have my data, my query, and my model views. So I can go through and look at all these same options, right? So it has a SQL endpoint built into it. One of the main differences is that this SQL Analytics endpoint in the Lakehouse is read-only, as opposed to the warehouse, which is read-write. So I can't write back to the warehouse. I have to go in and work with notebooks and do things like that. The SQL queries that I use for the warehouse version, I can actually modify and persist those changes into the warehouse itself. So that's a huge difference between the Lakehouse and the warehouse. But I did want to show that you have two different options. When you're in the Lakehouse Explorer, this gives me or exposes those files as well. So a warehouse is just like your typical SQL warehouse, right? We have our objects and everything that we create in there. We don't have this extra view into the one lake like we do with our Lakehouse. So that's another huge difference, is that I also have the ability to expose any files that are stored within my one lake here in the Lakehouse. So those are the main differences between this. But that's really all you have to do to create a warehouse, is just tell it you want one. It'll create one for you. It'll create the SQL endpoint. Easy peasy. Not much to have to work with in order to set this up. Super easy.
Great work, detectives. We solved several mysteries involving data warehouses: what they are, how to create one, the elements needed to form a semantic model for reporting, as well as some security aspects. Thanks for joining. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Together, let's investigate the different options and methods for loading data into a Fabric data warehouse, and how to choose the best one for your scenario. Whether you want to use data pipelines, data flows, or T-SQL, we'll show you how to get your data ready for analysis. Let's begin. Our case starts with the mystery of the questionable loading. First, we need to look at the clues of what options we have to load data into a Fabric data warehouse. In Microsoft Fabric, there are many ways you can choose to load data in a warehouse. This step is fundamental, as it ensures that high-quality, transformed, or processed data is integrated into a single repository. We'll look a bit more into these options later. In data warehousing loads, the efficiency of data loading directly impacts the timeliness and accuracy of analytics, making it vital for real-time decision-making processes. Investing time and resources in designing and implementing a robust data loading strategy is essential for the success of the data warehouse project. Once you've selected the tools for loading, our next set of clues will help us to better understand the process of data loading. To create objects, perform ETL, and load data into a data warehouse with T-SQL, you can use SQL Server Management Studio or another SQL client like the one available in Azure Data Studio or directly in the Fabric UI. Generally, you should implement a periodic data warehouse load processes that performs tasks in the following order. Ingest the new data to be loaded into a data lake, applying preload cleansing or transformations as required. Then load the data from files into staging tables in the relational data warehouse. This is a common approach to loading data, and we'll investigate this concept shortly. Next, load the dimension tables from the dimension data in the staging tables, updating existing rows or inserting new rows and generating surrogate keys values as necessary. Load the fact tables from the fact data in the staging tables next, looking up the appropriate surrogate keys for related dimensions. Finally, perform post-load optimization by updating indexes and table distribution statistics. And consider this: if you have tables in the Lakehouse and you want to be able to query it in your warehouse, but not make any changes, you don't have to copy data from the Lakehouse to the data warehouse. You can query data in the Lakehouse directly from the data warehouse using cross-database querying. Now, what about this staging concept? You may have to build and work with auxiliary objects involved in a load operation, like tables, stored procedures, and functions. These auxiliary objects are commonly referred to as staging. Staging objects act as temporary storage and transformation areas. They can share resources with the data warehouse or live in its own storage area. Staging serves as an abstraction layer, simplifying and facilitating the load operation to the final tables in the data warehouse. Also, staging area provides a buffer that can help to minimize the impact of the load operation on the performance of the data warehouse. This is important in environments where the data warehouse needs to remain operational and responsive during the data loading process. There are two types of data loads to consider when loading data into a warehouse, and those are listed here. And the main point here is that a loading process for a data warehouse doesn't always need to be both the full load and the incremental load. In some cases, a combination of both methods might be used. If the goal is to replace an existing data warehouse, an incremental load may not be needed from the original source, but may be necessary until the replacement is production ready. So, now that I've loaded your mind with the general concepts, let's talk tables. Understanding the clues of table structure in a data warehouse is essential for downstream analytics. Let's navigate the case of table treachery. We'll start by investigating dimension tables. Dimension tables describe business entities like products, people, places, and dates. Dimension tables contain columns for attributes of an entity. For example, a customer entity might have attributes like first name, last name, email address, and postal address, which might consist further of a street address, a city, a postal code, a country, and a region. In addition to attribute columns, a dimension table contains a unique key column that identifies each row in the table. In fact, it's common for a dimension table to include two key columns. First, a surrogate key that is specific to the data warehouse and uniquely identifies each row in the dimension table in the data warehouse, usually an incrementing integer number. Whereas an alternate key, often a natural or business key, that is used to identify a specific instance or an entity in the transactional source system from which the entity record originated, such as product code or a customer ID. Having both keys can assist in a few aspects. It prevents the risk of duplicate keys from multiple sources, and more importantly, helps with dimension attributes that change over time. What about these attributes that change over time? Slowly changing dimensions, or SCDs, change over time, but at a slow pace and unpredictably. For example, a customer's address in a retail business. When a customer moves, their address changes. If you overwrite the old address with a new one, you're losing the history. But if you want to analyze historical sales data, you might need to know where the customer lived at the time of each sale. This is where SCDs, or slowly changing dimensions, come into play. There are several types of slowly changing dimensions in a data warehouse, all of which are listed here, with type 1 and type 2 being the most frequently used. In type 2 slowly changing dimensions, when a new version of the same element is brought to the data warehouse, the old version is considered expired, and the new one becomes active based on the Boolean column added to the table. The following example shows how to handle changes in a type 2 SCD, or slowly changing dimension, for our products dimension table using T-SQL. The mechanism for detecting changes in source systems is crucial for determining when records are inserted, updated, or deleted. Change data capture, or CDC, change tracking, and triggers are all features available for managing data tracking in source systems, like SQL Server. After we load our dimension tables, fact tables are next. Let's consider an example where we load a fact sales table in a data warehouse. This table contains sales transactions data with columns like date key, product key, order ID, quantity, price, and load time, and we have a source table, order detail, in an online transactional processing, or OLTP system. In this example, we use a join operation to look up the date key and product key values in the dim date and dim product tables respectively, and then insert the data into the fact sales table. However, it's important to note that the complexity of the loading process depends on several factors, including the amount of data, the transformation requirements, error handling, schema differences, and performance. For example, slowly changing dimension tables add a layer of complexity to loading fact tables, which is why we need to load dimension tables first. Remember earlier when we looked at the options for loading data into Fabric warehouses? How about some more clues about those options? You bet. A data pipeline is a cloud-based service for data integration, which enables the creation of workflows for data movement and data transformation at scale. You can create and schedule data pipelines that can ingest and load data from disparate data stores. You can build complex ETL or ELT processes that transform data visually with data flows. Most of the functionality of data pipelines in Microsoft Fabric comes from Azure Data Factory, allowing for seamless integration and utilization of its features within the Microsoft Fabric ecosystem. You can create a pipeline within the Fabric warehouse itself, or by creating a new pipeline from the workspace and then select which option you want to start with. You can add an activity like a copy activity, use the copy data assistant, or select a template that may serve your copy purpose. The copy data assistant provides a step-by-step interface, like a wizard, that takes you through the process of connecting to a source, destination, all while applying settings that can change the data as it's moving from source to destination. Once you create the pipeline, there may be other settings to consider, like if you want to schedule periodic copy movement, set parameters like a specific database to copy data from, and even delete the data from the source if needed. Data Flow Generation 2 is the new generation of data flows. It provides a comprehensive Power Query experience, guiding you through each step of importing data into your data flow. This process of creating data flows has been simplified, reducing the number of steps involved. You can use data flows and data pipelines to ingest data into a Lakehouse or warehouse, or to define a semantic model for a Power BI report. Once the Data Flow Generation 2 launches, there are many options to load your data that are available. And you can load different file types with just a few steps. Once the data is imported, you can start authoring your data flow. You might decide to clean your data, reshape, remove columns, and create new ones. All the steps you perform are saved. Copilot can be a valuable tool for assisting with data flow transformations. Let's say we have a gender column that contains male and female, and we want to transform it. You could use a prompt like transform the gender column if male 0, if female 1, then convert it to an integer. Copilot will then add a new step automatically, and you can always revert it if you want, or continue to build on it for further transformations. With the data destination feature, you can separate your ETL logic and destination storage. This separation can lead to cleaner, more maintainable code, and can make it easier to modify either the ETL process or the storage configuration without affecting one another. When you select a warehouse as a destination, you can choose the following update methods. You can either append or add new rows to an existing table, or replace the entire content of a table with a new set of data. After you choose your update method, the final step is to publish your data flow. Publishing makes your transformations and data loading operations live, allowing the data flow to be executed either manually or on a schedule. This process encapsulates your ETL operations into a single and reusable unit, streamlining your data management workflow. Any changes made in the data flow take effect when it's published, so always ensure to publish your data flow after making any relevant modifications. SQL developers or citizen developers who are often well-versed in the SQL engine and adept at using T-SQL will find the warehouse in Microsoft Fabric favorable because the warehouse is powered by the same SQL engine they're familiar with. The copy statement serves as the main method for importing data into the warehouse. It facilitates efficient data ingestion from an external Azure storage account and currently supports the Parquet and CSV file formats. It offers flexibility, allowing you to specify the format of the source file, designate a location for storing rows that are rejected during the import process, skip header rows, and other configurable options. The option to store rejected rows separately is useful for data cleaning and quality control. It allows you to easily identify and investigate any issues with the data that weren't successfully imported. To connect to an Azure storage account, you need to use either shared access signatures or SASs or storage account keys. While it isn't included in this SQL query, the option to use different storage accounts for the error file location or rejected row location allows for better error handling and debugging. It makes it easier to isolate and investigate any issues that occur during the data loading process. Error file only applies to CSV file formats. You can also specify wildcards and multiple files in the storage location path to allow the copy statement to handle bulk data loading efficiently. This is useful when dealing with large data sets distributed across multiple files that have the same structure. In a scenario where an analyst needs data from both a warehouse and a lakehouse, this is definitely possible. To reference the data asset, ensure that you use three-part naming to combine data from tables on these workspace assets. You can then use create table as select or CTAS and insert select statements to load the data into the warehouse. The following query creates a new table in the analysis warehouse that combines data from the sales warehouse and the social lakehouse using the product ID as the common key. The new table can then be used for further analysis. All the warehouses that share the same workspace are integrated into the same logical SQL server. If you use SQL client tools like SQL Server Management Studio, you can easily perform a cross-database query like in any SQL Server instance. Nice job. Now that we've unlocked the clues to data warehouse loading, let's put knowledge to practice. Time once again to open up the Detectolab 5000 and start loading data.
All right, back in our environment. Now we're gonna load some data into our warehouse for this particular demo. There's several different ways that we can do this, and I'll show you a few. To show you all of them would take a lot of time, so I encourage you to practice and get engaged and dive in and get your hands dirty with warehousing in Fabric. But what we're going to do, our first option here is we're going to create a pipeline to load data in. Now we can do this just by going into our workspace and getting a new object and getting a data pipeline going. Now, it just so happens that in here I already had one. Because for some odd reason earlier it wasn't connecting to the blob storage account. Now it does, so I can view this. But what we're doing is we're adding a copy data activity, so I can just add a copy activity to this pipeline once I've created it. And then what I've done is I've changed the name of the pipeline to the CD load dimension table, or the name of the copy data activity to that. The source I've connected to sample data. I've tested this connection, and now I can browse it. This is similar to what we did in our Lakehouse. So we have our sample data. We have our different sample data sets, and this is our tables folder. And then what I'm doing is I'm loading in a dimension customer parquet file, right? So I have a file path, folder, and then a file that I'm actually going, and I can preview the data just as a sanity check to make sure I am connected. This wasn't popping up earlier, so now it is. That's good. We're also determining if this is a Parquet file format. And when I go into my destination, what I'm going to do is I'm going to set this up as a workspace object. Obviously, this is going into my warehouse and into my worldwide importer warehouse that I just created. This is the cool part about this data pipe, or the copy data activity feature within pipelines in Fabric, is that since I'm only loading in a single table object, I can have this table auto-create. Now, if I had existing tables where I used SQL language to create these objects, which we'll do here in a second, I could just, direct it towards those tables. But here, I already have, I can have it create the table on my behalf. So it's going to create the table object for me, which is awesome, right? So that's what I'm going to have it do is create these objects for me. And then we're going to call it DBO. So I'm giving it putting it in the DBO schema with the customer data table. And then we should be able to validate this. Looks good. And then go ahead and run this. And now that it's connecting to the blob store, hopefully this thing will run this time. We will get into that. And that should just go ahead and land our data into our data warehouse. And we'll sanity check that in a minute here. Shouldn't take too long to do this. Now, obviously, we can load data in other ways, the traditional way, so to speak. So I'm going to go into my data warehouse, and you can see that the customer table is already there. So that was a real fast process. And what I'm going to do now is I'm going to open up my query editor. I could do that through the SQL query editor here. You see, I can, now that I have some tables in here, I can do some things with schemas and views and stored procedures and such. But now that I have a SQL query here, what I'm going to do is I'm going to go ahead and copy and paste. I got to use Control V, and this is going to create a couple tables for me, right? So we're going to create a dimension city table, right? And we just do this drop if there's an existing table. We know it doesn't exist, but in case it does, or in case it fails and it creates at least the table, then I know I can go back and not have to change a SQL script at all. And then we're inferring, we're telling it the DBO. I'm inferring some column values in here and some of the guardrails on those. So it will create these tables, and we're also creating our fact sale. So we have our dimension customer. We're going to add dimension city, and we're going to add fact sale to this. And we'll go ahead and run this and have it create these tables for us. Good. Why it didn't run? Okay. Weirdness happening, but that's okay. You could see that it created those dimension customer and fact sales tables, which is exactly what we wanted to do. So this is how we can create tables in there. And I can rename this query, right? Just to create tables. And you can see that when I rename it and I save it, then it shows up in my queries, and I can go back and run this if I needed to, or just change some wording in it if I wanted to create other tables for it. We can always refresh. If this didn't show up here, I could always refresh the warehouse, and then the table should show up. Now, there's no data in here, right? We loaded in data from our dimension customer. That's the dimension city. This is our dimension customer. So we loaded this data in here. I know that we did because we ran that tool. But all I've done at this point was just create the tables, empty tables. Now what I could do now is go back in pipelines, load the fact sale and the dimension city, and direct those directly to those tables, right? But what we're going to do is we're actually going to copy data into these. Now that we have those in there, one of the ways that we can actually load data in that isn't going to require a staging table is to just copy directly into those tables. So we'll open up a new query window here. Let's do a new query, new SQL query, right? And then we'll paste this in here. And what am I doing here? So you could see that I'm going into that same storage account, the blob store, and I'm pulling in Dimension City Parquet, and I'm pulling in a Parquet file for the fact sale. And what I'm using is a copy into. And a copy into is a really fast way because there's parallel processing going in this warehouse. So, and especially with Parquet files, this can load these partitions in fairly quickly into these tables. So we'll go ahead and run this and have it load this data in. Now, in a typical loading strategy, these tables aren't that large, right? We're not loading in enterprise level data. And in the content we covered, you probably would want to set up a staging table to temporarily house that data in there. And then when we load it into our production tables, you could do things like ELT, where we're transforming the data while we're loading it in there, like insert table as select, which is very popular. So once we have data in a staging table, then we can run insert into commands instead of these copy commands. A couple different ways to do it. The staging way is much better for enterprise level data movement, whereas just to copy into, we have some small dimension tables. Even though the fact table is a little bit larger, it's not like enterprise level, but typically you'd want to stage your data, then load your dimension tables, then load your fact tables in that particular order. But in this one, we're just going to copy the data over. And once that completes, we'll be able to see, you know, the rows, and then we'll be able to take a look at the data that's within that. All right, so query ran successfully. Whew. You always cross your fingers when you do that, don't you? And you can see how many records were affected here. So I had 116,000 records that loaded in from my dimension table. And then this 50 million, right? So 50 million records from our fact table were loaded in here for using a copy. And you can see that that only took 2 minutes. So that's the magic and the capabilities of this parallel processing that can happen within these warehouses, is the quick load times into this. Same thing happens when we land data into staging and then perform ELT processes on the data. So very fast method of doing this. We're going to now show a pretty cool feature now called cloning. So I can clone tables using this. Let me go ahead and rename this, and we'll call this call it copy data right now. And that should save that in here. So now I got my copy data and create tables. Let's run a new SQL query though. And what we're going to do is we're going to use some language. Now that I have the data in here, we're going to use some language in here. You see this as clone of. So what this is going to do is these are going to create duplicate tables of what I have in here. Now, why would I do this? Well, sometimes we might want to create a couple warehouses for different purposes, and maybe have different tables within that warehouse, obviously different schemas, and we'll show that. These are going to go into the same schema, but what we're going to do here is we're just going to create new tables as a clone of that. Now, if you see how fast that was, by the way, let me refresh this and widen this out so that we can see this. Now I have a fact sale one and a dimension city one. When I click on this, the data's there. That query literally took 3 or 4 seconds, but created an entire duplicate table of all those records that we had already entered into, or that we loaded into these, that we loaded into the original tables. That's super quick. So this cloning process is amazing, by the way. We'll go back into the query just to show you. We'll call this clone table. We'll rename this to clone table, and right, and do that. But not only can we duplicate tables in the same schema, we can do it across schemas. So let's close out of these and we'll run a new one. We'll run a new query. And what we're going to do is we're going to create a schema. And that should add another schema to this. I love how this refreshes, by the way. This is awesome that it's refreshing on its own. So now we've created this other schema. And I can rename this to create schema just to save these, right? Not that, but if anybody else wants to create a schema, it saves a little bit of time to know that it's there, right? And now I'm going to run the same cloning technique, but now I'm going to apply it. Oops. Hit copy instead of paste. That's all right. That happens. So now you can see what I'm doing is I'm creating this into a different schema. So this DB01 from the original DBO. So what this should do now is create a clone of those tables. And again, happened in less than 3 seconds. So now when I go into my DB01 and I look at my tables, now I have my Dimension City one and my Fact Sale one here in my new schema. So different ways of loading data. Obviously, we didn't go through all of them again because there's a lot of different ways that we can load data in here. Staging to dimension tables to fact tables. Always consider your slowly changing dimension tables and things like that. But these are different ways, pipelines to create tables for us on our behalf using T-SQL language to create the objects, then copy the data into them. We can also utilize that process of creating a staging table, copying the data into the staging table, and then doing things like ELT, extract, load, transform from the staging table as we're loading it into the production table itself with an insert into statement. So different ways of doing it. Obviously, enterprise level, your best bet is to use that staging, dim, fact, optimize method. For smaller tables, you could just do a pipeline and create the table on its behalf, or use a copy into after you've created your table object. So different ways of loading data in. Let's head back into the studio.
Wow, we covered a lot of ground in this module. We learned how to load data into a Fabric warehouse using various methods and tools like data pipelines, data flow generation 2, and T-SQL. We also explored how to handle different types of data like dimension tables, fact tables, and slowly changing dimensions. Thanks for joining. A Fabric warehouse is just a nicely structured way of storing data, but where we shine as detectives is the investigation. How do we investigate the clues lying within our Fabric data warehouse? Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Let's unpack the mysteries of how to write and run queries in Fabric and other tools. We'll also discuss ways for non-technical users to query a Fabric warehouse. And we'll wrap up our investigation by learning some common SQL methodologies for data warehousing. Grab your funny-looking detective hat and let's get querying. The SQL Query Editor in Microsoft Fabric is a versatile tool that supports Transact SQL, or T-SQL, allowing you to create and run scripts to query your data warehouse. It also provides features such as IntelliSense and debugging to aid in the development process, but it isn't just about querying, it's about managing your data effectively. Whether you're creating a new table, inserting rows into a table, creating object permissions, or executing complex queries, the SQL Query Editor is designed to make these tasks seamless. To launch the SQL Query Editor, you need to select your warehouse asset from your workspace. This step connects you to your data warehouse automatically without you having to prompt any connection information. After opening the Warehouse Explorer, there are a few ways to open the SQL Query Editor, and these are listed by numbers here. First, from the Home menu, you can select New SQL Query or select any of the templates available. Or 2, from the Queries in My Queries folder, you can select New SQL Query. And 3, also you can select the Query tab. No matter how you initiate a new query editor, a new query item is automatically created in My Queries folder in the Explorer, and any new query item updated is automatically saved. To run a query, type it into the query editor and select Run at the top of the editor. The results section shows a preview with a maximum of 10,000 rows. Your query results can be exported as an Excel file, To export it, select the text of one of the select statements in your query, then select Download Excel file to export the results. Similarly, the query editor offers the ability to save your highlighted query, either as a view or a table, each with distinct features. For both options, you must provide the schema and the name before confirming the creation. So, if I only know SQL, can I query the warehouse? Not so fast, my friend. The Visual Query Editor in Microsoft Fabric Data Warehouse is a tool that provides an intuitive interface for building SQL queries. It simplifies the process of writing and managing queries, especially for those who might not be comfortable with SQL syntax. How, you may ask? Let's look at the clues. The editor provides a graphical interface where you can drag and drop tables and visually design your queries. This makes it easier to understand the structure of your query and the relationships between the tables. As you design your query using the visual interface, the corresponding SQL query is automatically generated. This allows you to focus on the logic of your query rather than the syntax. So now our non-technical team members can use it to extract valuable insights from the data, democratizing data access within your organization and speeding up our analytical mystery solving capabilities. All you need to know is the logic of the query as opposed to the SQL to execute it. You can also save visual queries as views or tables like the SQL Query Editor. Querying warehouses with the Fabric UI is just one way. Sometimes we like that warm, fuzzy feeling of working with tools we're familiar with, like my trusty magnifying glass. Sure, I could use Zoom on my phone, but I'm comfortable with the magnifying glass. Good thing our endpoint allows us to use external tools as well. We'll call this the case of the third party. Obviously, the first tool is SQL Server Management Studio, or SSMS. To connect to a data warehouse in Fabric from SSMS, you'll need your SQL connection string, which you can grab from your warehouse asset in your workspace. From there, you can launch SQL Server Management Studio, paste the connection string, and then authenticate. In Microsoft Fabric, you can authenticate using your Microsoft Entra ID, formerly Azure Active Directory user principals, user identities, or service principals. But SQL authentication is not supported. But that's not the only tool we can use. Any third-party tool can use the SQL connection string via online database or OLDB drivers to connect to a Microsoft Fabric warehouse or SQL Analytics endpoint using Microsoft Entra ID authentication. Now that we've cracked the case of the third party, let's move on to some actual common SQL methodologies common to data warehousing. We'll briefly cover the basics and some unique scenarios to data warehousing. First, the basics. It's common practice to perform selection, filtering, aggregation, joins, and sorting using T-SQL. Select and where clauses are the standard for picking what we want to query. Because this SQL query doesn't have a where clause in it, we're asking for all the data in the selected tables. Because of the way a star or snowflake schema is implemented, queries to perform this kind of aggregation rely on join clauses to connect fact tables to dimension tables, and a combination of aggregate functions and group by clauses to define the aggregation hierarchies. Finally, we sort data using order by, which can be further defined by ascending and descending situations. One special case for data warehouses is how to navigate queries in a snowflake schema. Because relationships built between tables may have different keys, we'll often need to create an additional join to be able to properly grab that data. In this example, you can see that we need to call the join on the product key to join the dim product and fact sales tables, as well as the category key to join the dim category to product category tables. Other less known processes you can incorporate in your queries is to use ranking functions. These functions enable you to partition the data over categories, each returning a specific value that indicates the relative position of each row within the partition. Row number returns the ordinal position of the row within that partition. For example, the first row is numbered 1, the second 2, and so on and so on. Rank returns the ranked position of each row in the ordered results. For example, in a partition of stores ordered by sales volume, the store with the highest sales volume is ranked 1. If multiple stores have the same sales volumes, they'll be ranked the same, and the rank assigned to subsequent stores reflects the number of stores that have higher sales volumes, including ties, kind of like golf scores. Dense rank ranks rows in a partition the same way as rank, but when multiple rows have the same rank, the ties are ignored. An intile returns the specified percentile in which the row falls. That wraps up the knowledge portion of our investigation. Time to jump back into the Detectolab 5000 to put this knowledge into practice.
Welcome back to the environment. And now it's time to do some SQL querying. So that's what we're going to work on in here. And we're going to do this specifically for the warehouse. There is a SQL Analytics endpoint for your Lakehouse, but we're going to focus in on the warehouse here. Now, one thing I want to show you before we get into the actual querying is that we can work outside of the Fabric browser if we want to. This will work with third-party tools. Our SQL connection endpoint, our endpoint connector will work. I just wanted to show you where you can grab that. So under your warehouse itself, under more options, you can get it under view details. You can also get it under the copy SQL connection string. And then also there's properties that you can grab from it as well. So those are the places that you can get it. I won't open it because don't have to blur that out a little bit later. But what we can do now is I'm in a virtual machine. I have SQL Server Management Studio open. I tested this already, but this is that SQL connection endpoint. And you see here that I am using Microsoft Intra Multi-Factor Authentication. It's going to have to be Intra. You can't use SQL Server authentication, and it's cloud native, so it doesn't have an operating system. So Windows authentication in this case won't be useful, but we'll go ahead and connect via this. And I already have authenticated. Usually it will take you into a browser for sign-on into your Intra account, but I've already done that. But you can see here that in my databases, I have my sample Lakehouse and I have my worldwide importer databases. And from here, all my tables are included. So when you get that warm, fuzzy feeling of working back in SQL Server Management Studio, then you may be able to be a little bit more comfortable working with Fabric warehouses in that case. But we're going to go back in here and work with the visual interface for this particular part. But now that you have that, just keep in mind that some SQL Server Management Service tools or SSMS tools you may not get full featurality with a data warehouse as you would with like a SQL Server. Just keep that in mind. There may be some differences between that. Okay, so let's next talk about visual queries. So we'll get into regular SQL queries, but if you are familiar with SQL, then that's just going to be repeat information. I think one of the cool features about Fabric and working with your warehouses here is the ability to use a visual query. So we're going to go into the warehouse, and you can see that up at the top here, I got my data, my query view, my model view. This will open up a SQL query, but what I want is a new visual query. So I'm going to open this up, and really this is a drag and drop interface. And what I'm going to do is I'm going to take my table, my fact sales table, and I'm going to drag it onto the interface here. And what I'm going to do is I'm going to hit this, and I'm going to keep my top rows in here. Put 10,000 so I can reduce the number of rows that are being loaded into this particular query. And there's some other things I can do, like manage columns and transform and sort. So a lot of different transformation. This is for somebody that's not SQL literate, but just knows the logic behind how I want my queries to be formulated and can work with it in that case, right? So now I'm going to take my dimension city and we'll put that on, we'll drag that on here. And then we're going to hit this combine button and we're going to merge queries as a new query, right? And then my left table I'm going to have as my dimension table. Usually in a join situation, the left table would be the outer table in this case, right? And I'm going to use, we're going to align this with our key values and then our fact sale for our city key here. And then we're going to do an inner join on this one. So I can select the join as well. And then we're going to hit OK. Right? So you can see it even develops a little lineage here. Connections between here. Now I have 4 rows from this inner join option. And then with this step selected, you can also see that there is the ability for me to expand this fact table out. And instead of selecting all of these, I'm going to include some, let's see, I'm going to include tax amount, I'll include profit, and total including tax. But that's all I want. So I'm even expanding tables out. This is familiar on what you can do with Power Query Editor. And in the back end, it's developing a SQL select statement for all this. But what I'm doing is I'm just visually changing the way that this looks by using logic as opposed to SQL. And then finally, we're going to perform a group by operation. In the advanced settings, we're going to group by country. We're going to group by state, province. And we're going to also group by city. New column name, we're going to call this sum of tax amount. Choose the operation of sum and a column of tax amount, right? And then we're going to add another grouping. I'm sorry, we're not going to add another grouping. We're going to add an aggregation called sum of profit. This will be sum of profit. And then finally, a third aggregation of sum of total including tax. All right, and then we're going to do a sum on this one and total including tax. All right. And we're going to move that one because that was a little extra that we put in there, right? So we got country, state, province, city, our aggregations here. And then we're going to click OK. And now it's added these additional columns for me, right? Where I'm taking sum of tax, sum of profit, and sum of total including tax. So I'm adding additional columns into this. So now I'm grouping by everything. And from here, I can rename this query so I can save this. So I got Visual Query 1. I can rename this to Sales Summary. And I also want to show you this last feature. You could do this with both the Visual Query and the SQL query, is this download to Excel file. Nope, couldn't translate the SQL on this one. I'll show it to you in the regular SQL version. But this is a great way for your users that may or may not be familiar with SQL language. If they know logically what they want to do with an operation, then they can create this visual query and perform it that way. But what we're going to do is we're going to go back into old comfortable new SQL queries here and just show you some options. All right. In fact, we'll close out this visual query and keep this one open. Now, again, I don't want to show you like SQL queries that we already know. But what we can do is, now where did I put I thought I had that ranking one in here. I may not have done it yet. I thought I renamed this, and we're going to rename this now. See, I can go back in here and rename these. I created a couple queries I want to demo for sure, but when you run a new query, it's up here. And what I can do is I can go into my tables. And if I want some quick query options, I can do, a select top 100 from this. It'll insert this for me and run it on my behalf. So there are some quick, I can create the tables. I can drop the tables. I can have a SQL query clone a table for me, and so on and so forth. I'm going to discard the changes to this. In fact, let me see. Oops. Okay, so this also gives me the ability to clone this without SQL code, which is awesome. But I also want to show a couple of these other queries, and then hopefully that analyze in Excel or the take or the export to Excel feature. The first one I wanted to do was cross-base querying. Now you saw that you can do cross-base or clone tables, but you can also perform cross-base, cross-database querying. Now this can be within the same workspace as what we're going to show you. But you can also do this across workspaces. As long as the data is in the same region, you should be able to cross warehouse query, or what we're going to show you is query in the same warehouse. The nuance, or what you need to make sure, and I reduced this to 1,000 because I didn't want this to run for a long time, but we're going to select the top 1,000 from all the columns in our warehouse. But what I have to do in order to cross-base query is identify the warehouse name, the schema, and the table that we're pulling in. So I need a 3-part naming system in order to do this, because I'm going to actually connect this to my Lakehouse, right, to my dimension customer table. These are the same, they're the same warehouses essentially, so they should group by and connect properly based on our customer key value. And we're just renaming these so that I can, on the warehouse customer key and the Lakehouse customer key, I know that those keys should match up. And then I'm going to order by the total including tax descending. And what this is going to do is it's going to literally go to my Lakehouse, it's going to go to my warehouse, and it's going to join these two tables together. First time this runs, when the query runs out, it takes a little bit of time. You can see that took 13 seconds. If I were to run this again, it's kind of cached into the query, so it won't happen. But 13 seconds for me to join two tables that aren't even located in the same warehouse, essentially. They're just, the files are all located in one lake, which allows me a cross-base query. They don't necessarily have to be, but this gives me that ability to do that, which is awesome. And then finally, once I have this, I can take this and I could open up a query in Excel, and you can see what happens is that it takes that SQL statement, and then I can hit continue and have that open up in Excel for me. So I can run this query in Excel as well. I can also save that table as a new table in my warehouse. So plenty of things that I can do with this after I've run SQL queries on it. The last query I wanted to show was this ranking query. And I'm going to do this over the stock item. I guess I didn't save that last time. And it's not DBODIM product. It is dimension. Oh, this is also in my, I think I'm doing this in my Lakehouse, aren't I? Because I had more tables in there. So let's go back in here. I think I might have it saved in my Lakehouse. There it is. So what I'm doing here is I'm taking stock item prices from my dimension stock item table, and I'm going to rank them by unit price, right? Descending. And I've run several different ranking functions on here to show you kind of what happens with this. So what it's bringing up is the stock item itself, the name, and you can see that it's ranking these. My 3XLs, my 3 extra smalls. Some of these might look the same, but they're not the same item. There might be 2 different ones in there, and that's what it's doing is it's ranking these by row number, right? So row number is our first one. So it's going to rank these in a row number format. So if there was 20 of these, it would create 20 different rows. You can kind of see this as you scroll down. Some of these rows have 3 instead of just 2, but that's what it's doing. Then we have our dense rank, right? Or we have our normal ranking system, which is going to include ties. So if all these have the same amounts associated with them, so they're all ranked number 1 because of that ranking system. They're all tied at that particular value. Dense rank, however, won't include ties. The difficult thing about it is that there's more than one there's not as many items within this to kind of show that one off. And then quartile splits it up by a percentage that we're defining in here. So dense rank, just unlike golf where tie scores get ranked the same place, dense rank will ignore that and just include it down in a ranking list. But so there's some select SQL statements that you can utilize. Visual, we can save them. You can do visual queries as well as a drag and drop. And then we always have our warm fuzzy feeling of going back into SSMS. Let's head back into the studio.
Congratulations, detectives. We covered how to use the SQL Query Editor and the Visual Query Editor in Microsoft Fabric Data Warehouse to explore your data and solve analytics mysteries. You also learned how to connect to your data warehouse from external tools like SSMS or any third-party tool that uses ODBC drivers. And you learned some common SQL methodologies for data warehousing. Remember, the key to a successful investigation is to ask the right questions, use the right tools, and follow the clues. I'll leave you with this. Why did the SQL break up with its relationship? Because it was tired of being in a join that didn't select any meaningful values. Thanks for joining. One of my favorite things to do as a detective is break open cases as they happen. This can also apply to the world of Fabric data warehouses. The mystery then becomes, how can we actively track activities and analyze queries? Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. We'll discuss the Detective Toolkit for monitoring your Fabric data warehouse. This includes tools outside of Fabric as well as in the data warehouse itself. Get your investigative mindset and let's unlock the case of the mysterious monitoring. When your organization uses Microsoft Fabric, the license used to purchase the service determines the capacity available. A capacity is a pool of resources that you can use to implement Fabric capabilities. The cost of using Fabric is based on capacity units, or CUs. Each action you perform in a Fabric resource can consume CUs for which your organizations then build. It's therefore important to be able to monitor capacity usage to plan and manage costs. In data warehouse workloads, CUs are consumed by data read and write activities. So queries in your data warehouse and the underlying file operations to OneLake storage are a significant factor in the cost of your Fabric analytics solution. The Microsoft Fabric Capacity Metrics app is an application that an administrator can install in a Fabric environment and use to monitor capacity utilization for the entire capacity. To monitor utilization related to data warehousing, you can filter the interface to show only warehouse activity. By using the Fabric Capacity Metrics app, you can observe capacity utilization trends to determine what processes are consuming CUs in your Fabric environment, and whether any throttling is occurring, which indicates that your processes require more capacity than is available within the constraints of your purchased license. With this information, you can optimize your capacity license for your needs. Now, let's crack open our warehouse and see what tools we have to investigate. You can use dynamic management views, or DMVs, to retrieve information about the current state of the data warehouse. Microsoft Fabric data warehouses include these popular DMVs. The exec connections returns information about data warehouse connections. Exec sessions returns information about authenticated sessions. And exec requests returns information about active requests. In this example, we're performing a few investigative techniques to track down a formidable opponent, the long-running query. First, we're pulling relative attributes in from the exec requests to identify any long-running queries. Now that we've tracked down the query, we can extend our investigation to discover the user that executed queries. I predict a stern email in this user's future. And if you're an admin, you can even use the kill command to terminate any identified long-running queries to save the day. Concurrency issues, throttling, and costs, that's superhero level detective work. Dynamic management views are great for monitoring performance in so many more areas than just query performance. Sometimes it can get complex in joining this DMV with that DMV to get query insights. So can we simplify this? Would I bring it up if we couldn't? Microsoft Fabric data warehouses include a Query Insights feature that provides a historical, aggregated information about the queries that have been run, enabling you to identify frequently used or long-running queries, and helps you analyze and tune query performance. Query Insights are provided through the following views. You got the Query Insights exec request history, which provides details of completed SQL queries. The Query Insights long-running queries provides details of query execution time. And the Query Insights frequently run queries provides details of frequently run queries. Let's tie this to another case to solve, and we'll call this one querying queries. We've been asked to track down recent queries within our warehouse and identify patterns of bad behavior. To help us solve this case, we can use Query Insights. In the first part of the query shown, we use the Query Insights exec request history view to identify queries that were run in the previous hour. Now keep in mind that depending on the concurrent workloads, queries may take up to 15 minutes to be reflected in the Query Insights views. Next, we can get details of long-running queries that have been run more than once from the Query Insights long-running queries view. This query identifies long-running SQL commands that have been used more than once and returns them in descending order of their median time to complete. This will help us identify repeat offenders. We can then use the Query Insights frequently run queries view to return details of successful and failed runs for frequently run commands. Then we can correlate any long-running repeat offenders with failed queries. Now that we've identified different levels of bad actors, we can act and save the day. Time once again to fire up the DetectoLab 5000 and apply these concepts to our environment. Let's dive in.
All right, back in the environment, we're going to cover monitoring. So what are we going to cover first? Let's talk about the Fabric's Capacity Metrics app. And it's an application, right? So we need to go into apps in order to get it. So if I go into more options, I can take a look at my apps here. Now I already have it installed in my workspace because I needed to test it out. But if you don't have it, then you can always go into Get Apps, which opens up AppSource. By the way, AppSource has a lot of different pre-built applications that you can use. But you can see the Fabric Capacity Metrics app is right here. So I can go ahead and install it in my workspace. One of the things that you need in your capacity application is, let me just show you in the settings here for the semantic model is that you're going to need data source credentials, and that's your capacity ID. Where do you get your capacity ID? Well, if I go back into my admin portal here and I look at my capacity settings and I look at my different capacities that I have, like in my trial one here, I have this one. Then I can go to my settings and get it. I'm not going to do it because that's going to expose an ID that I don't want to expose, but you can go into your settings and get that. Copy it, and then you can come back into the app once you've opened it up and then paste it. So now I'm going to open up the report. Now I could open up the app, right? But I'm just going to open up the report now so that you can see this. So what I got here is, first of all, you want to make sure that you got the right capacity selected. This works for any capacity that's associated within your tenant. So I have a Power BI embedded tenant or Power BI embedded capacity, and then I have this trial capacity. So I have that brought up right now. You can see that it contains a compute and a storage options. So I can see my CU utilization, my capacity units, which are my billable units. I can see things like my duration, my operations, what users are doing what in here, and then what's happened within the last bit of time. I can also see my utilization over a certain period of time, you know, what's been doing what, my data sets, my Synapse notebook operations, any warehouse operations, so on and so forth. And then I can see if there was any throttling that took place, any overages that might have happened, so on and so forth there in the compute. And in the storage, I can go in here and take a look at what my billable storage amount is in my OneLake, what my current storage is in there, how many workspaces are being applied to this. So I can get a sense of what everything's kind of costing me in this perspective. So this is a great monitoring tool. Yeah, you can see that it takes a while to update the visuals in this. It's got to pull the data in and perform any query operations that it's doing in the back end. So it's a little slow in generating it, but you can see that from a billable perspective, I can monitor that. So this, from my capacity, is great for me to go in and kind of monitor that aspect of it. What about my warehouse? Let's go into my worldwide importers warehouse, and we'll run through some of those DMV and query insight options that were in here. So that's loading up a table right now. But one thing I did want to show you is that there are views in here. I have system views, but you can also see this query insights. Now, I don't know what's up with the UI right now. This doesn't hold very long. Like as soon as the warehouse updates, it goes away. But if I look at the views here, I can run views for executive requests and frequently run queries and long running queries straight from here. I don't need to run specific SQL queries in order to do this. These are views that are predefined in the warehouse themselves. So I can run these, and just to show you, these are all the columns that get created, and I can pull out what information I need, perform join operations on exec requests, frequently running queries, and long running queries. You can see that this is query insights. Now I'm going to run those manually because I don't need to pull all of these columns in there, but wanted to show you that that's in there. Also in my system views, there's a lot of, DM exec requests and things like that that I can pull in out of here as well. So you could utilize system views and my query insight views to pull certain information out if I wanted to, but I want to pull specific information out. In order to do that, I'm going to run SQL queries. So let's run this SQL query here. This will insert all this in, right? And I'm just going to run these one at a time. So I can just highlight one of these and just run it just to get this one this one query executed. And I want to take a look. Now, I had just created this warehouse, so obviously there isn't too many query requests that have gone through in the last hour, which no, it says where it was running. So I haven't run too many queries, but this was a pretty long running query, session 132. So maybe what I want to do is I want to check this. Yes. So I want to check this. Boy, that takes a while to. It's easier to do it that way, right? So I want to look at session ID 132 specifically and see what happened with that. So now I can find an action. So if I have some, I don't know why it used one for one and one for another. But let's see. That was it. Yes. It didn't even give me a login name. So I know it was me. But what I can do then is I can look and see who the actual login or the username of the login that has long running queries in there. And if I am an admin, which I am, I can kill that query from running if it's still continuously running, which obviously would save compute operations from taking place. I don't want, this could be a reason that my compute utilization is so high is that I got a query that's just continuously running in the back end, and I don't want it to run anymore. So also there might be some concurrency issues that might be going on. If people are getting put in waits and it's because of a long running query that somebody executed, I can go ahead and kill that from an admin session, right? So we'll rename this, and these are DMV queries, or we'll just call it long running queries, right? And then we'll just close out of this one and open up a new one. Because I also want to show query insights. So query insights is the other one that we can use. Right, so here's the ones that we have. And this is pulled directly from the content. So what we're doing here is we're pulling in start time. I got my login name, and I got the actual command that was used to, or the SQL query that was used to perform that operation. So this is good information, right? I can see when the start time was, who did it. It's all me, and then obviously the command that took place here. I can also see how long it took, right? So here it's given me long running queries. Let's see, long running queries for something that had greater than one run. And obviously these copy intos are going to be long running queries, right? Because I'm copying data from a fact table here, which had, if you remember, 50 million examples or whatever that it pulled into the rows for that. So that was a big one, right? So I can see how many runs it took. It went through 2 runs. Median elapsed time was 69,500 milliseconds. And then it tells me when I last ran this. So this is also good information. Obviously, there's going to be hundreds of queries that are probably being run on this warehouse at any given moment. You'll be able to see those. And then finally, I can see frequently running queries. Go ahead and execute this. Again, it's showing me the last run command. And what other information did it pull in here? The number of runs, number of successful runs, and the number of failed runs. So I can get a lot of information out of these DMVs, meaning that I can, the dynamic management views and these query insight views, to track down bad actors, use our investigative techniques to resolve long-running queries and find queries that, are getting executed a lot, and maybe dive deeper into what's happening with that. Obviously, since this information is being collected and stored in tables for us, I can even add that to my own analytics reports in Power BI and trace these in near real time. Also, like create dashboards in order to monitor this stuff and create alerts on it. So I can set up automated processes, take it a step further. So obviously, monitoring is a big key part of making sure that our warehouses are running optimally, and great stuff to have and to implement. So back to the studio.
Great work, detectives. You learned how to use various tools and techniques to monitor your Fabric data warehouse, like Capacity Metrics app, Dynamic Management Views, and Query Insights. Thanks for joining. Ready for reporting? One of the keys to manageable performance solutions with large data is good model design. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Let's unravel the mysteries of model scalability, why it's important, and what tools exist in Fabric to help you and your team accomplish your goals. Gear up and let's get started. Before we talk through scalability, let's define what we're talking about. You'll notice that we refer to enterprise scale or large scale data rather than big data. Enterprise scale data is data that's massive, complex, diverse, rapid, and valuable. It requires a unified data platform that can handle all the aspects of data analytics, from data movement to data science, in a scalable and cost-effective way. Microsoft Fabric is such a platform, which offers a lake-centric data warehouse, a serverless data integration service, and a comprehensive suite of data engineering and data science tools. If you're familiar with working with enterprise data, it may be helpful to understand that the Power BI experience in Fabric is the next generation of analysis services. It's the same technology under the hood of analysis services and Power BI semantic models and the Vertipack engine. Scalability in this context refers to building data models that can handle growth in the volume of data. A data model that ingests thousands of rows of data may grow to millions of rows over time, and the model must be designed to accommodate such growth. It's important to consider that your data will grow or change, which increases complexity. Scalability must be at the forefront in enterprise solutions to ensure flexibility for changes, increases the data, and to reduce complexity. The best approach to building scalable data models will always be building with data modeling best practices in mind. Beyond the data model, Microsoft Fabric was designed specifically for enterprise deployments. Premium or Fabric capacity offers greater storage capacity and allows for larger individual semantic models depending on the stock keeping unit or SKU. Implementing the Fabric only large semantic model storage feature on a premium Fabric capacity enables data to grow beyond the Power BI desktop file size limitations or model size on this chart. Another important consideration in designing for scalability using Fabric is choosing the right capacity. You'll need to work with your Fabric administrator to determine which licensing SKU is available to you. If you're having performance issues, work first to optimize your model, and then work with your Fabric administrator to monitor Fabric capacities. At the most basic level, it's important to understand that premium capacities require sufficient memory for processing. You'll need to double the amount of RAM to process your data model refresh. For example, if you have a 40 gigabyte semantic model, you'll need at least 80 gigabytes of memory available. A 40 gigabyte semantic model would be best supported by an F256 capacity, which contains 100 gigabytes of memory. Implementing data modeling best practices is key to performant, scalable data models. Now, if you've worked with Power BI for reporting up to this point, You may be familiar with the storage modes you can implement when connecting to data sources. These are import, direct query, and dual. Import mode offers you the most options, design flexibility, and delivers fast performance. Use direct query when your data source stores large volumes of data and/or your report needs to deliver near real-time data. Finally, use dual mode when you need to boost the query performance of a direct query model, deliver near real-time query results from an import model, and extend the semantic model for an Azure Analysis Services model with other data. Dual storage combines data from more than one direct query source or combine direct query with import data. But we're here to talk about generating reports from Fabric. I mean, after all, we spent all this time setting up a lakehouse and warehouse so we can quickly generate a report, right? This is why we're going to talk a little bit more in depth about direct lake mode, which is an option as a storage mode in Power BI for connecting to guests. Yes, Fabric lakehouses and warehouses. Direct lake mode is a groundbreaking semantic model capability for analyzing very large data volumes. Direct lake is based on loading Parquet formatted files directly from a data lake without having to query a lakehouse or warehouse endpoint, and without having to import or duplicate data into a semantic model. Direct lake is a fast path to load the data from the lake straight into the Power BI engine, which is ready for analysis. The following diagram shows how classic import and direct query modes compare with direct lake mode. In direct query mode, the Power BI engine queries the data at the source, which can be slow, but avoids having to copy the data like with import mode. Any changes at the data source are immediately affected and reflected in the query results. On the other hand, with import mode, performance can be better because the data is cached and optimized for DAX and MDX report queries without having to translate and pass SQL or other types of queries to the data source. However, the Power BI engine must first copy any new data into the model during refresh. Any changes at the source are only picked up with the next model refresh. Direct lake mode eliminates the import requirement by loading the data directly from one lake. Unlike direct query, there's no translation from DAX or MDX to other query languages or query execution on other database systems, yielding performance like import mode. Because there's no explicit import process, it's possible to pick up any changes at the data source as they occur, combining the advantages of both direct query and import modes while avoiding their disadvantages. Direct lake mode can be the ideal choice for analyzing very large models and models with frequent updates at the data source, but depending on the use case, delta tables can be used in direct query or import using the Lakehouse SQL endpoint. Direct lake also supports row-level security and object-level security, so users only see the data they have permissions to see. Up to this point, we've done a pretty considerable job of executing best practices when creating our lakehouse and warehouse assets, but anytime data is going to be associated to a semantic model, you want to do as much data preparation work as possible before data reaches Power BI, as far upstream as possible. For example, if you can transform data in the data warehouse, that's where it should be done. Transformation at the source produces consistency for any other solutions built on that data and ensures that your semantic model doesn't need to do any extra processing. This may require working with your data engineer or other members of your data team and is critically important. Feel free to jot down these best practices or cache them in your internal database. Semantic models store data in a highly compressed, in-memory cache for optimized query performance. Enterprise deployment of an analytics solution will likely require a premium per user license for Power BI or a premium capacity. With the large semantic model storage format enabled, sizes are limited only by the capacity size or a maximum size set by the administrator. This differs from semantic models in Power BI Premium, which are limited to 10 gigabytes after compression if large semantic model storage format isn't enabled. Large semantic models can be enabled for all premium P SKUs, embedded A SKUs, and with premium per user and fabric capacities. Enabling the large semantic model format enables fast user interactivity and allows data to grow beyond the 10 gigabyte limit. Additionally, the large semantic model format can also improve XMLA write operation performance, even for semantic models that may not be large. It should be noted that semantic models enabled for large models can't be downloaded as a Power BI desktop PBIX type file from the Power BI experience. To take advantage of the large semantic model storage format option, it must be enabled at the Power BI experience. Here, you can enable large semantic model storage format for a single semantic model or for all semantic models created in a workspace. To enable large semantic model storage format for a single semantic model in the semantic model settings, toggle the slider to on and select Apply. You can also set the default storage format for all semantic models created in a workspace in the workspace settings. In the settings, select Premium and select Large Semantic Model Storage Format as the default storage format. Large Semantic Model Storage Format for a workspace can also be enabled using PowerShell. Guess what time it is? Yep, Detectolab 5000 is raring to put knowledge to practice. Let's dive in.
All right, welcome back to the environment. This will be nice, short, and sweet. We're talking about large semantic models, right? So that's what I'm going to show you. That's really about the only thing I can demo on this topic is the large semantic model options. When we're dealing with enterprise level data, you have to keep in mind that when we're developing models in Power BI and then publishing them to the service, there's size limitations on the model size, depending on the license that you have, Pro, Premium, or Capacity licenses. And even with a premium per user license, there are still limits up to 10 gigabytes, I believe, for a model size to be published. Well, if we have more data imported on the model and we need to push this into the service, we're going to need more capabilities, right? So those are options that we can enable in a couple different levels in our workspace or in our items within our workspace or the workspace itself. Let's look at the items because I want to really point out the differences between your default semantic model and any models that you create in the service itself. Now, whenever we create a lakehouse or a warehouse and we add tables to it, then it creates a semantic model for us. These are default semantic models. Now, if I go into my settings for this, into this particular, and I have all of them, so I could show you, you can see that I have a few options, a few settings that I can change, like query caching, refresh, so on and so forth. Same thing with my warehouse, same options, except, let's see, there's one in here, I think request access is different. No. It looks like there's server settings. No. Oh, Q&A? Oh, featured Q&A. All right, so there's a little bit of difference between Q&A and featured Q&A questions. But I can't do anything with the semantic model size. So when we're working with our default semantic model, I think this is important to point out in this one, is that they're very limited in what we can do to work with. The default semantic model is more designed for us to just do some quick analytics on something. If I want to see some quick visuals, then I can do that by using my default semantic model without me having to create a new model, create all relationships in between it, so on and so forth. But when you create a new model and then associate it with, Lakehouse or warehouse objects, you can see that I have more options here for settings, including a large semantic model format. So if I'm now it says right here that my semantic model size is 1 megabytes, but for most premium capacities, using the large semantic model storage format can improve performance. So I can turn that on. What I want to test out is to see if I set this at the workplace level, if that's going to trickle down into my individual my individual custom models that I've created here. So let's go back to the workspace and I'll show you where we can do that. In workspace settings, this is where I can, under my premium option, I can enable large semantic models and then apply that. And this applies to all the workspace objects. Any new semantic models that I create should be automatically enabled in the large semantic model storage format from here out. What I don't know is if that changes any current models that you might have created that didn't have it before you enabled it at the workspace level. So we'll see if, clear all these out. I don't know if that's going to create a notification to let me know if that has been enabled yet. Probably one other thing I'll point out in here is the Git integration, because I didn't cover it in a different demo, and I apologize. But just know that under your workspace settings, this is where we can connect to either a DevOps account or a Git repository, right? So I already have a DevOps account associated with this, with my Entra ID, but I can also connect to a Git repository and connect and sync that as well. Just keep in mind that things like data pipeline objects, notebooks, these are all coded, right? What you wouldn't know it by looking at a pipeline because it's a visual interface, but underlying those data pipelines, they create JSON code, declarative statements that can be saved in a Git repository, and then I can just make updates to the underlying code, which will therefore change the way that the data pipeline operates, and use an infrastructure as code type of mechanism instead of going in and changing a data pipeline in this UI itself. I can go into the Git branch or my Azure DevOps account, change the objects there, and push those or publish those changes into here, and they'll apply, make massive changes and apply them all at the same time if need be, without and doing it at a time when people aren't on here working on it. So Git integration is great for continuous integration, continuous delivery, because I can change things. I can push those changes out at a time when people aren't utilizing those services at that point. It's a great thing to do. What I want to see is if I go into, let's look at the settings under my semantic models again, just to see what happened here. I just want to see if my large semantic model applied to this, and you can see that it didn't. So it'd probably be a good idea to go ahead and set that at the workspace level before creating custom models, because now I can go ahead and turn this on and apply it for this. But it didn't apply that once I've already created a custom model. So if you need to make sure, especially if you have F64 capacity or higher, there's usually unlimited model size that you can publish at that point. You'll want to make sure that we have this large semantic model storage format. Just keep in mind that, because of this, or set at the workspace level first before starting to create custom models. If you've already created custom models, you can always come back in and change that setting automatically for you, or change that setting within the actual semantic model itself. That pretty much covers it. Let's go back into the studio.
Awesome job, detectives. We just learned about the mysteries of model scalability, how to leverage Microsoft Fabric as a unified data platform for enterprise-scale data analytics, and how to use direct lake mode and large semantic model storage format to build fast and flexible data models. Thanks for joining. Working with relationships and semantic models reveals several complex mysteries to solve. How do you set up relationships between different tables of data? And how do they affect the way you filter and analyze your data? We'll unlock these questions and more. You'll discover how to apply star schema design principles, how to choose the right cardinality and cross-filter direction, how to activate or deactivate relationships with DAX functions, and how to understand relationship evaluation and precedence rules. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Gather your evidence bags and let's start investigating, starting with our first case, the model mystery. A model relationship propagates filters applied on the column of one model table to a different model table. Filters will propagate so long as there's a relationship path to follow, which can involve propagation to multiple tables. Relationship paths are deterministic, meaning that filters are always propagated in the same way and without random variation. Relationships can, however, be disabled or have filter context modified by model calculations that use functions. Model relationships don't enforce data integrity. Here's how relationships propagate filters. In this example, the model consists of 4 tables: category, product, year, and sales. All relationships to the table are one-to-many, which we'll cover in a bit. A query asks for the total quantity of sales orders in a category, category A, and a year, calendar year 2018. Filters on the category and year tables reduce the product table to 2 products in category A and the sales table to 2 sales rows for these products. Their total quantity is 14 units. The year table filter also reduces the sales table to 1 sales row in category A and calendar year 2018. The query returns a quantity of 11 units. Multiple filters on the table are always an AND operation, meaning all conditions must be true. Now that we have a better understanding of what model relationships are, our next case to crack is the star scheme. We recommend you apply star schema design principles to produce a model compromising dimension and fact tables. It's common to set up Power BI to enforce rules that filter dimension tables, allowing model relationships to efficiently propagate those filters to fact tables. The following image is the model diagram of a data model. It shows a star schema design compromising a single fact table named sales. The other 4 tables are dimension tables that support the analysis of sales measures by date, state, region, and product. Notice the model relationships connecting all tables. These relationships propagate filters directly or indirectly to the sales table. It's unusual that a model table isn't related to another model table. Such a table in a valid model design is described as a disconnected table. A disconnected table isn't intended to propagate filters to other model tables. Instead, it accepts user input, maybe with a slicer visual, that allows model calculation to use input values in a meaningful way. One example of a feature that creates a disconnected table in Power BI is a what-if parameter. Another special circumstance is attempting to relate a column to a different column in the same table. This is referred to as a self-referencing table and uses this concept to store parent-child relationships to generate a model a hierarchy. This isn't possible in model formatting in this service. There are other ways to generate parent-child relationships, and we'll look at that in a bit. All right, definitions and design recommendation mysteries are covered. Now, how are relationships created? And how does filtering work? Let's crack the case of the cardinal sin. In most cases, a model relationship relates one column in a table to one column in a different table. Each model relationship is defined by a cardinality type. There are 4 cardinality type options representing the data characteristics of the from and to related columns. The one side means the column contains unique values. The many side means the column can contain duplicate values. When you create a relationship, the service automatically detects and sets the cardinality type by querying the model to know which columns contain unique values. Sometimes, however, the service can get it wrong. You can get it wrong when tables are yet to be loaded with data, or because columns that you expect to contain duplicate values currently contain unique values. In either case, you can update the cardinality type if any one-side columns contain unique values, or the table is yet to be loaded with rows of data. Let's briefly discuss each cardinality type. The one-to-many and many-to-one cardinality options are the same, and they're also the most commonly used cardinality type. A one-to-one relationship means both columns contain unique values. This cardinality type isn't common, and it likely represents a suboptimal model design because of the storage of redundant data. It's often a better idea to use Power Query to consolidate the tables into one. A many-to-many relationship means both columns can contain duplicate values. This cardinality type is also infrequently used. It's typically useful when designing complex model requirements. You can use it to relate many-to-many facts or to relate higher grain facts. For example, when sales target facts are stored at product category level and the product dimension table is stored at product level. You can interpret a relationship's cardinality type by looking at the indicator, which could be a 1 or an asterisk, on either side of the relationship line. To determine which columns are related, you'll need to select or hover the cursor over the relationship line to highlight the related columns. Each model relationship is defined with a cross-filter direction. Your setting determines the directions that filters will propagate. The possible cross-filter options are dependent on the cardinality type. Single cross-filter direction means single direction, and both means both directions, kind of like roads. A relationship that filters in both directions is commonly described as bidirectional. When the cross-filter direction is set to both, an additional property becomes available. It can apply bidirectional filtering when Power BI enforces row-level security rules. You can modify the relationship cross-filter direction, including the disabling of the filter propagation, by using a model calculation. It's achieved by using the cross-filter function, which is described shortly. Keep in mind that bidirectional relationships can impact negatively on performance, so it's recommended to use bidirectional filtering only as needed. In Model View, you can interpret a relationship's cross-filter direction by noticing the arrowheads along the relationship line. A single arrowhead represents a single direction filter in the direction of the arrowhead. A double arrowhead represents a bidirectional relationship. Cardinality essentially affects the flow of traffic of data while filtering out what's being requested. As you can probably deduce, this is an essential concept because ultimately a query or a report visual heavily relies on accurate filtered information. Now, what about multiple relationships between tables? Let's investigate. There can only be one active filter propagation path between two model tables. However, it's possible to introduce additional relationship paths, though you must set these relationships as inactive. Inactive relationships can only be made active during the evaluation of a model calculation. It's achieved by using the useRelationship function, which again we'll look at shortly. Generally, we recommend defining active relationships whenever possible. They widen the scope and potential of how report authors can use your model. Using only active relationships means that role-playing dimension tables should be duplicated in your model. In specific circumstances, however, you can define one or more inactive relationship for a role-playing dimension table. You can consider that design when there's no requirement for report visuals to simultaneously filter by different roles, or you use the useRelationship function to activate a specific relationship for relevant model calculations. In Model View, you can interpret a relationship's active versus inactive status. An active relationship is represented by a solid line. An inactive relationship is represented as a dashed line. Now let's take a look at a special case. We want to speed up queries to direct query tables that have relationships built between them. Any built-in features that can help? Glad you asked. The Assume Referential Integrity property is available only for one-to-many and one-to-one relationships between two direct query storage mode tables that belong to the same source group. You can only enable this property when the many-side column doesn't contain nulls. When enabled, native queries sent to the data source will join the two tables together by using an inner join rather than an outer join. Generally, enabling this property improves query performance, though it does depend on the specifics of the data source. Many of the settings and strategies we covered up to this point can be accomplished through the visual interface. But just like most platforms, you have the flexibility of using programming language to perform these types of operations. This is where data analysis expressions, or DAX, comes in. Now, I've been holding off on saying DAX because my pet, best pal Dax, is kind of a diva, and although hates to be on camera, loves to be mentioned. Yes, Dax, this is where we talk about Dax. Now, go lay down and be good. Let's investigate some DAX functions that can help us work with relationships. There are several DAX functions that are relevant to model relationships. These are listed here along with how they're formatted. The related function retrieves the value from the one side of a relationship. It's useful when involving calculations from different tables that are evaluated in row context. The related table function retrieves a table of rows from the many side of a relationship. The useRelationship function forces the use of a specific inactive model relationship. It's useful when your model includes a role-playing dimension table and you choose to create inactive relationships from this table. The cross-filter function either modifies the relationship cross-filter direction to one or both, or it disables filter propagation to none. It's useful when you need to change or ignore model relationships during the evaluation of a specific calculation. The combine values function joins two or more text strings into one text string. The purpose of this function is to support multi-column relationships in direct query models when tables belong to the same source group. The treatAs function applies the result of a table expression as filters to columns from an unrelated table. It's helpful in advanced scenarios when you want to create a virtual relationship during the evaluation of a specific calculation. The parent and child functions are a family of related functions that you can use to generate calculated columns to naturalize a parent-child hierarchy. You can then use these columns to create a fixed level hierarchy. Up to this point, we've covered many ways to help develop proper semantic model relationships. But it's also important to understand how the engine works with these relationships so that we can discover ways to further optimize our model. Let's uncover the clues to solve the case of the performance problem. Model relationships from an evaluation perspective are classified as either regular or limited. It's not a configurable relationship property. It's inferred from the cardinality type and the data source of the two related tables. It's important to understand the evaluation type because there may be performance implications or consequences should data integrity be compromised. A model relationship is regular when the query engine can determine the one side of a relationship. It has confirmation that the one side column contains unique values. A model relationship is limited when there's no guaranteed one side. A limited relationship can happen for a couple reasons. The relationship uses a many-to-many cardinality type, even if one or both columns contain unique values, or the relationship is a cross-source group, which can only ever be the case for composite models. It's not always possible to determine whether a model relationship is regular or limited. A many-to-many relationship will always be limited, as will be a one-to-many relationship when it's cross-source group relationship. To determine whether it's a cross-source group relationship, you'll need to inspect the table storage modes and data sources to arrive at the correct determination. You can tell in a model view if a relationship is limited by the following identifier. We discussed bidirectional relationships and the consequences involved. This could also mean slower performance. Why? The service uses precedence rules for ambiguity detection and path resolution. Those are listed here. If you notice, bidirectional relationships are last on the list, meaning that those types of relationships are resolved last. Last, but certainly not least, the following list orders filter propagation performance from fastest to slowest performance. Now that you have a better relationship with relationships, let's put that knowledge to practice. We'll fire up the DetectoLab 5000 and put this knowledge to work.
All right, back in the environment, and now it's time to build our relationship with the relationships. So that's what we're going to focus on in this. So the first thing that we're going to need to do is we're going to create a new semantic model. Now I can use, I've already kind of built the relationships between the default, but if you remember from previous demos, and the default semantic model has some limitations to it. It's great for quick analysis, quick reporting within the Fabric environment, but in order to get more features and options, we need to create our own model, which is kind of what I did here. And we can do that from the Lakehouse itself. And I can create a new semantic model from the Lakehouse. What I want to show you is the difference between a Lakehouse and a warehouse. So my worldwide importers warehouse, right? I do have a default semantic model. You can see that I'm in the model view. But even when I go into the data view, I don't have the ability to create a new semantic model of the warehouse. So I can only use the default model. So this is great for quick analysis. Now, don't think that you can't, now you might be thinking, well, now I can't use this or do anything else. Well, you still can. If I go into if I have a report open in Power BI desktop and I just want to connect to the data, I can do that. I can connect to my warehouse. So if I go to Fabric, you can see that I have the warehouse option, and then connect into my warehouse. And then what happens is essentially the tables that are associated with that warehouse become available in this report. And I can utilize that and combine it with other data sources to essentially create a new semantic model if I need to. So that's the workaround for that. But we're gonna work with this Lakehouse one since it's easier to do from here. So let's go back in the Lakehouse. By the way, if I switch to the SQL Analytics endpoint, same thing. I don't have the ability to create a new semantic model from here. So we got to do it from the Lakehouse Explorer. We'll create a new semantic model, and we'll call this, I think I already have test model. So we'll call this test model 1. And then it gives me the option to select which tables that we've created in our Lakehouse to generate this new semantic model from. So we put a lot of tables in here. Some of these aren't going to apply to this. So we got dimension customer, dimension city, the stock item, the employee, and the date. We made these aggregated tables ourselves. They're just for analytics purposes, like quick analysis, so I don't really need them. The only other one I'm going to need is obviously my fact table, right? So we'll confirm this, and it should create the model for me and hopefully open this up in a new window for me to work with. So we'll wait for this to happen. All right. So it says here, changes will be permanent and automatically saved. That's great. All right, so that's good. Now, I want a little bit more real estate. I know what's here. We're working with relationships, right? So let's expand this out. So I can zoom in, zoom out, do all these things, reposition these. But what we're going to do is we're going to create a star scheme out of this, where the dimension tables filter into the fact tables. Now, there's a few ways that I can build relationships. I'm going to move these kind of in a star schema or a star format so that I can show you the different, what visually this looks like when we get it done. And we'll zoom back out to full mode and maybe move this around just a little bit more, make this look a little bit more starry. All right. So there's a few ways that we can do this, that we can create relationships between models. I can do a drag and drop. So if I know exactly what columns I need to build a relationship between, I can do that. And just as a nuance, if I do it from the fact table to this side, it depends on what we're trying to join it to. It doesn't make any assumptions about if it's a one-to-many or a many-to-many. I'm defining that myself. So I can see that I got a customer key. So this is, well, I got a city key. Let's do this. So I'm going to drag the dimension city into this fact table, and it should open up my relationships, right? So I'm going to make this relationship active, city key to that. The problem is that it's given me a many-to-one, and I've dragged the dimension into the fact. Now, if I said okay on this, right, and I'm going to assume a referential integrity on all these because these are live connections, so I'm pulling this from source. Now you can see that the many side was put on the dimension and the fact was put on the one side. That's not what we want, right? These should have all the unique values in here, and these should have the duplicates in there. So we'll go back into the properties and we'll switch this to one-to-many. And we'll hit OK, and that should make that proper, all right? So let's do this the other way, right? So I got customer key, and I got customer key here. So I'm going to move it from the fact table to the dimension table. And then we'll assume referential integrity, and then it's a many-to-one. And this one should be okay, right? One-to-many. That's what we're looking at. So the way that this works, when we try to do it that way, that's how we can obviously create that many-to-one is drag and drop. Now, some of these we might not know exactly what key to utilize with this. Like I have an employee key here, and I have a salesperson key, but this isn't that obvious to me. And this is how I'm going to build this relationship. I can also go into manage relationships, and it shows me the relationships that I have. I can create a new one. So if I want to do from my fax sale and my salesperson key to, and I just highlight that, to my dimension employee and my employee key, and I say many-to-one on that, assume referential integrity, we hit OK. That should go ahead and you can see that the many side is on the fax sale. So that's exactly what I wanted. And I can do this for the other ones. I haven't done date yet. Oops, I wanted to show something particular with that. I think this one has a stock item key, right? And then we have, oops, I should have done this from the fact, well, that doesn't matter. I can make it a one-to-many in this case. And then I should have the same stock item key here. Boom, did it. All right. And you can see that the cross filter direction, single to both, I can apply that on these as well from this management, right? Now, the last thing I want to show you is inactive relationships while we're building our model. We're doing a good job. The last thing we need to deal with is our date table. There's going to be cases where your tables are going to need multiple relationships with the fact table, or maybe other tables. But a lot of the times it's with the fact table. I'll just give you an example. Is that you can see here that we have, and I know this is really hard to see probably. We'll just zoom in on this. So from my fact table, you can see that I have a delivery date key and I have an invoice date key. I might actually want to build multiple relationships between this. Why? Because I might want to compare when somebody ordered something as compared to when it was delivered. This way I can find differences or discrepancies on when somebody ordered something and when it was delivered. This could be for optimizing manufacturing processes. Now my date is usually because that's a whole date stamp or date time object, and that's what I will usually want to associate with this. In the table itself, if I went back into the table, you'd see that this is like a timestamp information as well as these delivery date and invoice date keys. So they should match up. But I'm going to need two of these. So I'm going to create one And I'm going to make this invoice date key my default or my active relationship, right? So it's active. I'm going to assume referential integrity. We're doing this to the fact table, and I think it needs to be a one-to-many in this case. And we'll hit OK in this one, and that'll create that relationship there. But I also want a relationship between that and the invoice so I can make a comparison on those, right? And it's kind of giving me a weird thing happening, but I think I could still switch this. Actually, let me cancel that. That looks a little funky. Maybe I need to do this from the, we'll try doing it one more time. Date to delivery date. All right, that looks good. So boom, boom. We need to switch that to one-to-many. The thing is that it's not going to let me make that relationship active, right? Because it already has that in there. So I need to go ahead and make that inactive. I'm still going to assume referential integrity on it, and we'll go ahead and put that in there. What I want to show, let me zoom out full again and pull this out a little bit, is how these are labeled differently. Let's zoom back in. So you can see that inactive relationships are identified by this dotted line as compared to a full line. So that's how we identify inactive relationships. So now we have our model, right? And we'll show you how, visuals are, how these apply to certain visuals and things like that. What I want to do is move over to some other, actually some reports that a colleague of mine created that really highlight the use cases for these, for the relationships on here. First, I want to talk about bidirectional relationships in particular. We talked about it in the content, but I want to show you what a use case is for it. By the way, thank you, Wesley DeBolster. He's the one that, he's another Microsoft technical trainer who developed these reports, and very smart, very intuitive about Power BI, and created these reports. So thank you for having this material here. So these bidirectional relationships, I think it's important to point this out. Now, if you can see here that our table, right, our table will contain a customer and a product and a sales. And the way it's built right now is that there's a one-to-many relationship between products and sales. So anytime this is going to filter into this, when I pick and this is a good use case, by the way, for bidirectional relationships. So when I have a country selected, let's say I want to parse through countries, what's happening is that because I don't have this bidirectional relationship associated with it, it's going to, this product part, since I'm only filtering into the sales, I'm not filtering back into products. So it's going to give me all the product options in here to select from a slicer. So if I'm in Australia and I pick hats, it's blank. There's nothing there, but the slicer still shows me it's available. And then if I pick jeans, blank. T-shirts, there's 30 of them. If I go to the United States, there's 10 T-shirts, there's 20 jeans, but there's no hats. Now, from a user perspective, that can be a little frustrating, right? Because it's not easy to use. I'm just getting blank values in here, and I don't want my user to experience blank values in my reports. So what we're going to do is we're going to go into the model view, and we're going to take this product, and I'm going to highlight the relationship here, and then I'm going to change this cross filter direction to both, and I'm going to apply the changes here. And this will create that bidirectional relationship. Happened really quick, by the way. But now when I go back into the report, side, and I click on Australia, you see what happened there? It removed all the values, or it filtered all the values out that have blank values in here. This is where bidirectional filters kind of play a good role, as if we have multiple slicers in here. The problem is the potential for ambiguity. I referred to, these relationships as roadways, right? So we got one-way traffic rolling this way, one to many. So traffic stops. First of all, the traffic can't go back in here. So I know that this table's protected from anything else filtering into it, at least from this direction. And this way now, the sales, since I've opened up the roadway, now we got a two-way path. What can happen is if I built another relationship between products, and what I see a lot is that we'll have a sales side. Usually there's a customer side and a vendor side. And models try to get created where we're trying to simplify the process of making a report for both possibilities in here for vendor side and sales side. Well, if I have products and then it's associated to a sales table, maybe on the vendor side, or vendor items or stock items or something like that, what can happen is that now that I have this filter open this way, if I build a relationship to another table going this way with a one-to-many, I'm actually opening up now this sales filter into that other table. And this is where ambiguity can happen. So typically, if you're going to build a bidirectional filter, make sure that the table is a standalone table or that you understand the consequences of building this relationship. Okay, that's all I want to point out there. Other thing I want to show is these DAX samples here, because again, Wesley DeBolster did a great job of just got to connect to my VM. Maybe it'll connect. There we go. All right. My Bastion isn't that great. I got a free Bastion, so it doesn't work that great. All right. So related. We talked about some of these DAX functions. Yeah, DAX. I know. I'm calling your name. It's all right. Go lay down. So we got related, right? So what related does is it actually retrieves the value from a one-sided relationship. Where does this come in useful? Well, let's say I want to see sales that don't apply to non-USA, right? Everything but US sales. I might have a different report for that. What I can do then, and this is reflected here, right? In fact, I might be able to pull this in, and if I select the visual, there we go. You can see that I got country, sales amount, and sales non-USA. Apparently there's a measure created somewhere in the sales table maybe that shows sales non-USA, right? And that's what this is right here. So it's a sales territory column to now where I can add that measure in to just get the sales of everything that isn't United States. So I'm just pulling in all the row related information not related with the United States. Awesome, right? Let's look at use relationship. By the way, if you've taken the Power BI course or understand DAX a little bit, then you'll know that calculate overrides any filter context that's been applied by default. So I can override that. That's why measures come in pretty handy to create other visuals, because now I can create a visual object based on a measure that I've generated, which essentially is what this is. You can see that, and the reason for this is because we have inactive relationships. I have a relationship between my date key, boom, boom, and several different things. But you also see that I have ship date key, and my active relationship is order date key. Well, what if I want to see sales by ship date, not necessarily by order date? I can override that context now by using my use relationship. So calculate overrides the filter, and then I've created this measure to essentially say use the relationship between the ship date key and the date rather than the order date. And that'll override that. And now you can see that I got the ship date, sales by shipping date created its own. And then I can see the sales amount in here. So for comparison, I could also create a, just sales by order date in here. If I wanted to create, let's get in here real quick. And I want to say, well, that's by month. Yeah, so I can see sales by order date. Since the default is the order date, this light blue one are my sales by order, right? And these are my sales by shipping date. So there's discrepancies happening here. The sales by shipping date, these are things that we need to look at to see why our sales by shipping date were different than our order date. It could be because something was ordered at the end of the month and it didn't get shipped till the next month. That's usually what you'll see discrepancies like this, but we want to make sure that we're finding out what the reasons are behind this. That's all about analytics. And then finally, we can, again, override a cross-filter relationship. So not only can we activate inactive relationships, we can override the cross-filter direction that was in there. And in this case, we're applying a bidirectional and overriding the unidirectional relationship between that. So a lot to cover about relationships. It's a really important concept because if you have bad relationships built into your model, your analytics are not going to be accurate, and your users are going to experience some crazy things. Bad decisions get made. A whole lot of bad things can happen. So model relationships are important. Back to the studio.
Great work, detectives. You just solved several mysteries related to model relationships. You learned how to set up and configure relationships between different tables of data, how to choose the right cardinality and cross-filter direction, how to activate or deactivate relationships using DAX functions, yes, DAX, and how to understand relationship evaluation and precedence rules. You also learned how to apply star schema design principles and how to use various DAX functions to work with relationships. Did I do good, DAX? DAX approves. Thanks for joining. Imagine you're a detective and have a case that involves optimizing a report by using various tools and techniques to improve its performance. You need to investigate how the report elements, like visuals and queries, are performing and find out the best ways to fix any issues that might slow down the report. You also need to understand how the data model works under the hood and how you can use tools like DAX Studio and Tabular Editor to optimize it. Along the way, you'll learn some best practices and tips to make your reports more efficient and user-friendly. You ready to take the case? Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Grab your investigative gear and let's get started. Here they are, our prime suspects. Optimizing your report solutions can take place at the level shown here. Typically, the data is through direct query, or we're relying on the data source performance in our models, then the data source is the prime suspect. The typical culprit is the data model, as there is so much opportunity for optimization there. Even visualizations themselves can be a suspect, especially when several visuals are associated with interactions or you have too many visuals in a report page. Finally, our environment assets like capacity settings and data gateway clustering and sizing can be suspects as well. Detectives always have their list of prime suspects handy, and as a formidable detective, you should too. Optimization is where real investigation takes place, and for that, we need our investigative tools. Let's look at our toolkit for Power BI report optimization. We'll introduce these tools as we move along through the case, starting with Performance Analyzer, then DAX Studio, and rounding it up with the Best Practice Analyzer, or BPA, via Tabular Editor. The first tool in our investigative kit we're looking at is the Performance Analyzer, which is built into Power BI Desktop. The Performance Analyzer helps you understand how report elements like visuals and DAX queries are performing. The Performance Analyzer is a great place to start when you're optimizing reports. Performance Analyzer displays and records logs that measure how each of your report elements performs when users interact with them. You can also see which aspects of their performance are most or least resource intensive. You can immediately see results, make changes, run the analyzer again, and see the impact of the changes that you've made. To use the Performance Analyzer, enable the Performance Analyzer on the View tab of the ribbon and select Start Recording. After you start recording, take actions on the report. For example, move from one report tab to the next, select a slicer item, or interact with any of your visuals. Any actions you take in the report are displayed and logged in real time in the Performance Analyzer pane in the order that the visual is loaded. The Performance Analyzer is looking at the time it takes for each visual to query the data model and render the results. This is the time from when a user does something on the page to when the visual is rendered in milliseconds. In the example below, 3 actions were taken after recording started. First, we navigated to a new report page. Second, we changed the slicer value. And then third, we cross-highlighted a table. Each visual's log information includes the time spent or duration to complete the following categories of tasks. If a DAX query was required, this is the time between the visual sending the query and for analysis services to return the results. Evaluated parameters provides the time spent evaluating the field parameters within a visual. Currently, this is a preview feature. Visual display provides the time required for the visual to appear on the screen, including time required to retrieve any web images or geocoding. Other is the time required by the visual for preparing queries, waiting for other visuals to complete, or performing other background processing. After you've interacted with elements of your report you want to measure with the Performance Analyzer, you can select the Stop button. The performance information remains in the pane after you select Stop for you to analyze. You can select Refresh Visuals in the Performance Analyzer pane to refresh all visuals on the current page of the report, which will gather information about all the visuals. If one visual appears to be performing slow, you can also refresh individual visuals. When Performance Analyzer is recording, you can select Analyze this visual found in the top right corner of each visual to refresh that visual and capture its performance information. As users interact with visuals and reports, DAX queries are submitted to the semantic model and cached into memory. Because of this, you may need to clear the DAX query cache to get accurate results in the Performance Analyzer. You can clear the cache by either closing and reopening your report or using DAX Studio. For queries with longer duration times, it's likely that a measure is written poorly or an issue has occurred with the data model. The issue might be caused by the relationships, columns, or even metadata in your model, or it could be the status of the auto date time option. You can save Performance Analyzer results by selecting the Export button, which creates a JSON file, not this one, containing the results. Now that we have found some potential suspects using Performance Analyzer, we can take those clues and then have them analyzed in DAX Studio. You can import the exported performance data into DAX Studio, where you can view, sort, and filter it. You can also bring a single query into the editor, where you can adjust the query to improve performance. What is DAX Studio, you may ask? Oh, looks like I've said DAX too much and my best pal, Dax, thought I was calling him. Sorry, Dax, false alarm. You can go lay down. DAX Studio is an open source tool for executing DAX queries against semantic models and analysis service models. DAX Studio is useful for reviewing the contents of your data model and even writing and optimizing complex DAX formulas and queries. You can download and install DAX Studio, and it can be launched from the External Tools tab of the Ribbon Power BI desktop. Calculations using DAX, either measures or columns, are a part of a DAX query, which is processed by 2 engines in VertiPack. The VertiPack engine delivers fast access to tabular model objects and data by using compression algorithms and a multi-threaded query processor. When a query is processed, the formula engine processes the request, asks the storage engine for data, and performs necessary calculations. The storage engine retrieves and aggregates data requested by the formula engine. In this diagram, the DAX query is sent to the tabular model in steps 1 and 2. The request is then processed by the formula engine and sent to the storage engine, represented by step 3. In step 4, the storage engine either retrieves the data from the model and stores it in memory for import mode, or passes the query onto the data source for direct query mode. For import mode, refreshing the data will retrieve the data from the source. Troubleshooting in DAX Studio enables you to see detailed statistics on the server timings of your query. You're able to view the proportion of time the query takes in each engine and can then adjust your queries accordingly to improve performance. But that's just one way DAX Studio analyzes our performance clues. Viewing the VertiPack analyzer metrics in DAX Studio is a great way to get an overall view of what's going on in your data model. VertiPack Analyzer reports the memory consumption of the data model and can be used to quickly identify where you're spending the most memory. In short, you can use VertiPack Analyzer to make memory gobbling offenders obvious, rectify them, and then rerun VertiPack Analyzer to see the immediate benefits of your data model updates. Viewing the VertiPack Analyzer metrics will only be helpful for import or composite models, since direct query models send the query back to the source, not VertiPack. You can look at the size of the table, columns, and etc. in bytes. The displayed sizes in bytes are evaluated prior to the compression. To view model metrics, launch DAX Studio from the External Tools tab of the ribbon and select View Metrics from the Advanced tab in DAX Studio. Viewing metrics in DAX Studio helps you immediately find and fix problems. For example, notice that the model in the image contains a table that's consuming 99.6% of the database memory. By drilling into the table, you can see that 2 columns, end date and start date, are gobbling up most of the memory. You can then fix that issue, refresh the metrics, and immediately see the effects of the changes on the model. Now, how can you be sure to implement data modeling best practices as you design and build data models? There's a tool for that. The Best Practice Analyzer, or BPA, in Tabular Editor can be used during the development of tabular models, in semantic models, and even analysis services models. Tabular Editor is an alternative tool for authoring tabular models. Tabular Editor 2 is an open source project that can edit a BIM file without accessing any data in the model. Tabular Editor enables users to easily manipulate tabular models and can be used in a few different ways. Some examples can be to quickly edit data models. You can automate repetitive tasks using scripting. You can incorporate DevOps with tabular models, and what we'll talk about here, run BPA rules. BPA is a set of rules run in Tabular Editor that notify you of potential modeling missteps or changes that you can make to improve your model design and performance. It includes recommendations for naming, user experience, and common optimizations that you can apply to improve performance. To use the predefined BPA rules, download the BPA rules JSON file from a GitHub repository. The rules are divided in categories like performance, DAC expressions, error prevention, and formatting. Each rule has a description, and many of the rules also have a reference article and video. Reading the rule description and article will provide context as to why the rule is important and why you should follow it. BPA rules can be run against tabular models in Power BI Desktop, SQL Server Analysis Services, Azure Analysis Services, or Power BI Premium. BPA was designed to enable you to create custom rules and best practices for your organization. If the BPA rules don't suit your needs, you can create rules required for data modeling best practices as you deem appropriate. You can also edit existing rules, disable and ignore rules, and set severity levels for each rule. Edits you make to best practice rules in this window will then be saved to the JSON file. If your organization has an established continuous integration, continuous delivery process, using Git, BPA can be integrated into your Azure pipelines. If objects violate best practice rules in the build, you can establish a process to either fail the build or proceed with warnings based on the severity of the violation. Enough talk. Time to put knowledge to practice. That's right, time to fire up the DetectoLab 5000 and get optimizing.
Welcome back to the environment, and we're going to talk about optimizing our models, whether this be through DAX manipulation or iterating through our visuals, utilizing tools like DAX Studio and then Tabular Editor to apply best practices to our model. So first, we're going to need a report in order for us to visualize this. I want to show this cool feature in our models is that I can actually take one of these models and I can auto create a report out of it. So let's do that. It'll let me pre-select the data out of here as well. So I'll just select all these in this model. And it's going to pre-generate a report for me. Now, it's probably not the most intuitive, but at least it's a good starting point, and it'll allow me to at least demonstrate what I'm going to do from the performance perspective. So now I can view this report, but more importantly, this gives me the opportunity to perform some performance analyzer on this. Let's see how the auto report did from a performance perspective. So what I'm going to do is I'm going to go ahead and save this and name this, we'll call it sample report 2 because I have sample report 1 in here. And now that I have this saved, I can actually download this file locally. Why do I want to do this? Well, I have to run Performance Analyzer in Power BI Desktop. I can't run it through the browser. So I need to open this up. I think this is also another good thing to point out is that we enabled large semantic models earlier. And if you notice, I can't import the data when I have large semantic model selected. Why? Because the model could be 500 gigabytes and then it has to download that entire file into my local system. So it doesn't do that. It only let me utilize a live connection, which is similar to connecting to like analysis services or something like that. So when I connect into Power BI Desktop, then I should be able to open up the report. The difference being is that it's going to make a live connection. It isn't like direct query or import mode. It's like connecting to an analysis services cube, essentially. We're going to open up this report though. And since I just downloaded it, it should be here. Boom. And again, this is just for us to run our performance analyzer on this. So now I got it in Power BI Desktop, right? I got Power BI Desktop opened up. I'm connected, logged in, I'm authenticated, I'm all ready to go. So where do I start running visuals, performance analyzer on here? Go into the view ribbon, and then you can see performance analyzer is right there. What you might have to do, again, is you may have to clear the cache out. If somebody has already been interacting with the report and you want to start Performance Analyzer, what happens is when a report is open, it starts caching that information. Now, there's a couple ways to kind of deal with that. I can go into my options and setting without actually closing the report. If I go into my options and I look at the data load under our cache, you could see that I have cache like 6 kilobytes. And that's usually because of interactions. I can clear the cache that way. I can close the report, open it back up. That'll clear the cache as well. Once I have that cache cleared out, let me move the performance analyzer over a little bit. Then I can hit the start recording button, and any interaction that I make now with the visuals are going to show up in this performance analyzer report. So I could select certain items within here, and you can see that since all of these visuals have interaction built into them, I make a selection on one and it filters all of them. This can cause performance problems. As you can see, there's all these different things it has to do just to perform that one operation. I can also, if you see this, analyze this visual, I can just hit that and it'll analyze that particular visual itself, just a refresh on it. Same thing with all these individual ones. I could monitor each one and see which ones have have the longest times within them. And then I can make a couple other, selections on here and get all this and get these times in. And you can also see that it creates every effect that it has when I make that interaction. These multi-card rows, probably these visuals are going to be the most interesting to look at, is that it gives me things like the underlying DAX query, how long it took it to run, how long it took the visual display for it to re-render, and then some other background operations that it took. Sometimes those are a little out of our control, but it only shows me what happened within it. Like a text box doesn't have a DAX query running into it, so it's not going to show that aspect of it. But there'll be different details for different ones, for different interactions that we make with this. And we can analyze each individual visual itself, right? So we just refresh the visual and it ran DAX queries and everything else on there. So now we can hit stop. We've done some analysis on this. And at this point, I can export this and it'll export it into a JSON file. I already have one here, but I'll go ahead and rewrite it. And then if I want to, maybe test out some alternative DAX functions, not you, DAX, you can go lay down. Not DAX functions, but try out different DAX functions that might work a little bit better than the one that we currently have implemented, or a different way of structuring it. Maybe break it up into variables and do it that way if we're finding a lot of things. There's ways to handle it, but we have to find out where we can do all this without really affecting the model itself and any of the visuals. It takes a long time to enter measures and have the visuals have it applied to the visuals. So I need a tool that allow me to do that, and that's what DAX Studio is. So I can open up DAX Studio. Once I install it, it actually shows up under my external tools. And then it's going to connect. Since I have a live connection, remember our model here is on a live connection. So it's got to go into the Power BI service to connect to this model. Once it does, you can see that it's connected to this. And now I can look at all my tables associated with this. You can see that it's all connected. And then I can do things like find my server timings with it. But what I want to do is I want to load this performance data. So I have that and I have my performance data. So now I can open it up and you can see that everything that occurred in there, everything that every interaction that I made and every visual that was analyzed, all the underlying DAX functions are contained within here. So now I can just copy the query, paste it in here, see what the results are from a timing perspective, and then manipulate the DAX queries to get better performance out of them. I can also go into server timings and see what the performance is on certain queries that I run. So if I run a DAX query in here, let's go back into this performance data real quick and see if I can, or maybe even get into, do I have a measure? Oh, in my fact cell, I got a couple measures, right? I don't see any here. Okay. Well, anyway, you can also run the server timings on that. Keep this demo a little bit shorter. A lot of content covered in that. But I can also get into here and run server timing. So if I have a DAX query that I want to write, I wish it would let me do this. I can run server timings on it. I don't think this is going to run very well, but you can see here is that it has my storage engine and the storage engine and the function engine that performs the DAX timings on this. And then it'll record it. I can stop it and get the results from that particular query to see where the performance throttling or issue is taking place. Is it happening in the formula engine or is it happening in the storage engine? I think I said function engine earlier. It's formula engine. So is it happening within the DAX formula itself, or is it from grabbing the data from the server? This is where server timings can help us help us get a better sense of where the actual problem in the query is happening to improve the performance of our visuals. All right, I won't save this, but what I am going to do is finally I'm going to open up Tabular Editor. And again, this should connect to the model once I have this. So now I have this live connection again. This will open up our model. And best practices analyzer is kind of what I wanted to show on this. Just under the tools, we have our best practice analyzer. And what I can actually do is add the file in here. I can manage rules. I can add, include rules from a local file. And then it'll open up my browser. And I think in my desktop, I have the BPA analyzer here. Yep, BPA rules. And it's a JSON object. So what happens is now it's applied all these rules in here. So these are best practice rules from this JSON file. Now I don't have to keep all these. I can keep all these rules. And what'll happen is that it'll do certain things based on the rule that's applied to here. And a lot of this has to do with referential integrity and some other things contained within here that are going to help make our models run the best out of the box when we apply these rules to them. But I can go in here and I can change rules, like I can select rules, I can change them if I wanted to. But it's always good to have that best practice analyzer in there, because now that I got the rules in here, I can take the effective rules and then I can select certain ones that I do or don't want to apply into this and edit those out. And then once I save this, it should save it to the model and when I publish it back to the service, it'll include all those best practice analyzer rules in here. So the next time somebody opens up the report, it'll be managed by those best practices that we implemented. And that JSON file is located in GitHub. All right, so I think we did a good job of just covering some of the basics of optimization, looked at Performance Analyzer to perform analysis on our visuals, take that information, move it into DAX Studio. From there, we can test our queries out, try to improve them from there. We can also perform server timings on the queries, see what's happening from the formula engine and the storage engine, where the root cause of the problem is with that particular query is happening, and then being proactive and applying best practices before we even get started with our reports, applying these best practices to our models in order to have our models work really good out of the box. All right, back to the studio.
Great work, detectives. We covered optimizing reports by using various tools and techniques. You learned how to use the Performance Analyzer, DAX Studio, and Tabular Editor to investigate and improve the performance of your data model, DAX queries, and visuals. You've also learned how to use the Best Practice Analyzer to check your data model against a set of rules and best practices, and how to customize and integrate BPA into your continuous integration, continuous delivery process. Thanks for joining. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Our focus here is on how to use tools to design and secure your data models, and how to apply best practices for performance and scalability. You'll learn how to use features such as row-level security, object-level security, star schema design, and XMLA endpoints. By the end, you should be able to create data models that are robust, reliable, and ready for any challenge. Ready to start unlocking clues? Let's go. Our first case to crack revolves around access to data in a data model. There are two approaches to protecting data, and we'll investigate both. Let's dig into the case of the two sides to data access, starting with row-level security, or RLS. As a data modeler, you set up RLS by creating one or more roles. A role has a unique name in the model, and it usually includes one or more rules. Rules enforce filters on model tables by using DAX filter expressions. The animated image generally shows how RLS works in your model. By default, a data model has no roles. A data model without roles means that users who have permission to query the data model have access to all the data model. It's possible to define a role that includes no rules. In this case, the role provides access to all rows of all model tables. This role setup would be suitable for an admin user who's allowed to view all the data. You can create, validate, and manage roles by using several tools depending on where the model was created. For models created using Power BI, you can use Power BI Desktop. For Azure Analysis Services or SQL Server Analysis Services models, you can create, validate, and manage roles by using SQL Server Data Tools, SSDT. You can also create and manage roles by using SQL Server Management Studio or by using a third-party tool like Tabular Editor. If you've been following this video series from the start, how many times have I mentioned a star schema as a best practice? Must be pretty important, huh? So again, we recommend you apply star schema design principles to produce a model comprising of dimension and fact tables. It's common to set up models to enforce rules that filter dimension tables, allowing model relationships to efficiently propagate those filters to fact tables. All right. Back to roles. There are different ways of defining roles, and let's investigate. Rule expressions are evaluated within row context. Row context means the expression is evaluated for each row using the column values of that row. When the expression returns true, the user can see the row. You can define rules that are either static or dynamic. Static rules use DAX expressions that revert to constants. Defining static rules is simple and effective. Consider using them when you need to create only a few of them, as might be the case at AdventureWorks, where there are only 6 US regions. However, be aware of disadvantages. Setting up static rules can involve significant effort to create and set up. It would also require you to update and republish the semantic model when new regions are onboarded. If there are many rules to set up and you anticipate adding new rules in the future, consider using dynamic rules instead. Dynamic rules use specific DAX functions that return environmental values as opposed to constants. Environmental values are returned from these specific DAX functions. Username or user principal name returns the authenticated user as a text value. Custom data returns the custom data property passed in the connection string. Non-Power BI reporting tools that connect to the dataset by using a connection string can set this property like Microsoft Excel. Defining dynamic rules is simple and effective when a model table stores username values. They allow you to enforce a data-driven RLS design. And as quickly as DAX appeared, DAX is gone. Must mean it's time to move on. When you create roles, it's important to test them to ensure they apply the correct filters. For data models created in Power BI Desktop, there's the View As function that allows you to see the report when different roles are enforced and different username values are passed. You can also use Tabular Editor and its impersonation feature to test roles in the service. Now that we have roles and tested them, we need to map some of those roles. Even though we can create dynamic roles that can restrict access based on login, some roles, especially static roles, need to be applied to users. Role mappings must be set up in advance of users accessing content. Role mapping involves assigning Microsoft Entra ID security objects to those roles. Security objects can be user accounts, group accounts, or security groups. When possible, it's good practice to map roles to security groups. That way there will be fewer mappings, and you can delegate the group membership management to the network administrators. For Power BI Desktop developed models, role mapping is typically done in Fabric. For Azure Analysis Services or SQL Server Analysis Service models, role mapping is typically done in SSMS. When your data model has direct query tables and their data source supports single sign-on, the data source can enforce data permissions. This way, the database enforces RLS, and the model and reports honor the data source security. Calculated tables and calculated columns that reference a direct query table from a data source with single sign-on authentication aren't supported in Fabric. That solves the first part of our case. Now moving on to object level security, or OLS. DAX won't be involved in this one. As a data modeler, you can consider restricting user access to model objects. Typically, you apply OLS to secure objects that store sensitive data like employee personal data or social security numbers. When OLS is enforced, not only does it restrict access to tables and columns, but can also secure metadata. When you secure metadata, it's not possible to retrieve information about secured tables and columns by using dynamic management views, or DMVs. OLS is a feature inherited from Azure Analysis Services and SQL Server Analysis Services. The feature is available in Fabric and Power BI Premium to provide backward compatibility for models that were migrated. For this reason, it's not possible to completely set up OLS in Power BI Desktop. To set up object-level security, you start by creating roles. You can create roles the same way you do when setting up RLS. Next, you need to add OLS rules to the roles. You add OLS rules to a model by using an XML for analysis, or XMLA endpoint. The read-write endpoint supports dataset management, application lifecycle management, advanced data modeling, and more. With XMLA endpoints, you can use a client tool like SSMS and third-party tool options too, like Tabular Editor, which is an open source tool for creating, maintaining, and managing models. This will be your go-to for default semantic models in Fabric Lakehouses and warehouses. Once you've added the OLS rules, you can publish the model to Fabric. Use the same process for RLS to map accounts and security groups to the roles. In a report, when a user doesn't have permission to access a table or column, they'll receive an error message. The message will inform them that the object doesn't exist. Consider carefully whether OLS is the right solution for your project. When a user opens a report that queries a restricted object for them, the error message could be confusing and might result in a negative experience. To them, it looks like the report's broken. A better approach might be to create a separate set of models or reports for the different report consumer requirements. There are restrictions to be aware of when implementing OLS. You cannot mix row-level security and object-level security in the same role. If you need to apply RLS and OLS in the same model, create separate roles dedicated to each type. Also, you can't set table-level security if it breaks a relationship chain. However, model relationships that reference a secured column will work, providing that the column's table isn't secured. Lastly, while it isn't possible to secure measures, a measure that references secured objects is automatically restricted. Case closed. Before we wrap up the knowledge part, let's cover some modeling best practices, the icing on top of the knowledge cake, if you will. It's critical that your model enforces data permissions correctly and efficiently. The following list provides you with good development practices to apply. All are pretty self-explanatory. The main points to take away is less is more, model design is vital, and test and validate, then possibly test and validate again. Time to fire up the DetectoLab 5000 to apply our data access principles to practice. Let's jump in.
All right, back in the environment, and we're going to talk about security from row level security, object level security, so that we don't, so that we're providing least privilege in our reports as users are logging in and consuming them. But there's a lot more to it than that, and I kind of want to dig into that a little bit here while I have the opportunity, because applying row-level security is kind of simple in the tools, but I want to point out the differences between live connection and our other import modes, because we're dealing with direct lake when we're working with Fabric objects as the storage mode that it's working with. And then when we create Power BI reports in the Power BI desktop, we have import mode and direct query mode and the ability to create composite models because of that. Direct lake works a little bit differently. It's more of a live connection than like an import or direct query mode. So I want to show you how that affects particularly working with roles in these services. So there's a whole bunch of different places that we're going to be able to manage roles at. And it depends on the type of mode, storage mode that you're involved in. So what am I talking about? Let's just dive in and kind of show this. So I've created not my default semantic model, but I've created semantic models outside of that default semantic model. One of the ways that I can connect to or manage roles is to run it through the service itself. So if you see here, I have this test model 1, and if I open this up and then open up the data model, here I can manage roles through here. Now, why does this make a difference? Why I can manage roles? You can also see I can create DAX measures and calculation groups from the service itself, from the Fabric service itself. So that's awesome. But I can also create roles. I think I have one in here. Sorry, my Bastion host is a little finicky sometimes, but that's all right. No, don't have any in here. This is test model 1, so I can manage the roles from there. Why am I bringing this up? Well, here's the deal. If I were to go to Power BI Desktop and I could open up a new report from this model, because I have the model published in the service, but I want to show the effect of what a live connection has on these models. So if I hit new and I want to get my data from a Power BI data set, which should be semantic model, you can see that test model 1 is in here, and I can connect to this. But this is a direct lake model, meaning that it's a live connection. So when I go into my modeling view, I can't manage roles or view roles from the Power BI desktop, which might be a limitation for this because it's a live model, direct lake. So how can I get around that? Let's go back into the service and I'll show you. Actually, I can go into this report and let's go back home. And what I can do now is if I wanted to, I need to close out of this and open up a new one. So we'll open up a new report. We'll open up a new report and then we'll get data out of this one as well. Because remember, I can not only connect to semantic models that are available online through the Power BI service, I can also get it from the resources themselves. So if I went into my Fabric resources, I could connect to a Lakehouse or a warehouse, right? So let's look at this because there's different options that I can utilize for each one of these. So it gives me my sample Lakehouse, but I want you to see this drop-down menu. I can connect to this, and if I use this, this will do essentially the same thing that the model did earlier. That's just connecting it as a Power BI data set. It connects as a live connection. What I could also do is connect to the SQL endpoint associated with the Lakehouse. And this will provide me the ability to define the data mode, which means then I can change it to a direct query mode once I've put the data in here. And it essentially acts like any other SQL server that I'm connecting to. Then I have the ability to manage roles and do things like that because I have a direct query connection as opposed to the direct lake connection. So I want to point that out because that's going to affect the way that you're going to work with roles depending on how you open up the report and add your data in there. Because, one of the options here to view the roles and to manage the roles is through Power BI Desktop. Now they're incorporating this into Power BI Service. So like I mentioned on the service itself, I can go in here and manage roles. And that's what I'm going to show you what I can do here through this end, right? So there's two different types of roles that we can apply. There's static roles, and what I can do is I can apply these into, my a certain maybe if I want a city and I can choose the column, like I want to make sure that the sales territory equals Great Lakes, I think is one of the territories. And this is awesome, by the way. And then I can save this and it's an untitled rule. Let me go ahead and name this. I'll just name it static for right now. All right. And then I'll save this. Now, one of the cool things about doing this, making rules or assigning roles, RLS roles in the service, is that I can assign them in the service now. A role is just a parameter, so to speak, until we apply it to somebody in our tenant, which are usually email addresses. Now, these could be clients that have specific email address as long as they have access, like read access into the workspace. But I think I have some individuals in here. So I got Gary Gumshoe, if you remember, and I got VD Vigilante. So I can add these users, or I can add groups, or even better, I can add security groups to these particular roles that are in here. So what'll happen is that now that I have this static role, I'm assigning anybody that's in the Great Lakes territory to this role, right? So all they're going to see is the Great Lakes information if I set up my relationships right, because we're filtering that information from that Dimension City table and saying, okay, if you're signing in here, all you're going to see is Great Lakes information, which is fine. But I have the role. I think I have the role saved. Yes. So now there's another way and that's great, but now I have to create new roles for every region. And if I don't want just region, I want to do something else, and I got to create roles for all that and then assign them. And you can see how that could be a lot of work. What I can do instead is create what's called a dynamic. Now, let me try to get some real estate here so you can see what I'm talking about. And unfortunately, the data set that I'm working with doesn't have this in here. If you go through the labs and in the online content, it will kind of take you through this. Now, if I had my employee key, now we were setting up roles for our employees, right? What I don't have in my employee table here, I guess I'm all the way through, is email addresses. Let's say I had a column in my employee table that had email addresses, and it was just a column called email address, right? What I could do now, we're just assuming this, that I have a Dimension employee column called email address. What I can do now is use a DAX function called user principal name. And we'll call this one dynamic. I'll just rename it to dynamic. And I'm just going to show you, I don't have an email address column on here, so I'll just make a column up. But what I can do now is, let's say I want to filter, the territory out again, right? Or I want to filter Dimension. I want to filter everything that's in this Dimension City by, or I'm sorry, the employee. If I had the email address in here, I'll just use this employee equals, and then then I can use user principal name. There we go. So if I go back to into the, it's not showing me what it's saying here, but now I can use this user relationship. And then I could use the employee if I wanted to. my dim employee, if I wanted to apply that to the ID, right? And what I could do is I could filter this out and just put whatever column I want to in here. So it could be in the employee column, or I can make it a customer column, or whatever. You know, what I'm doing is I'm dynamically filtering this. Now what it's going to do is when somebody logs in, it's going to look for their email address, and then it will automatically look through all the column values that are associated with that, and it'll look for, okay, so Dimension City, you know, if I'm looking for a certain, you know, that sales territory in the Great Lakes, what it's going to do is it's going to find that because that territory is included in the employee information, what sales territory they're in, it's going to automatically filter that information by them. So now I don't have to apply this to every member of the group. It's going to run this by their email address. So it makes things a little bit easier when we have to add a lot of users to a single type of role, so to speak. Other than that, you can use both options in here. So that's applying role level security. You can do this in Power BI Desktop too when you have, if you're using, you know, import direct query, composite models, you can bring those into Power BI and use, you know, the same interface, so to speak. It's just not here in the service. It's on Power BI Desktop. You can utilize that as well. What I do want to show though, however, is applying object level security. So let's go back into the report that I have that I think I had connected. All right. Do I have, no, this is not, doesn't have any data in here. This one does. So what I'm going to do now is I'm going to open up and show you object level security. Now you can't apply object level security within within Power BI Desktop itself or the service. You'll have to use XMLA endpoints. I guess a good thing to point out is where that's available at. So let's go back into my workspace here. And if I go into my admin settings, I can go into my capacity settings. And then from here, I should be able to enable a XML endpoint. Oh, in the settings. Maybe it's not in here. Export and sharing. Here we go. Integration settings under tenant settings. Allow XMLA endpoints. That needs to be in there. And then I'm pretty sure under capacity settings, there is a read write setting that needs to be changed on here. There it is. Power BI settings, Power BI workloads. I'm sorry. So our semantic models, you can see here that my XMLA endpoint for this particular capacity is on read write. By default, it's a read. So what we need to do is make sure that that's on read write if we're going to use third-party tools in order to apply changes to our model. So once that's enabled on read write, right, then I can use third-party tools to manipulate this data or manipulate the model and then push it back into the service. And that's essentially what Tabular Editor does for me. Now, again, when I sign into say I'm not authorized. Yep. Yeah. Azure. Let's see, test model 1. I think that's what we were working with. There we go. So now you can see I'm connected to it. This is what the read XMLA allows me to do. It allows me to read this into this particular service. Now you can see that I have a static role already created, this dimension city. So that's already in the model. I created this in the service, but you can see it's been applied. And you can see that sales territory equals Great Lakes. That's under that particular column. The other thing that you might notice is that there's object level security that can apply. So this is at a column level, right? By the way, your model permissions should be on read in order for these roles to actually take effect. So if you're going to work, by the way, you can do RLS and tabular. I could apply dynamic rules or static rules into any one of these using tabular editor. I'm not limited to just using OLS. In fact, I would recommend that if you're going to apply both object level security and row level security, because you can't combine them. You can't combine roles into both. It's got to be one or the other. So this is a good way to kind of manage that aspect of things. But what I can do is now I can change row level. I can create a new role, right? So I can create a new role. We'll call it OLS example, just so I show you. And now that I have this role here, I don't have any RLS or OLS enabled on this, but what I could do now is I could go in and select some of my objects in here and say I could read this, or I don't want you to do anything with it. I don't want any permissions between this and what this object level does. So what'll happen is when if somebody is associated with this role in service, tries to open up this report, this particular table will be unviewable for them, right? And that's what we're setting for table permissions in OLS. All right, so that's one way that we can define object level security. We can manage row level security in here and save that as well. And I also showed you where you can apply those, assign those models, assign the roles to the models through Power BI Service. But we can also come into here and go into security now. And I can also apply those to my users for that particular role. My static role, it doesn't have any users applied to it. So I can apply Gary to it. I'll add it. I can save it. And I can even go in here now and I can test in the service as that particular role. So I could open this up and make sure Gary is assigned to, if Gary was in there, he would be assigned to he would only be able to see the Great Lakes data. So I won't be able to see any other data in the report that contains to any other sales territory besides the Great Lakes. There's some other things I need to set up. Gary isn't really a real user. He's a sample user, so that's why it's not really working here, but hopefully you get the gist of it. That's security in a nutshell, nuances between direct lake and other modes. So be aware of that when you're working with row level security and object level security. Utilize Tabular Editor, get familiar with the tool. You can even test roles in Tabular Editor. So it's a very dynamic tool to be utilizing to update your models. Let's head back into the studio.
Nice work. We learned a lot about how to secure our models using row level security and object level security. We also seen how to use other tools to manage and test our roles and rules. And remember, as Sherlock Holmes once said, there is nothing more deceptive than an obvious fact. So don't be fooled by the data, look for the clues. Thanks for joining. Hello, my name is Jason Richards, Microsoft Technical Trainer and Data Detective. If you plan on earning your certification in the Microsoft Fabric Analytics Engineer, or DP-600, This video will provide you some great resources to help you prepare for the exam. Let's start with the study guide. The study guide will help you understand what to expect on the exam and include a summary of topics the exam covers, with links to additional resources. The page also includes study resources where you can find self-study options, classroom training, as well as links to documentation, community sites, and exam prep videos. The information and materials in the study guides will help you focus your studies as you prepare for the exam. The study guide for the DP-600 can be found at aka.ms/exam prep, then navigate to study guides. One of the best resources to help prepare for the exam is the practice assessment. With it, you're able to assess your readiness, determine where additional preparation is needed, and fill knowledge gaps, bringing you one step closer to the likelihood of passing your exam. Practice assessments will provide you a score report that provides the answer, rationale, and links to additional information for every question. Practice assessments are available at no cost and can be attempted as many times as desired. You can access the practice assessment for this exam by navigating to aka.ms/exam prep. When you're ready to schedule your exam, begin with the certification overview page and click on the Schedule Exam button, and you'll be redirected to verify your information in your certification profile, and will then be redirected to the exam provider site where you can select to take the exam online or at a test center location. Be aware of any additional system requirements for taking online exams. If your personal email or any associated emails in your loan profile qualify for discounts, this is where you can check and apply those. Additional information can be found at aka.ms/DP-600 exam. The number of questions on a certification exam is subject to change as Microsoft makes updates to ensure it aligns with the current changes in the technology and related job rules. Most Microsoft certification exams typically contain between 40 to 60 questions. However, the number can vary depending on the exam. Exam time also varies based on the type of exam you take. For more information on the exam experience, you can go to aka.ms/exam prep and navigate to exam duration and exam experience. We really hope you had a great experience in this series, and your perspective is always welcome. Good luck and best wishes in everything you do. Thanks for joining.